是啊，今天做得很好，我需要，现在做出来，很给他说。快了，6天了。对啊。好的，明天要回去了。又要升职了。做工啊，太多东西了。哎呀，我就想快点回去了。那都再回去想到了。Yes, quite fast. So fast. You brought it up. Okay, yes. Morning. Morning. No sleep. No sleep. So you last night. So fast. Okay. Right? Yes. So evaluation form, just I need to fill out the information form. Yes, I need to fill out the this is all evaluation form. Just have to fill it out before it's okay. And on 12 o'clock you receive a digital copy of your certificate, including the promo code and everything like that. Okay. Make sure the promo code really because it only had expiry is only 30 days. Oh, okay. So better redeem it before that. And it's all the content is for the papers. Okay. You can sign more than that. The Udemy one and the Shopee one, the Shopee code is 15 I give it to you guys a voucher. And if you want any software, you can go to my mobile page in Shopee. Okay. Any software, video courses. I have all. We use the copy of Fiverr and Shopee. No, the main reason I know what I'm doing is not exactly right. The main reason why I'm doing that is because I'm trying to help students. Students cannot afford this type of license. install. It's very straightforward to install this software. Actually, it's not. There are certain processes you have to go through. You need to configure the Windows first. You need to configure the net framework. You know what is net framework? No. You must configure that, and then you must make sure update your Windows first. Configure the net framework, and then check your system requirement, everything is compatible or not. Then only you can proceed for the installation. And the installation will take 40-50 minutes. But they complain. No, is it taking so long? Because you're using a hi-fi processor, obviously. Okay. I mean, the evaluation won't take your time. Okay. And if possible, since 2012 until now, we managed to survive this far because of Google review. So give us a review because like I said, the first day of the training, consultation is free. You want to keep remain free, give us a Google review so we can survive. Okay. And later on, after the class finish, we'll take a group picture with the certificate.
Usually the fighting is on another stage.
Yes.
This is like industrial center.
Do you know Global Earth?
Yes.
Global Earth, Mr. Chairman.
I'm familiar with Global Earth, but not actually the people inside.
Oh, their boss, Mr. Chairman.
No,
They're doing that project. Yes, we're doing the project, yes. We already came.
I'm actually, you are more into HVAC, right? HVAC.
Refrigeration system.
Refrigeration.
Yeah, the R507, the R222, R404, CO2, we take out the refrigeration system.
Do you have WhatsApp number?
Yes. Then in the business person.
I have WhatsApp.
No problem.
I'm using the top number is my WhatsApp number.
Okay. Yeah. It should be good. The whole color.
Yeah. That's the way.
Yeah. The top 10 features. Yeah. And it's full of boss.
So today we continue with the motor programming.
Okay.
I do. First, I will connect the motor with this PLC. So this one. This will be okay. Yeah.
So green.
Then we do some wiring. Yeah? I will show you the wiring. So this drive, we want to control using the terminals. Okay. Normally drive you can on off using this, right? You can on off using the terminals, or you can on off using the communication. Okay, so you can use RS485 communication. Okay, you can use the modbus communication. Right? Okay. But we want to use the just on off and analog control. So this two is the S1, S2. You can see that S1, S2. It's the forward backward. Okay. According to the wiring diagram. So forward backward. Then you have analog in, analog out. AI, AO, right? The white cable. Okay. Then this is the COM for the AI, AO lah. Means the 0 volt lah for this. Okay. So because AI, AO must have always two cable analog. Positive, negative. Because the range, right? Okay. So for both AI and AO, they use only one. So they share. Inside that, okay? One common. So
Right, also depend on the module.
yeah, normally one only. Normally common. Okay. So what I did is from here, I connect here, I make it into 4 cables. Means the COM, I loop it.
Okay.
Okay. So means the two analog output, right? Means from here must be input. Right? This is output, here input. Here output, here input. Okay. So I take out the 2 cable, I connect it.
Okay.
Okay. And from here I connect it. So that's why I need 2 cables. That's why the COM I loop. Okay. Then actually that's why this 4 enough already actually. Okay. But my S1 and S2 I must give 0 volt according to this drive.
Why?
According to this drive.
Oh.
This drive connections. Okay.
It's like a ready signal.
On off. Forward back. Okay, but it's very this one, right? Because this book was very small book. Okay, so you see the COM I say 0 volt, right? Okay, so can you see they use the COM to the input S1, S2. Right? Okay, means this one and this one I must give 0 volt. Okay. So, but my output here is 24 volt, correct? Directly cannot connect. That's why I use a link. Because this is 0 volt, my output is 24 volt.
Okay.
I directly cannot connect, correct? Okay. So I use a relay.
Adjust.
Yes. So my output will energize the relay. Then relay will give the 0 volt
To this.
Yes.
Okay.
Okay. That's why the 0 volt is here. Then this is for the relay activity. On off the relay. Okay. Okay. So we do some further.
COM is 0. Positive is 0.
Yeah, because they mentioned that, right?
Yeah, correct. And here we need to put the COM. This one put the COM. COM follow the COM. AI is a COM. AO is a 24.
So AO here, here is AI. So AO, the white cable is the positive, huh?
Yeah.
So
AI one is a positive, right?
you don't see this one. And not because it's the you can choose voltage or milliamp.
Okay.
So there's a 3-pin, can you see here? 3-pin, yeah. So this 3-pin you can choose which one you want to use. If all the 3-pin is not connected, it's a 0 to 10 volt.
This connector is 24.
First and second is connected is 24 volt. Second and third connected is a milliamp.
Connected is mean like what?
This is connected.
Oh,
It's a jumper.
jumper lah. Okay. But this one cannot be jumper. First and third.
Can this one because it's here it's a 2 volt.
Okay.
So if you connect the first and second, first and second.
And first and third. This one is first and third, right?
No, first and
Oh, sorry.
second.
Okay, okay. I thought it's first and third.
So here output means here input, huh? So I connect to the second analog input. We have right. That is the positive, lah. Okay. So the negative. So the negative means the 0 volt, lah. COM, right? COM.
And you got
No. First must go to the analog COM, right?
two, M is in the Siemens, M is a com.
Yeah, 0 volt.
Okay.
So I share with this guy.
Okay.
So what I do?
Can I say that com must be 0?
Yeah. So from here output, okay, go down.
Do you have class to teach regarding the communication?
Communication.
Like advanced, is advanced. Like I-45.
Yeah.
I
It's like a special request lah.
I-232, I-45. How much one? It's two.
Yeah. My serial.
How about the
Actually got two.
yeah communications? And how about the IP address between the internet?
It's a TCP.
TCP. Also in the advanced mode.
No, we are doing this communication, right? But our communication is more to TCP communication, Profinet communication.
Yeah.
So if anything, it's like a special request. Like it's depend on the PLC. Okay, let's say you come for training for Omron. Omron, okay, we mostly use RS-232. So you come for this one, we use Ethernet. You come for 300, we use the Profibus.
What's the name? Profinet, Profibus. It's mean what? It's a RX-45.
Profibus is a 485. Profinet,
No. Profinet.
Profinet is there. In Siemens.
Okay. Maybe only two lah.
Yeah, or Siemens.
Profibus is
Then you see output. Here output 0 and 0 light. Right. Okay. Yes.
Input rule color.
Yes, correct. Put the blue comma. And this one is the control.
One question. Let's say PO to the driver. One line intercom go to two. I'm only using two cable using the terminal to separate.
Normally yes. Okay, that's the in the machine with MSF terminal to separate. You input like this two cable going. Or normally what we do that we just form right, so we know it's a 0 volt right. Just a 0 volt right. So using the same power supply right. So the 0 from here 0. Go here, from here I jump to here, from here I jump all the 0. others also. Okay. So we connect all the envelopes. Now I want to connect the relay. Okay. So what I do, I use the last two. Okay. So number 3 and number 4. Okay. So number 3 go to number 4 go to the relay 1.
Number 4 go to relay 1.
This is for the relay coil.
Relay 1 is
S1.
S1. S1, S2 is relay.
No. S1, S2 is the input.
They are input.
But my input is
0 volt.
0 volt.
So you need to convert.
Convert to use relay.
Because now your output is 24.
Yes.
And then output 5.
Now 4. Then, okay. Here is this one going to the coil lah, right? This one is positive, right? Positive. So the core must be
Column is monochrome.
no for the relay lah. Relay must have positive and negative. Right? So I already supply positive. Then I need to supply the negative. Then only get negative. That is the core lah. So this one I can take from here.
Here also is positive.
No, here I already finish it. I put 0 to 2. Okay, because I have 3 cable, right? One is going to the discoms. Okay. Then the other 2 is one is going here. Go to the S1. Another 0 is going to the S2. Go to the S2. This one.
I don't know.
You understand the concept? You don't see this wire.
This one concept I understand. But I need to know if they say like how to check which one is output, which one is input or which is a relay supply.
1340 is the coil.
1340. 1340 is the coil. Which one is 13? Which one is 14? Oh, follow the number.
Yes.
So here is a termination. This one is output.
No, there's no input output. I mean 1340 here is the power up.
Okay.
Then can you see the contact? There's a normally open and normally closed contacts.
The-
Four contacts. What number? Tell me the number.
11, 21, 31, 41.
See this number. 11, 1, 5. This is one contact. 21, 6, 2. This is another contact. So I use the 11 and 5.
11 and 5.
It's an open contact.
Close contact is 11,
And
12.
1.
1 is here.
This is the 5, right?
Now,
This is the 1. Oh, you mean the bracket is 9 lah, right? You see the bracket,
See the bracket.
So 9 and 5. So this 0 volt, right? Go to the number 9 and number 9. Okay. And number 5 is the open contact. I go to the S1, S2.
Okay, when energized open,
Yes.
coil 13, 14. Coil is for
Energize the relay.
energize the relay. Means like the line, you give a
0 volt.
0 volt.
So it's standby. So if I give the positive negative here, the this one will energize. Then it will become a close contact, right?
Okay.
So the line will supply whatever voltage here to number 5.
Number 5.
Then number 5 I'm using to connect.
Oh. Okay. It means like here need to power the coil. Just want to energize open the supply to you.
Yes, do the open close.
Maybe if let's say here we put the below work, come out also the below work. If you here put the below work, here come out is the below work.
Yeah.
Okay.
Number 9 is connected to which one?
Number 9.
Yes.
Zero.
Zero.
0.
Okay.
Because number 5 I connect to the S1.
Okay.
So number 9 is 0.
9 is 0.
So 9 and 5 is the open contact.
Okay.
Okay, so when we energize, it becomes closer. Push button lah, right? So the signal goes here. Okay, yeah.
Just want to energize only, to open something.
Yeah, that is the function of the relay.
Like for example, we want to open up the contactor.
Yes, yes, yes. Okay. Yeah. Continue. Yes.
Here is 0 separate again. Here also 0. So we connect to here. So here.
Yeah, because I need to give 0 volt here, right? Then only the 0 is to the S1 is to by supply here. And this COM also needs 0, right? So I take 0 from here. All these are reduced by now. And from here I just jump here. This is supply for the release.
Com is always have not current, it's always on one.
COM.
What I mean like, what I mean like,
For example,
here the com, go to this, okay, standby, do the energize, com, go through here.
go to S1,
That's what I do. It's then it's coming out. I mean, whatever the supply you need is based on
Number 9.
what we connect.
Yes, correct.
Like for example, this one is request 24 volts.
Yes.
Here we need to standby 24 volts. Then after that, here is controlled by our PLC.
Yes.
Output.
Mm.
If output say that I need something to on, then the on pass through.
Yes, correct. Okay, good.
Yes. Here is the output. Right? For example, here connect to the output. Right? One is a 24, one is a 0.
Yes.
And 24, if I have this is the first output, Q0. So this one connect to Q0.
Yes, yes. Okay,
Yeah.
yes. So when you want to run, so you do some settings lah. Okay, I do a basic settings lah. Don't go to the functions lah. Okay, so we will be doing the run command. Who run? Others all is a factory setting. Okay, the most important run. So who run? Keypad, this one, or terminal, this one, or the communication, that is the RS485. Okay, who run on and off. So we use what? Terminal, right? F02, this one, 01, right? What number? 1. Okay, then this one, factory setting. Then who frequency command, who control the speed. Okay, Z keypad, okay, AI1 or AI2. Got AI1 and plus 2, but this one got AI2 only lah. Because this one got small big also. This manual is for the small and also big lah. Okay, multi-step speed, or PID communication or communication. Okay, so we are using the AI2, right? So, right, so I put 2 there. Okay, and AI2 means this name for this is AI2 because this this one have a big and small. The big one got 2 analog inputs. This one only 1 analog input. So they name it as the AI. Okay. Then number 4 is the maximum frequency lah. 50 yeah. Then number 5 is the upper frequency 50. The lower frequency is 0. This one is a keypad lah. Keypad that's what it's 20 right? Keypad. This one is a 20. Means if the frequency command I choose keypad, the drive will follow what is the value at the here. Okay. Then the acceleration and deceleration time. So I just 2 seconds to ramp up, 2 seconds to ramp up. That's all. The rest all is the factory setting. Default. Of course, then you need to do some this one lah, the motor power. Need to set the motor. Depend on this, depend on the module lah. F201. Okay, motor rated power. It's a 0.25. Okay, so maximum 0.3 kg lah. Okay. Then 202 rated frequency. Motor frequency 50 lah. Okay. The rated speed is the 1350 RPM. 230 volt. Okay. Because I connect 230 volt now. This driver. Okay. And 204 is the rated voltage. 230 volt. Okay. Then current. Current is how much? They got 1.45 right. So 230. The rest all okay.
You can put more about motor less. The level number 25, motor 45, you put 1.5.
It's not 1.25, 1.45.
Yes.
So the nearest is 1.5 lah. Right. If you put 2, okay, but the motor won't run at the maximum frequency lah. Here it will show 50 according to your setting, but the maximum if you measure here, it won't run RPM.
They mean if they will based on 2 to do the
Yes.
hertz.
Yes. Based on so what I say, how it works, very simple. This one we give a voltage to here. Based on our settings, this one we give the voltage. So if you do put a lower settings, here it will show 50. The motor will run, but when you measure, it won't get 100, 1350 RPM. You get a lower RPM. Okay, done. Good. This is the one. Yes.
So we are using Omron
AI.
In the parameter setting, we choose AI2.
Yes.
AO.
No need. No.
No need.
Because it's feedback, right? Feedback no problem. So because AI is the set the speed. So according to this drive, this model is the AI.
So the feedback AO goes to the input,
Yes, correct.
and input for drive where is coming from the
Output, yes. So we choose what just now according to the pin, right?
Yes.
We choose 0 to 10 volt. So when you send 0 to 10 volt here, let's say you send 10 volt, 50 Hz. When this one running, here it will give a 10 volts to here. Okay? Right. Then the number 4 and number 5 is to on and off, forward and backward. Okay? I connect it. But this one, For this one, there's no wiring, huh? For this one, is just what? Communication. Okay. Okay, I can do this. This one.
Communication meaning this one give a communication to the
No, no. Let me connect this. This one is your laptop. Okay. Now, what connect is using the communication means communication between two disks. Okay, between PLC and the drive. Okay, so what I do, I use a Ethernet switch. Because then only my PLC, my laptop can connect to here, my laptop can connect to here. Okay, okay. So from the laptop, I connect here. One. Then connect this to the PLC. This one is essential. So I need to use both. Okay. Then this one connect here. And the drive also. Okay, and so it means these two connect to this and also your laptop. So this is called communication. This is the Profinet communication. Okay, so now your laptop also want to connect, right? This laptop also want to connect to this PLC. This laptop also want to connect to this PLC. Okay, so what I do? Internet. This one, huh? Just so this one I used to, because all these three, this one and this one connected here. So only got 4 port. So I need to jump lah, make it use all this. So I just from here to here I just jump.
Plan is jump.
So it's just a switch, switch, huh? Okay, so I need one more to connect to this laptop. So the drive I try to I do the basic only. Because if we do more advanced of the drive, we don't have time to complete. So we concentrate more on programming. Okay. The drive setting, I will do the basic settings. Okay. So all this, so got 8 connection lah, right? Actually got 6 only lah, right? So 1, 2, 3, 4, 5. Okay? Sorry, 5 only. Because 1 from here to here jump. Okay? Now all this can connect to this PLC and we can control. Okay? This one we don't need to do any settings. Okay, because this one we can do settings in the software. Setting like that we do, right? We can do in the software. Okay? Siemens, because it's already in the TI portal, we install the software. Okay? If you want to use this like this, you can use this terminals here. Okay? You can use these terminals, all these terminals. This is just a DIDO, AIAO. So each one like that lah. What meaning what AI, can you see? AI, AO, everything.
Means like if with Siemens PLC we can direct link. If there's like Mitsubishi or Allen Bradley or Omron, we have to do it. If
Yes.
we also can use a LAN cable. Oh,
Can. Others can also, but make sure the other also can support Profinet. But this one no Ethernet, so no choice lah.
yeah.
So let's say this one got Ethernet, and let's say this one can support, then I can directly connect.
We may have to depend
This-
on
The model lah.
this model,
Yes.
see whether can support the Siemens.
Yes, correct.
And the PLC have to support the PLC, like for example Siemens PLC. Is it
No,
all?
once if you support one Siemens, all can support.
Okay.
But the thing is, okay, support means what type of communication you can support. Profinet or Profibus. Siemens only have these two. Communication lah. Direct Siemens lah. If not direct Siemens, Modbus. Okay.
TCP.
This Ethernet is TCP.
Yeah.
485 we call RTU.
TCP and RTU.
Modbus.
TCP is Internet.
Okay, so this one actually two things.
Modbus is I-45.
Modbus is a protocol. You can use TCP and RTU, two different cables. Okay, this one is the power module. Okay, power module lah. So here is the part number. Want to take picture, you can take picture like that. Okay, this is the control module. This is where you send some signals lah. Okay.
Our software here is 4.6. This one is 4.7.
No.
No.
That is 4.6 is what actually
PLC.
PLC.
Okay.
It's different. This one is a drive.
So,
No. Okay. And this one called BOP, Basic Operating Panel. BOP. So they have AOP also. Basic means you can do some basic settings lah. Copy the program from here to here. Okay, reset, check
These are the storage.
EEPROM. Okay, good. Yes.
It's very clear. Yeah, Profinet is I-45.
Profibus, no. Profinet is Ethernet.
Hey,
Siemens Ethernet, they call Profinet.
Okay, so they make is a TCP.
Yes.
Okay, then Profibus is a I-45.
Yes. They use RS-485 protocol.
Okay, then the
For RS-485 protocol, it means it's a two cable, it's a serial communication. One connect to multiple signals. That is called RS-485. RS-232 is one-to-one communication.
Okay. Then just now you said the Modbus.
Modbus is a Profinet is a Siemens one, right? Modbus is different people one.
For example.
Not for example, it's a different people. So what happens is a common. If it's common, okay? It's a common for all the automation devices can connect. So it's created by Modicon. Modicon is the first PLC. So they created, okay, Siemens means they use Profinet. Profinet means, you see, I use Siemens software, I use this, I configure this, I tell, okay, this is the Profinet connection.
Yes, correct.
Okay, so Modbus means my PLC, I don't know what model, I don't care what model. So I use the Modbus protocol to send and receive data. Okay, if you want to go deep, we cannot do here. Okay, you know why? Because it will confuse you. That's why I don't want to go deep. No, but the other thing is, okay, you don't confuse. Okay, there's a lot of communication protocols. Okay, so they have if Siemens, they have Profibus, Profinet.
Siemens also
Profibus. Profibus. You know the using this.
R45.
No, we don't tell RS45. Siemens Profibus, Profibus.
Okay.
Leave it, because if you talk 45, then you will confuse. Okay, we don't.
Why?
No, you will confuse.
But it's the same.
No, they use the same protocol. Okay, this is C. We have three types of cabling. One is RS232, 485 Ethernet. RS232 is 1-to-1. 485 is 1 to multiple. Ethernet also 1 to multiple. I mean multiple to multiple communication. That's all. Okay. Now Siemens, they create their own name, and they use the 485 protocol. What I call protocol means how the 485 work. One connection multi. Okay, they use the 485 protocol. Okay, and they make Profibus. Correct. Okay. Then Siemens, they have they call PPI also, point to point. That is a one-to-one communication. Siemens, they give their own name. They use this one-to-one communication protocol. They use their own name. Then Siemens, they use the Ethernet. They give it the name Profinet. How the Ethernet work? Multiple communications.
Let's say Siemens protocol R45 Profibus. Meaning they can link all the drives.
Yes. That's a purple cable I use. Okay. You see the drive, that drive.
But they cannot, let's say, two Siemens, one Mitsubishi, Siemens cable.
Can. Okay, can.
Need more pass.
No.
No.
Okay, can. Okay, so let's say I buy a Mitsubishi drive. Okay, let's say the drive can support Profinet.
Can share the information.
Can share. Can support
Internet.
Internet or in the Profinet or Profibus. It's a Siemens one.
Profinet.
Profibus. Okay. What you do? You go to the Mitsubishi page. There will be one file. Download. You install in TI portal. Okay. When you install in TI portal, later how this one like how we add this one, add new device. Correct. How we add HMI, add new device. So this one also later we need to add device. So when you add device, the Mitsubishi will also be there. So I add, then in the, like just now we do the setting, right? In the setting, okay, I need to tell I'm using Profibus. Okay? Now, so this one is a Siemens one. If a Mitsubishi, they call this communications, right? This field communication, they call CC link. Okay? They also, they have their own name. Okay, so for multiple communication, they use Ethernet. Okay, I mean that if they want to use serial, they use the 485 protocol, but they call CC. So you see, in many PLC they have their own name. Okay, these three unit common. That is 232, 485, Ethernet. These three is the main. Okay, like Omron. For Ethernet, they call fins. Yes, for Ethernet. For RS232 or 485, they call toolbus. So you see, this 3 is the main. 232, 485, internet.
Yeah.
232, 485 is the old communication protocols. Old like serial, now all internet. So each PLC they have their own name and own settings.
That means Siemens is like this called Profibus.
Yeah.
Internet is internet.
Yes. Okay. Modbus means my PLC I want to connect to a drive. Let's say that drive cannot support Profibus, cannot support Profinet. Okay.
The train,
The drive.
Okay.
We talk about the drive.
Driver.
Let's say the drive cannot support. Now the drive cannot support.
This one cannot support.
Don't have Ethernet. I mean, don't have a Profinet.
Okay.
Don't have a Profibus. Means I cannot directly connect.
Yeah.
Okay. Means I cannot configure in the software. Cannot configure.
Mm.
Cannot add a drive in the software. So what I do, I check the one got Modbus or not. Okay, got Modbus. So I use the Modbus language to send my data.
They mean the
From the PLC to there, I send the Modbus language data. It's a different language.
now is Modbus.
Now it's hard wiring.
Hardwiring.
Yes.
If without Modbus, if the drive also without Modbus, it will act external.
No, cannot.
Cannot.
It's just a protocol leading to PLC.
They mean have to base on what you
Take the
buy.
book, yeah. Based on the book. Let's say I want to use Modbus, but I don't go deep. I don't confuse you.
No, I don't want to understand what
Okay,
is
no, Modbus you very hard to understand. I can, but we are doing time, I suppose. Let's get prepared to use. So they didn't put here. Okay, they put serial communication. Can you see? Serial communication. Serial communications use the RS485. Okay.
Okay. RX45.
But my laptop is a TCP. TCP, right? It's the internet lah.
Internet.
So I need to add a module lah for that. Okay.
Two cable.
Two cable for module, two cable modules. And there I need to do the settings like the address, the power rate, the format, everything I need to do setting. In the PLC, I just do programming, Modbus programming to send data and receive data. Okay. If Profinet means in the software, I need to add the drive there. So my PLC will know what is the drive. Can you understand or not? The Profinet or Profibus, the PLC will know what is the drive. If Modbus means the PLC don't know what is the drive.
Don't know.
PLC even don't know what is it a drive or not. That's all. PLC only will know it's a device.
It's a
It's a Modbus.
Modbus device, that's all. So PLC don't know whether it's a temperature controller or is it a drive or is it a load cell. PLC don't know. PLC just do the settings, address, okay. What is it? Like IP address, right? So they have their own address, the speed settings, there's some serial communication settings lah. And okay, what data I want to send. Okay, I send. What data I want to receive. I want to receive.
You mean it's like a serial communication? 0
Yes.
to 247.
It's the addressing.
Addressing.
Addressing the power trade and this one. No, you don't see, you cannot understand.
Yeah.
So I confused. This one Modbus, you want to learn, you need one whole day to learn.
Next topic.
Yes.
No, I just want to understand only.
That's why you have time, you go to Google and see what is Modbus mean. Because if you go to YouTube and search Modbus, always have some video on Siemens with Modbus.
Confusing.
Not Modbus. So you just try to understand what is Modbus.
Okay.
What is Modbus?
I mean it's not related to the Profinet.
No.
It's a
Okay.
protocol.
Very simple example I give you. If I'm using Profinet or Profibus, my Siemens will know what is my device. Whether it's a drive, whether it's the HMI, whether it's something, some device, okay? If Modbus, my PLC won't know what is the device.
Okay.
That's all. And PLC will know, okay, I connected to Modbus device, this is the address, this is the data I want to send. That's all. So Modbus is like a universal. So like this, Siemens want to talk. So I am, let's say I am Siemens, I have a drive, I want to talk. I see this the Siemens, oh, we can talk in Profinet, or Profibus. I see this is the Mitsubishi. I check, can you talk Profinet or not?
Yeah,
Can. Okay. You give me your file. I install in my device. Then I will talk in Profinet.
If let's say he is
Yeah, that's
a
right. Let me know.
Okay.
Okay. Then I need another brand. Let's say Arabic. Okay. I check. Can you talk to me Modbus or not? I mean Profinet or not? Can you give me your file? I install. Then we talk in Profinet. Now I have another guy. Okay. I check. Do you have a Profinet? No. Do you have a Profibus? No. Because Profibus means I can add some module, right? Easy for me. Easy for me to because not much programming. I take your file, I just install. For me, easy to understand, easy to communicate. Okay. Now I have one drive. So you don't have Profinet, you don't have Profibus. Let's say I'm a Siemens lah. If I'm a different, let's say if I'm Mitsubishi, I see. Do you have CC link? No. I tell you that.
Okay.
If Omron, they have their own protocol. So I check. Okay, do you have this? Yes. So now you don't have. So then how you want to talk? Then he say, okay, I can talk Modbus. Then I say, okay, Modbus. Okay, we use Modbus to talk.
Let's say Modbus, we can receive data and send data.
Yes.
Normally, how about the capacity, the bytes, or because we're addressing it, right? We're addressing.
Yes.
So
Very big, 10,000 data you can take.
also Modbus also can save data or cannot save data. Or is it only
It's
just
just
signal?
okay. Is it the Profinet, the Profibus, all this right? Communication means I send and receive.
No,
No,
sorry.
No
No
storage.
Oh.
Storage means the PLC only can store values. Correct.
But let's say this PLC sent to here, I want to store temporary data out.
Yeah, of course. Because whatever you send there, it will store there.
Using the functional.
No. Okay. Don't go that one. Function block, all that. No. Okay. Very simple lah. We talk right. So I send you some information. Can you store the information? Can, right?
Okay.
You give me some information. Can I store? I store
PLC.
until you give me another information.
They can use a PLC store.
PLC and the drive also. You can keep the value. Okay. Let's say for example, you tell the drive to run 50 hertz. You send value 50. The value 50 will always there.
One time.
Yeah. Until you change, then I change the different value.
Modbus also sent one time.
Same.
Okay.
Last question. This one you say right? Communication. He has a Profinet. As well as a Profinet.
Yes.
Give me your file. Let's say
No, Profinet no need file.
no need file.
It's a Siemens lah.
Siemens and the
Siemens.
Alabama.
Oh, okay, Alabama, yes.
The Alabama, they give you your file.
Yes.
What the file means?
Okay, they call GSD file.
Okay. GSD file.
Okay. If you are the Siemens, I have Siemens, we got in Profinet, your what do you call? Your device, I know already. What is your model?
Yeah.
Because we are Siemens, right? So I know what is your model. So what happens when I do configuration, I take the model and keep.
And also link their
Link
his
just link.
IP address.
Yes,
also.
everything.
If let's say his IP address.
That's what the problem is. You know what? We haven't do this. That's why you cannot understand. We do this, then you can understand.
Okay.
If afternoon we discuss about my program,
Yes.
there's a good example of GSD file.
Yes, you have GST.
Yes, one of our.
That's why your questions is not.
Because we are not start yet, so I
Yes, that's why. Because your question must be, we complete this, then you throw the questions. So you know what question to ask. Now I tell you cannot imagine also.
So at this moment, we know first, then we listen. We listen first.
No.
then we ask the question.
No.
Yeah.
You mean like we have to practice all the things?
No, but no, not practice. Okay. Just how to configure these things. Once you know how to configure, when I tell, okay, I need your file, then you can understand.
Okay.
Okay.
No, you know when asking the question, like our mind already thinking of the question coming out at you.
Yeah, I know, because you cannot imagine how it works. Of course, you will have so many questions. So once you know how it works, then you can know already. Okay, because okay, let's say I say okay, you need to configure this. Then only you know okay, this is how it is. This is how you add a device. Because now I say add device. Can you imagine or not?
No.
Add this device to the PLC. Can you imagine or not? Cannot.
Last
You need to
question.
do the first.
Last question. Let's say our work file is we're using the work file we have the example the PDF, Excel file, .xls. Let's say Siemens or Mitsubishi or other brands.
They have their own file extension. They have their own file extension.
So from file station we can know that it's under which brand.
No. No. For me also sometimes it's difficult to find out. But Siemens one, I think you will have TIA lah. You have TIA or something. You
So-
check in your file.
So when people ask us what's your communication you are doing, then we can select our profit. Either you use a Profinet or Profibus.
For Siemens
For Siemens lah.
Yeah.
Then they will know already your
Very
Profinet.
simple. If Siemens are very simple. If you see Ethernet cable, it's a Profinet. And Siemens common practice they use a green color cable.
Green color.
Yes.
What is the purple color?
Purple color is a Profibus.
Profibus.
Yes. It's a standard in green.
Green and purple.
Yes. Green Profinet, purple is a Profibus.
Why they mix up sometimes?
Huh?
Why they mix up? Some they use a Profinet, some they use a Profibus.
Because based on your device.
Yes.
Okay, for example, see, I use this PLC, for example, want to control this drive and also that Siemens drive.
Okay.
It's a Siemens drive.
Okay.
That Siemens drive must use Profibus.
Oh.
So I use this terminal to connect Profibus.
Oh.
This drive I want to must use Profinet. I use this terminal. Got it?
Correct. To me, make very clear lah. Other like this is Profinet. This is Profibus.
Okay. Okay. First thing what we do, now all the laptop connected to this drive, I mean this PLC drive, okay? So later want to test, let's say you do the program, you want to test, okay, make sure that you just tell them that offline, so you download, you test your program. When you want to test, you test your program, okay? The first thing what I want to do is, I want to set your laptop different IP address. I don't want to conflict. Because that day, the first day we set our laptop on IP address, right? So I'm not sure what IP address. So this is 01. Okay? So not an issue. We can later download. So whatever we download we can change that. So laptop we change. So what you do? This one can minimize. You right click your Ethernet. Network, open network and internet setting. Okay. Change adapter option. Okay, your internet is unplugged. Okay, you check your laptop internet. Maybe the cable loose. power on. Check power on.
Okay, okay.
Then what? Your laptop, is it your laptop connected? No. You right click your internet cable, properties. Yeah. No, just click edit.
不是粘在这边，是粘在房间里面。
Go to TCP/IP4. Go down. Internet. Go. Internet Protocol version 4. Double click. Okay. What is your laptop? 1, 2, 3. What is your laptop? Last number. 10. What is your laptop? 4. Okay. Not same one. So that is okay. 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 And close. Okay.
Hello，哎，下次可以来。对，类似里面，不是，对
New project.
对，房间里面。所以我们有洗车
New
力，
project.
但是我放洗车力进去。
Add new device.
你帮忙看一下可以还是不可以？可以吗？好吗？
Select your PLC. All are same now.
Mine is still loading. Mine is still loading.
Okay.
如果你连外面的话，外面的那个玻璃你帮我清干一下对。对。看一下啦，你要换了，不要。对。如果它脆的话，它会不会去到里面？不可以，我要去那个白的那个房间不可以，白的那个房间要里面，就是那两副大片的，一定要连房间里面。可以啊。
Now in the middle, just now I add analog output card,
我
right?
是哪里？我是哪里？
Okay, it's a signal board.
M0, but that means the analog card is only one output.
Yeah, one.
Because here I saw it's only
AQ.
0.
AQ1. You see the part number?
Yeah.
Okay.
So that means it's one output.
Only one.
Okay.
Okay, where is it? Where we take? In the center means where, from where we take? Board. Signal board, huh?
Right. Okay.
Take the signal board. Yours is what?
output。
Analog output. Signal board. Analog. Q.
EQ? Only one, right?
Okay。
Okay.
Oh, that means the system already created the only like other model.
No, because that one only have one model.
Okay. With other model, and based on other model, I mean the analog output, like for example, is a 1, 2, 1, 4, 1, 2, 1.
1, 2, this whatever here, that is the model. So it doesn't matter. CPU is 1, 2, 1, 2, 1, 2, 1, 2.
Only the model.
Yes, because the one I connect only have one output. Unless I connect like this one got 4 output type.
Oh. 80, 81.
Okay, so what is the address for the analog output?
Q80.
QW80.
QW80.
Why? What is your analog input address?
IW64.
Yeah, then
Yeah,
output
Q, W.
W.
Why use W? I can't remember really.
Analog is how many bits?
276.
27648, right? So where we can store the 27648? Can I store in 8 bit? I mean the 27648. Can I put inside the 8 bit? Yeah. 8 bit maximum 255.
Yeah.
Can I store in 16 bit? Yes. Can I store in 32 bit? Yes, but not necessarily lah.
Oh,
So
but if let's say
always analog is a 16 bit.
okay,
All
then
PLC.
it's a W lah.
Okay.
We can put QB also, but
No, can
QD cannot.
because analog is always 16 bit.
So only W.
Okay, you got it right? Okay, safe.
If let's say all the configuration yeah, like yesterday we do like 0 to 127 something right? Then what is the like, for example we set the what you call the analog 0 to 10 equal to 0 to 27.
Yes.
So it has to base on analog also. Then we fix already that one.
Yeah, for Siemens is already fixed. Is it 0 to 10 volt or 4 to 20 milliamp, 0 to 20 milliamp is a 27648 fixed.
27648 is fixed. So that means we do the conversion also. We have
Based
to
on
put-
that.
Yeah, 0 to 27648.
Yes, correct.
Then only change on like either you use the 0 to 10 or 4 to 20.
Yes.
That's it.
Okay. Okay, now go to program block. Okay. Go to main. No, okay. Do simple. Go add new block. Add new block. Just you put VFD analog control.
I see.
Ah. Okay, okay, okay. So now what I want, you have the output, right? The for the relay I connected. What output? Q0.4 and 0.5.
Yeah.
Okay. So before that, you go to PLC tab, show all tab. Okay. So you put you have 3 push button, right?
Yeah.
So you put start forward, start backward, stop. Okay. Then the output is what? Q0.4 and 0.5, right?
Yes.
Okay, you put one is forward run, one is the backward run.
All is 4.
Forward is for lah.
What is it?
No, add forward run, backward run, the output, the two output.
Oh.
The Q0.4, Q0.5. Now we are doing according to our wirings. No need to put output forward run.
Oh. This one should do.
I have one question now. Just now you mentioned that analog card for the Siemens is already fixed to 7648, right?
Yeah,
How about the other brand?
they have their own
Own
numbers.
Maybe different.
Different.
That means
5 and 6.
we cannot like
4 and 5, right?
Are we putting to 5 and 6 now?
No, check and see. What is the address? Don't count the number.
Okay.
4 and 5, right? Okay. Then we have we have an analog input, right? That is the potential meter, right? The rotate one. Okay, so you put that is what? Just put AI one lah. Okay, that is an integer. It's an integer, right? Change integer. And what is the address? Put that address.
analog is in here.
Yes. What is the address? IW?
IW 64.
Yes.
Oh,
Okay. Next one is the analog input from the VFD, right? So you just put VFD AI2. So I know that is from the VFD. Okay, so it's 64. Then the VFD got analog output, right? So you put VFD A01.
this one is
Okay, my analog output what address? Change QWAP.
analog output is that the signal for the control
From where to where?
from PLC to drive.
Yes, correct.
There is an analog output. Input, we get the data
Yes.
from VFD,
Yes. To the PLC.
PLC.
Okay. Now you go to the VFD analog control.
Okay, can we declare one thing? All the, no matter how the interlock, I mean the analog input output or something like, it's like if we after the PLC is all called output. It's a result. Then all we call output.
No, again what?
Like for example, okay,
From the PLC.
from the PLC,
Huh?
after you, I mean configuration or you what you call to get all the data, all the input you get already. Okay,
Okay.
then coming out from the PLC, all is output.
Of course. Coming out from the PLC is output, right?
All is output.
Yeah.
If let's say the cut here,
Huh?
can we put input also? Can, right?
Yeah.
But have to depend what you need.
Yes.
Okay.
Okay. Go to VFD analog control. Okay. You do a simple program that is start forward, forward run. Stop, stop. Start backward, backward run. Stop, stop. Can? Just now we have a button, right? Start forward, the forward run. Stop forward, for stop. Backward, start backward, backward run. Stop means stop. Okay, you do this here. So
Hey, yeah, in.
Can you explain the condition again? Press start.
When you press start forward, right? Stop means stop lah.
Stop, you will use the stop push button.
Stop button, yes. The third push button lah. Okay, then start backward, right?
Look.
Now remember, you are downloading to that, not your laptop. I mean, not your PLC, you are downloading to that.
Okay.
Okay.
You got an advanced class in your
Yeah, advanced is like, because so many advanced. Can learn more bus, can learn temperature PID, can learn other some special communication or with a special device nowadays. Then can do advanced SCADA or that. So it depends what you want to learn.
I want to learn the what's internet link. You know why?
IoT.
IoT. You know why? My programmer, he had set all this kind of IoT. Okay, but need someone go to site and check. But he just on the office and check. They will call, what's the issue there? And they will just like, okay, that's one. Can already. This one I need to learn.
How they use?
How they use? They just call me like, okay, you give me your internet IP address.
Your laptop IP address
No, they want to know their internet because in the factory, right?
is connected to the. I mean, your
Yeah.
PLC is connected to internet, is it?
Yeah, correct. So that's why they just directly know, okay, your IP address connected, okay, come. What's the issue? Start. Then you check one by one. That's why I need to know how to link it. Because sometimes in the previous 10 years ago, when we the factory, like we have to go to the field, use a touch screen and check what's the error, right? The error, oh, this is a sensor error, or this one error, some sort like this. And now it's just like, okay, because there is overseas for example. So they just will call the operator, okay, you go to the field, start. And you need to check, I will check. You call someone to stand by for you.
Yeah, of course.
Then check, they will like, if any issue, like the motor not running, right?
Yeah.
Or here the PLC already run, they will call and you go check the motor run. If not run, that means not the PLC issue, it's your motor issue.
Yes.
Or cable issue.
Cable issue.
That is a hard wiring issue or something. By this month or next month, if you have this kind of advance.
No, advanced is a special request. What then only I can do. Normally basic to advanced, normally I will get the request. So,
But you got any minimum bags or something?
no minimum.
One to one.
One to one. Because if we talk about IoT, so many things.
Yeah, so many things, but I just want to simple it.
Mm.
I just want to no need like have to rush and fly to the field.
No.
You know what I mean, right? You know all the clients very crazy when they like this overseas one, right? They will call you, you must come over.
Yeah.
Then how can and if they won't give you any time on time frame, no. I
Yes,
want to
correct.
run the production now.
Yes.
That's why sometimes our program make very simple one, all
Yeah.
from the task screen. You check from task screen, that's it. And sometimes, yes, like yesterday we discussed, right, the error, some operate maybe a few months, it will come up, pop the error, why the timer run out, or why the program make the sequence different really. That's why I say maybe it's a trick or memory or something.
Yeah.
Sometimes they will supposedly the first motor run first, but no, the first motor cannot run really, only can run second motor.
So there's sometimes the sequence problem. Because we're using memory to jump to next.
Yes,
sometimes.
yes, correct.
This one then? Okay. So this one you can just on off the relay of it. Okay? Now, I want you to do the scaling. Okay? To set the value there and also to receive the value. Also. Okay? Don't do any, just do below here. Don't do it another FC. Just do below here. Okay. But I will do the graph first. Okay, you follow the graph and do.
Because you want to learn the IoT.
IoT.
Yes, we can learn together.
Yes, I have interest in that.
Yeah, that's why. You know, like I believe you and my kids are same, you know. If the production stop, right? Oh my god, all the clients are chasing you, hey, faster, I need to run back the production. If not, any loss I will charge back to you. And oh my god, how come the huge money, you know? We ours is just a small company, how come like you need to charge back, you know?
So we have two scaling tools. One is AI, one is AO. Okay? So our AI is what address? IW
64.
60 for the VFD.
The VF system.
BFD 66.
Okay. What is the value?
0 to 274 648.
Okay. So I want to convert to the VFD feedback, right?
Feedback.
Hertz. Okay.
Hertz.
Correct.
What is the feedback?
You know, you can if hertz want to put the RPM is depend on you.
It depends what is the figure you want.
Yes. So want to put hertz or RPM?
Hertz now.
So hertz is what value? 0 to
50.
50. So your analog input is the IW64. Once you convert, so what address?
Either.
Memory, right?
Memory.
What memory?
MD.
MD or MW? It depends on what you choose, whether you want integer or real.
Yeah.
Correct? It's up to you. I just leave it. Just put memory. Okay. Now, for the analog output, how it works? Okay, you see first. Because analog output means you need to give. Correct? Means you need to do some set point. Okay, so the set point in hertz convert to analog output. Okay, what is the address? Analog.
AO.
QW. 50.
Okay. What is your set point value?
0 to 50.
That is 0 to 27648. So what is your set point address?
Memory.
Memory. Dependent whether it's real or integer is dependent. So you see x-axis for this scaling, this is x-axis, y-axis. For this scaling, this is the x-axis, y-axis. Yeah. Okay. So you do two network. One network for analog input scaling, one network for a lot of those. No need to do it in another epsilon. Okay, so do two scaling, normax, KNX, normax, KNX. So in the network title, you can put analog input scaling. In the comment, you can put, okay, this one is what? AI, IW64. Like this, in the comment, let's give you an example now. So you can put, so you know why? So whatever this one you do, try to put comment on. So later when you refer, you can understand. Okay. So in the comment, you can put very simple thing. This is AI, that is your IW66 is equal to 0227648, right?
Yeah.
Okay. Convert to the VFD feedback inputs, that is okay, what M, right? Let's try. I just put MW1, MW0. What's the value? 0 to 50 hertz. So you put some comment. So this is means you are converting the AI, which is 0 to 27,000, convert to feedback. VFD feedback to the MW. What is the range? 0 to 50. So for this one, the set point means you need to key that. So later on to test the drive means you need to key the set point first. Then only you can press the start. Then only because when you set, let's say 25 hertz, then this one will become up. Then only my PLC can send 5 volt to the drive. It's an output, right? Correct. So then only the PLC will send the 5 volt to the drive. When the drive running, then only the PLC can feedback here. Okay. So set point hertz, let's say it's the MW, I just put 2. Okay, convert to AO QW80, which is equal to 0 to 50 hertz. Okay. Convert to
Hello.
AO QW80, which is 0 to
Oh yeah.
yes.
I need to. I know the time. I need to flashback again. Real is got decimal point. Or not? Decimal point.
Yes.
Got.
Real or decimal point?
Integer? No. It depends what you want.
Yes.
If some people say that I don't need the decimal point, use the integer also.
Yes.
If some people say I need,
Yes.
like for example like the temperature.
For this also lah. Let's say the feedback, I want the value 45.5. Choose real. If you want value 45, only choose integer.
Your inverter is only like 45, 46, 47. You cannot like 0.5 something.
It's depend on you lah.
Okay. Decimal point only one, right? One decimal point only, right?
In real.
Yeah, real.
Real can show up to 7 decimal points.
7. But
It can show
you
lah.
can show. But
If you want to in the HMI, it's up to you. How many decimal point?
oh, they will set and
The HMI, yes.
Ah, yeah,
Okay, go make a coffee.
I need you know, morning I make coffee one, you know. Without coffee,
Yeah.
my brain cannot turn.
Hello Jackie，早。不好意思啊，打扰你下车啊。那天我们谈到那个 private 对吗？铺地下的，给那个 scissor lift 进去的。赵斌跟我们讲，你们的人全部丢完了。对。canvas 的话也能。应该有 canvas 啊，因为我打电话打了，他没有听赵斌。他在现场吗？我再打给他一下。好。不认识哦，能跟你拿一下号码吗？那个号码现在都在省，先留，好不好？好，谢谢你，谢谢你，好。找哪里啊？找我们做那个
scaling， 它是叫做 scaling 哦，就是像这样子，不要写你放在那里，就是给你记得啊。
Halo, Ali. Itu samping ada yang tepi tak? Itu orang yang main kon, ada tepi yang tepi tak? Macam mati atau ada angkatnya?
Tadi pagi-pagi saya ada nampak. Sekarang saya nak balik dia ada workshop, jadi sekarang saya ada pergi workshop.
Jika
Saya mau canvas ke apa barang ada.
Canvas ada. Aku tadi short call dia, itu main kon dia bos. Canvas ada. Aku send satu nombor kasih lagi lah. Jika itu samping cakap tak ada, you call me lah. Boleh tak? Itu sekejap punya hak atau 3 hari. Karena orang bising, susah banget tu.
Dia cakap mau pasang ada susah, tapi sini pasang lain kali ini biasa ada rusaknya. Boleh buka lagi mau tambah. Mau pasang ada, ini sudah rusak macam mau buka.
Tapi you ingat lah, mereka pakai otak lah, itu production. Dia pasang dalam luar, koridor di tempat. Kan bencana itu cermin masuk dalam macam mana? Kita janji 1 tahun tak ada hal itu sudah okey punya. Itu 1 tahun tak ada hal itu sudah okey. Karena banyak susah punya buat sikit kerja memang banyak mabuk. Karena itu semua bahas semua kasih mereka arrangekan. You try tarik jadi itu samping minta dia itu canvas. Nanti memang dia cakap tak ada itu nombor kedua aku saya kasih you tanya dia. Memang ada punya canvas aset, memang ada. Okey, boleh. Okey, thank you. Hello? Yeah, Mr. Jonathan. Yeah. I get your number from Jackie. CSE. But because our system is so we think that we have those That's why I asked Jackie. Yeah. I asked my team to okay. I decided. I asked him for you. Okay. Thank you so much. Dia ada kasar, dia cuma fokus lagi. Aku suka kasih dia tahu lah, dia akan cari dia. Kalau ini mana? Oke, 这房间里面的话，你去拿铺一下，然后给那个剪刀车伸进去，它的主。不过如果讲你不要补的话，你可以先做。听懂吗 ？OK， 那两个房间，他们去哪里开？OK， 不过如果讲我们是有3副床，在对过，对吗？那个里面在外面有没有？那个里面在外面。对，不要浪费时间，我们不要浪费时间。因为那个房间里面哦，它有一个 production。如果讲我们也在考虑的哦，进行做的时候必须要怎么去，要很大的问题，就我们一样的那个房间。如果你讲那个微波那边有问题。有个案到的话，在旁边，他是现在有房间里面或者这个，可能他太阳的光线。对。他会稍微有点对，这个是真的。可是如果讲你的经验啊，我们可以在房间里面走房间也好，房间也好，大概就对，像不要气泡啊，还是气体之类的。我很简单，超过1年就没有问题了。这样子就不用看那个 report 我们没在出来，那两个大片的我们没在房间，然后我想说，你是讲哪一副？其实里面的话，我们有实质力，我们实质力大家，它的那个做工地方还可以在。不过我看一下你们，如果讲我们真的应该做工的地方，房间的地方。 会选，会调出来去到表现吗？会吗？这样子哦，你里面，你如果里面做工真的很重，不会有问题的，因为我刚才看到行政力比赛，就是说我们绑定在白羊的地方过后，行政力的那个platform推出来，它可以推出来，不会撞到，因为行政力比较重。这个东西我会做一个问题哦，通常多久需要换？通常会通过的话，然后几年会有问题，2年、3年、4年要换。这样子哦，如果客户到我了，我们就做工了，不要浪费时间，也不要恐慌啊。外面所有的东西全部外面没关系。如果客户到的话，以后会快要换的时候会很慢，就是这样子。对，不要恐慌，不要恐慌。对，你连片过你给我的照片，我现在给我。可以，你帮忙记一下，因为你邀请了我可以。有什么问题你叫我的外老板可以。好，不要恐慌，不要恐慌，做得好。只想你第一个sample你先给我，第一个sample。好，谢谢。Hello，平安。哦，刚刚我有跟你的人头打电话，我刚讲全部连外面啊，没有错啊，不要。OK，不要，全部连外面。不过啊，我之前真的有跟你谈到里面要里面的啦，我之前是有跟你谈到的，对，行车力进得到。对，对啊，我们就定下来，我们定下来了 ，OK 好，谢谢你。应该是我在忙做吧，不方便听不好意思啊。OK 好。Hello， 阿丽。Hello。你看不啥呀？什么打呀？输入那个广告。打电话出来了。OK，OK，
Okay, when you come error, you close this. So check here what is the error.
This is X is also
Error.
This one is error.
Hmm.
This one also is error.
No, it's from error from the program block, error from the block 1 and block 2.
Block one,
No, you click here. Click the green color.
green color. This one. Oh, this one. Green. Okay, ready.
Yes.
Hey. Then start.
Still.
Good. Oh yeah.
Why this one is quite difficult? Sometimes they can't detect the hack the actual.
Already done?
Yes.
You want to use the what?
Here.
No. You want to use what?
This one is an output to input.
No. Okay. You must put tag there, correct?
Put many times as you put them.
No.
Okay.
There are two options.
Mm.
One you can put the internal tag. You bring it down.
This one.
No, this one bring it down. This window here. This window bring it down. Yes.
Okay.
Put a temporary. So you can use temporary.
Hmm.
Then only will get the hashtag.
Oh.
Correct.
Hmm.
Or must use MD.
MD.
So which one you want to use?
I'm using this one.
Then you add that first.
Okay. Let's say.
No X.
This one.
X1. Okay, what is the data type?
Real.
Choose your test. Okay. Okay, now erase this. Erase this.
Hmm.
Okay.
Okay. Then we're going to use.
Now use no X.
Hmm. Hmm. Yesterday I'm typing here. I'm typing here using.
No, okay, I know what you mean. Okay, you put it here. The same thing. You want type there, go down. Okay, right click here. Key in there, norm X. Norm X2. Okay, enter. Right click, define. So, local temporary. Yes.
Oh.
So there's a two-way. One is you key here and add, or you define.
Okay.
Yes. Of course, that's when you do practice. Define. Then I define first. It will be still like that. Double click, change. Change again. No, choose again. Choose. Double click. Choose. Delete that and choose. Norm X. Because when you key in norm X, you define, right? The hashtag won't be there. So if you delete, it will select me.
The hashtag is for the local temp, right?
Yes, it's a local. It's to indicate that it's a local.
Okay.
Oh no, again. Why one grey color? Yesterday I look at this one, right?
CPU operator.
CPU operator. Oh,
Done.
okay.
This was correct. Yes. Supposed to be M. No, not two. Any. No, okay. Wrong. You are wrong. What is wrong is this is not the feedback. This is the feedback. This is just the norm X value, the convert value.
Like the stealing, those ways that you
can fix everything. You can fix.
They mean the function block you have to fix. Function block you no need to fix. I mean you don't need to key any input. You just create a file.
Yes, yes.
Then function you have to fix something inside.
All that, yes.
Like
All
give
the
the input
inputs.
in output also you have to fix it.
Yes. That is the concept. That is what you need to understand. How the block works. FC, how the FC work, how the FD work. So the program you want to do inside can be any program you can do.
I mean FP can I declare like the FP, I create my own program. Don't need put any input.
Code.
Yeah, code, the code.
Yes.
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 Then the FC, I need to put something inside.
Subroutine.
Yeah.
Yes. That is commonly used. Later we can see is program. So FC normally, what I also say, FC are normally subroutine. FB is a code block.
Yeah, code block like I can put anywhere and I just key it in the main block there. It's a
Main.
input.
Yes, yes.
Okay.
Okay, done?
Can I say like the function equal same like the main block?
Yeah. Same like the main block.
Same like the I don't need to do anything on the main block. Okay, I do all in the function there.
Yes.
Then I just put that function in the main block. That's it.
Yes. Okay. You save yours is your analog, huh?
Strong. Analog.
Yes.
Analog.
Scaling. There's so many things need to change. Okay. First we see here. Okay. What is your x-axis?
0 to
0 to 26, and it's a IWCC6.
Yes.
Convert to a memory.
Yeah, the
Then memory and convert to the result.
Yeah.
Correct. Go down. This one, what is your x-axis?
This one is output.
No. What is your x-axis?
It's memory. Memory from here.
No. Any memory. Because cannot be. Why cannot be this memory, right? Is it the same name?
No.
No. So different.
So where?
So this one you drag put here.
This one.
No. This one drag put here. Because this is where you key in this number, correct or not?
Yeah.
So here is the MD12.
New memory.
Yes. Name is wrong. Name you rename lah.
Rename one.
Enter. You follow my name.
Is
Set point hertz. Yes. Right click, rewire, change to real. Yes. So you see here, one is input, one is output. Similar like your push button also. You see, push button, all your digital input always on which side? Left hand side or right hand side? All your input will be left hand side, right? Here. All your output, where is it? On right hand side. This is the output. This is output. You got the idea now? How to scale the input, how to scale the output.
Because one more question. So the first This we're getting signal from
This calculation.
yes,
Mm.
it's from the
From the analog.
from analog.
From the drive. From the drive.
Right.
Yes.
Okay. And then to norm X,
Mm.
to scale X.
Then I use the normax to convert this data into 0 to 50.
Yes.
This is my result.
Result.
Okay. The feedback lah.
Yes.
Okay.
Okay. That result.
Mm.
Are you? I'm just.
I know what you mean. Can I use this result here, right?
Yes.
You tell me. Can I use or not? Logically can, because this is a memory. This is a memory. This range also is a 0 to 50. This range also is a 0 to 50.
Yeah.
But if you think of this one now, your motor must run first, then only I can get the feedback one. Correct or not? Correct? Your motor must run first, then only I can get the feedback. Because this is the feedback. Correct? Means your motor run first. So you need to set first. Unless you want to use the meter, the potential meter to set the speed. It means this is the IW64, right? That output you can use here. You get it? What I mean?
One more time.
Okay. What he asked is, can I use this data straight away here to control your drive? Cannot. Cannot. Why? This is from where I get? From the drive. From here. Right. So the drive must run first, then only I can get the feedback. Correct or not? Correct or not? Means the PLC need to set the value first. Means the here must have the value. Then only here I will get the value. Clear? Okay, you don't confuse with always input output. No, we talk about this project here. I need to give the drive 0 to 10 volt, then only the drive can run. Right? When the drive run, then only the drive can give me a feedback 0 to 10 volt. Correct. When the drive run, then only I can get the feedback. Is it clear?
Yes.
Clear. Okay. This one is what? The
Drive.
drive feedback. The drive feedback. Correct. IW66 is for what? No, what input?
Obviously.
From the VFD. When I get the value?
When start the button.
After get the
When the drive is running, not start button. When the drive is running, then only I get the feedback.
meaning the QW running, come out the result and can
Yes. Can you imagine or not?
Okay. Top one, clear lah.
Okay. Don't confuse with top and bottom. Okay? Because I know sometimes people confuse. Oh, this one the first no. Okay?
The top one, I just open the file, input, I just do 0 to 27685.
Okay.
I don't want to care you 0 or something. So the first one, input,
Mm.
I need to do this way.
Okay.
Output to come out the 0 to 5 result. I just compute here. You see the norm X, the MD12, there is no input. Where is the input?
You key in.
I key it.
If you want to run a motor, how the motor can run 50 Hz? Who set the value?
I set the value.
Okay?
That means the value, the set point, have to link to somewhere.
No. For now, we don't have any project to do that. So I manually key in.
Okay. Oh,
That's why the name I put here is a set point.
can I say like this set point? We do.
You need to key in.
And yeah, I will do key. And also we also can link
Do something.
something.
Yes, of course.
HMI or something.
Of course.
They mean we need to
Can
do.
I can link to the potential meter also.
Okay. I can link to. That means I need to key something.
Yes.
Memory for me to key something.
Yeah, of course.
Not from the button, not from the drive.
No.
So the running where will be from?
Okay, what do you do? Where do you do? No, no questions. You download. You test, then you understand. If no, you go to understand.
Just the third one I understand.
No, you say first. Okay, one person down, let him download lah.
Yeah.
Okay. You remember just now we add the option board in the middle of the board.
Yeah.
Correct. We do configuration, right?
Yes.
Okay. Right click the configuration, download the configuration first. No, PLC. Yes. Download to device, hardware configuration. You will test first, then it will clear some of your questions.
Configuration.
Come on.
Starts. Why can't start search?
Oh.
Check the cable at the back. Or check the cable of the PLC. PLC. Whose laptop is this one? Your laptop is it?
My laptop.
Oh, okay. You don't do download.
Yeah, this one.
Ah,
Oh.
sorry. I thought this laptop. You don't know.
Yeah.
Wait. Okay, this is the main, right? We call this block. Go to main. Call this block. Save. Right click the PLC. Download to device. Hardware configuration.
One question. Anything to change from the device configuration that we have to download?
Yes, correct.
Like for example, tag. Like say related you know here. If let's say we do simulation.
Yeah.
Start
The
from zero.
addressing.
I think we cannot start from zero. Either 10, 20, 100 also can.
Yes.
Then after we change, we have to download.
Download the hardware configuration.
What is the? I saw the download for the hardware. Right? How about the software? What is
Software means your program. That's called software.
software.
Software is your program.
Maybe we ask him like download.
No. Yeah. Because normally we click download, it will download software also.
Software only.
Okay. No, password must not be empty. Close. Okay. You click here. Got see whenever error like this only. Just click here, it will open. Full access. I think you didn't select this now. Full access. Okay, wait. Go to connection mechanism. Go down. You see, you didn't uncheck this one. When you first open, come out right. Uncheck. You go to protection level. Okay, no protection now. Okay. Save. Download the configuration.
That means anything error from there, we just click it.
Click it. It will bring you to the error. Where is the error?
Okay, good. Learn something.
Yeah.
Yes, the last time I just confused my can simulate. Oh my god, I check all the program, you know.
Yeah.
If let's say anything change from our device configuration, right? We download it also will automatically download. We have to do it separately.
Separately. Only the first new project I will download. Second time, third time you click download, I will download only the program. So anything you do in the hardware configuration, so always make it every time. Anything you do in the hardware configuration, download hardware configuration. Okay, now download the program because you download hardware only. Correct. So like now normal download lah. Okay, wait cancel first. We do see? Just make it smaller. Can you see like a box here? Right. It means some issue there. You bring the mouse there. What is the issue? Long real to integer. Okay, see because your output is a integer. Right. So it must be 0 to 50, not 0.0 to 50.0. This one 0 to 50.
Wow. This one is real.
No, this is not real. This is data is for what? Not for this. This data is for the output. This range is for what?
Hertz.
Yeah. So your hertz is what? Real or integer?
Integer.
So must put 0 to 50, right?
We here we choose real.
No. This one is for this only.
Oh, for this value only.
Yes. Okay. Now save down.
Can run also or cannot run?
No, can run, but it shows what? Runtime error might be possible. Means the value you won't get the proper value.
Oh.
Because it's just a warning, not error.
I think if we choose real, we have to write no maximum point. No.
Okay. Now the up one no need lah. That one is very simple program. Okay. Now go down. Okay. You see, now your output, you have any value? No, right?
No.
Okay, you see the drive, what is the value of the drive?
Value is rough.
What's the value of the drive? Escape, you just press escape. Got shows words. Is it off? Oh, okay. What's the value? Nothing, right? 0, right?
0.
Okay. Now, you key in value here.
In value
In the set point, you key in. Okay, how much you can key in? What is the range?
30, 40, 50.
Any number. Just key in.
So we tell the average first.
Okay,
But let's see what.
that one don't care. 25, 13,824. Right. What's the value?
24 heads.
Of course, you won't get the accurate value. Right? Okay, you know why? Because 13,824 it means 5 volt. Correct? 5 volt. So my drive receive 5 volt, it's supposed to be 25. So this has some voltage drop lah. Okay. You see. So means you key 25. 25 means half. Half, right?
Yes.
So you should get what here? Can you see 5 volt? Right?
It's 0.
So here I get what? What? I get 5 volt. Accurate lah here. Only this one the problem lah, not the accurate time to calibrate. 25 right? Can work. Okay?
So this one running at 24 first.
Now running right? You see the feedback IW66. IW66.
130 something.
1300 lah. Supposed to be 1308. 13,800.
This one number is before from here.
Supposed to be similar, but that is the feedback from here. So we see what is the feedback. Supposed to be 5 volt, right? But I don't get 5 volt.
input we can
That one is problem, this one problem.
That means if somehow is wrong, that means the issue from here, not from there.
No, because you see, I send 5 volt, so I should receive 5 volt. So there is some voltage drop
Drop.
because of this. Okay,
This one is the our receipt.
analog input, this guy receive
Okay.
from your output
Mm.
to 5 volt, right?
Mm.
And this one running analog output, right?
Mm.
It is 0 to 4.7.
Okay.
Okay, so the IW66 you do scaling, you get the MW0. Okay, MW0, you right click the MW0. It's in hexadecimal, change to decimal. Right click the MW0, right click the MW0, the name. Monitor display format, tab, decimal. Okay, so you get what? 24.
24 is this one.
So feedback lah.
So here is a key in. We key in, we generate this one.
Yes.
This one go to this one. Then this
No,
one.
no. Not there.
Okay.
You key in here,
Okay.
generate this number,
Okay.
this value go here.
This value go here.
No, here.
This value go here.
Here.
Okay.
Then the feedback go here.
Oh, this value go driver.
Yes, of course.
Then driver using the
Then I
from
feedback from here.
to here.
Yes. If this value go here, why not same? Correct or not? So it's not directly go.
It's through the drive.
It's two different, two separate. Don't make it. It's the same thing. Okay.
Okay.
The two is different thing. One is send output, drive. Sorry.
So let's say we don't want to key in the program.
Mm.
We link this one to the HMI to key.
The MW.
This one we link to HMI.
Yes.
Then we make a table, we key in.
Yes.
So we should link that.
Yes.
Okay.
Even you can make this one convert to here also. I can. This one is what is the value?
This one I put QW.
No, what is the value? 0 to 10 volt, right?
Yeah.
This one can give what? 10 volt, right? I can remove this this one. I can put direct here also can. So I don't need to use the QW80.
So I don't need to do any conversion.
I don't need the number network for. I don't need.
Okay.
So means I increase decrease this one. I get feedback only. Also can.
Oh, because we already covered.
Yes.
Okay, so for
I think if you on the manual, it will show you then that one.
No, it won't show you. You mean the manual, right? In the manual, they just tell you at the AI 0 to 10 volt.
Or others.
No, that's all.
So it's depend on the module lah.
Module lah. I mean, this module lah.
Yeah.
Choose lah, milliamp or voltage lah.
Yeah, some of the they will.
They just tell you that is the input.
Ah.
They won't tell you must be from the PLC
No.
or must from the.
Then they will say like, oh, my input. They say that I will show you. My input is 0 to 10 or 4 to 20. That's it. Then whatever you want to keep, you have to modify your PLC.
Even let's say I have another drive. For example, this output I connect here. Then this feedback, right? The 0 to 10 volt feedback. I can connect to the other drive also can as an input.
That means we can link.
No. You clear. Listen first. I send the 0 to 10 one output to the input here. Then I take this output. I can connect to another drive.
This is the output.
From this output, I go to the other drive. Okay.
For
Run that one.
run that one.
So means you set here value. The
24.
result from here, not 24. You set this value,
Yeah.
the analog voltage from here. The result, I run the other one.
Also can control also.
Okay.
Okay. If they say this is 0 to 10, V 10 to 0 to 10
Voltage.
voltage. Another one is 4 to 20.
They cannot.
They cannot
Must use converter.
convert the. I mean like we have to use two
Of
outputs.
course lah, two output lah. Yes.
If all the same, they will link.
I just give you example.
Yeah.
No problem.
Okay. One thing. Output output, the 0 to 10 coming here, right? Revealing, right? Anything changes, control because will it affect, the among these three of
Yeah, of course.
That means like for example, I set 24, O will become 24.
Yes.
If I set 25, O will become 25.
Yes.
If I separate the output,
I can control separate.
separate, that means I can control, I can
First one
few-
25, second one 30, third one 45. Like that.
Okay. One question. Just now, see, if they say this is a real, the number I key O is a real.
Yes.
That's the decimal.
Yes.
Okay. I don't care about this.
Yeah, that is the Normax.
The Normax. Because the Normax from here,
Yes.
what result you get, I need to follow.
Yes.
What you come in, come out, what you need is based on here.
Yes.
This one also same, right?
Yes.
We can set our ourselves.
Yeah.
So
It's
this
the same thing,
no
Normax.
issue.
What no issue?
Like mean like here, I get the result real, and here increase the real. I get the input from real. No. Or for real.
No, real is from here.
Here.
Yes,
This
it's
one
the
is-
same thing, man. Normax scale. You see that way. Don't
Okay.
make it input output.
Okay.
Just see Normax
Whatever
scale.
I do the non-max, right, and the scale X comes over there have to be the same.
No.
Okay.
You forget this.
Okay.
You forget about this.
Okay.
Only F1.
Okay.
Now you explain.
Okay. Because I explain right, I check what the figure, the digit I need to key in. Real.
Okay.
The result I come out real.
Okay.
After that, what I receive, I need to receive is the real result.
Yes. Okay.
But I need to convert to the integer.
Yes. That's all. That's all.
If let's say, I
真的是没有差别的啊，我们先
real integer.
我现在给
Cannot.
我们先
Why?
浪费时间。
Why cannot? Cannot. Real integer. No, you ask Siemens.
No selection.
Huh?
Oh, okay. But here can.
Yes.
Whatever here we need, here have to be same.
Okay, you see how it works, Normax scale X. Okay, no, one more thing I want to show you. Okay, Moses, you ask me, right? Speed can, when it's running, can increase, decrease speed, right? Say yes. You increase the speed to 40. Can you increase that?
Yeah.
Yes.
You see the feedback, I get 39, right?
Mm.
Okay, you decrease to 20. Okay, right? So it means can. So it means that, because yesterday you asked me that this machine when it's running can increase the speed. But if you want to decrease the speed, cannot decrease. Want to stop, then only can decrease. So I tell him, they do some programming, some interlock. So when it's running, you can increase the speed, can. But if you want to decrease the speed, they put some interlock there. So you must stop and put the speed.
But now we can put the speed during running, right?
Yeah, ours is normal programming, what we did here.
I think
They do some interlock programming, additional programming lah.
Oh, they mean your program is like, and you have to stop first.
yes.
If you want to
Before you
decrease
decrease the speed.
You don't simply like just decrease.
So meaning we learning the map function yesterday. Map function they have an increment. So we can give a result then increase the speed. Yeah. Okay. The map function we have an increment, right? So once I give the output, so from the output start thing to increase, it's the same or different.
No. What do you want to do? What do you want to do? You give me the flow. So that's why I say your mind is like, okay, for this increment. Okay, no. You give me the flow chart, give me the flow, you give me how you want to control, I give you the idea.
Okay.
What you can do.
I need one idea.
Mm.
Like for example, right? sometimes the conveyor, we say conveyor, the motor drive. When we finish up, you see the sensor. After I scan 4 bags, I need to reduce the speed. Okay, and also I need to calculate how many times I have reduced and increased my motor. That means, for example, after 4 bags, I reduce.
Okay.
And another after bag, 4 bag, I increase back again. Then I need to calculate how many times the motor has been increased or decreased.
Okay. What is your question?
Okay, because normally the compressor have a terminal box. They have a terminal box for the wiring, example. So once compressor running, increase the frequency, then the terminal will become hotter and hotter. Another one. Your terminal wiring, so it become hotter and hotter once the frequency increase. So let's say this one become hotter, the frequency want to increase, so that the temperature will get hotter.
No, pardon?
Okay, normally our compressor, let's say 3-phase, example 3-phase compressor, we have a terminal box.
Terminal box for what?
For the wiring, the stuff, the power winding, example the power winding.
That is the one lah.
This one.
Yeah.
So let's say this one getting hotter and hotter. So we need a temperature sensor to sense the temperature.
Yeah, of course.
So once the temperature increase, example, we go until 60, I want to make the compressor to lower down the frequency.
Okay. Okay. First thing, like yours. First, what I need to do? I need to use the counter. After count, I want to reduce automatically.
Yes.
Okay, it's the same thing like when temperature increase, reduce.
Yep.
Okay. So temperature increase, what I use? Compare. Correct?
Okay.
Correct.
Okay.
If the counter already reached 4, what I do? Use the counter output. Then how to reduce? This is where we will do the move function. Okay? I want to do a move function. Okay? You press stop. Okay? Now, what you do? Go offline. So I do the temperature one lah, easier. Because it's the same thing only. Temperature or your method also is the same thing, just going to move the data. Okay, so we do that. So for that, let's say the potential meter is the temperature. Correct? Temperature. Okay. Go to network number 5. You do scaling. Normax scale X. Okay. Scale to integer first. Integer, real integer. Huh? For the IW64, I want to convert to temperature. Value IW64. AI1, right? Okay. That is the meter lah. Okay. What is the value? 02? 27648. Okay, the normax. Put the normax. All using different way of normax, so follow your own way. Okay. Change. Yes. Okay, you convert to 0 to 100 temperature. Okay, so the temperature must be new memory, right? So what memory is available according to your project, you use that memory. No. Memory is what? No. Memory is what address? MW.
Integer.
MW.
Go and define it.
W, just now
What's that?
Define the tag easier, more faster.
Then the name, if you want to define the tag,
Yes.
put the name temperature.
Easy.
Yes.
No need to like think how, when or what.
No, that one is important.
Then picture one by one, as you say, go to the show all tag.
Yeah, I know.
This one we choose global, choose.
Global memory. Okay? Save. Now I got the temperature already. Now, go back to the process. How you want to control? What is the value? If less than
More than 5. Oh, since.
similar yesterday, right? Similar like yesterday, okay, but a bit different. One thing we need to learn. Okay. Let's say less than 30, I want 20 hertz automatic lah. Automatically. So after this, we don't need to key in. Automatically 20 hertz, less than 30. Okay. If more than 50, I want sorry, if you want to decrease, right? So if less than 30, let's say I want 40 hertz or 45 hertz.
Less than 30.
Degree 45 hertz running. Okay, if more than 60, drop to 20 hertz, for example. Okay, so less than, more than, what do I need to do? What I need to use? Put compare here. Put to compare, less than, more than. Compare with the temperature.
More than or equal.
Less than and more than. Go up. Compare. Go down.
More than.
Comparator. Above max function.
Use the result.
So the one is
Less than first.
Less than.
Okay, you add another branch first. More than. Okay, put the less than lah, less than 30, more than 60.
Speed of motion.
Okay, now I'll show you something. Okay, what do you do? How am I going to set the value? If less than 30, I want the motor run 40 hertz. How? That's the idea, right? So you see, you see, my phrase, less than 30, I want the set point set point value is 40. Okay? If more than 60, I want the set point value is 20. Means move. They call move, right? Okay, this is where we use the move function. Okay? Go to move. Move. The first one, move. Right? Take and put here. Put here. Both lines also. Okay. The first move. Okay. What you want to move? No. What?
Temperature.
Data.
Temperature.
Not temperature. The speed, right? You want to move the speed, correct? You compare the temperature, want to move the speed. Right? Speed, okay, how much?
The speed.
No, how much
want to move?
So
What is the speed?
40.
Less than 30? What is the speed? 40?
40.
240? Okay, so I need to move to where?
Move to motor.
So where is the motor data? Which one?
QWB.
No.
This one.
No.
This has to be key in. This one.
Set point.
We move the hook.
Yes.
We're using that.
Yes. So if I want to run the motor 40 Hz, where I key in?
Here.
Here. No, where? Here, right?
No.
Here, right? No, are you confused?
A little bit.
No. If you want to run the motor, where you key in the 40 Hz?
Set point.
Where? Show me. Where?
Here. Set point.
Here, right?
Yeah.
Okay. So if I want to make it, if 30 degree want to move means, so go down.
Move to set point.
Yes. The 40 move to the set point.
Move.
Got the idea?
Yeah.
So speed to
No, you see, when I compare,
uh,
okay, we know from the previous, okay, you see, this is not a project. Okay, we just learn how to do the scaling, or set the value, receive the value, everything. Now only we are doing some process. Okay. But earlier we learned already how to set the speed. Where to set the speed, where to change the speed, here. This memory is the one we can key in the speed value. Correct?
yes.
That one you understand?
Yes. Okay.
Now, when less than 30, I want to the motor run 40 Hz. So what I do? I just move the value 40 into here.
Oh.
So now here, if I move 60, so what I do?
20.
20,
Okay. 20.
go where?
This one will be go to here.
No. Where you set the motor speed?
We set the
Set point.
Set point.
So same memory address.
Yeah, of course. You get the idea now?
Oh, okay. So they will only will reduce.
Yes.
Oh, okay.
Because that is where you key in the speeds just now.
The output I link to the set point, right? The
Yes.
value.
Yeah.
What the come red color here? What's
Okay.
that cannot be.
Where? Oh, okay. Because it's the what? Real, right?
Yeah.
So you must put where? What is that?
0.0.
Yes.
Okay. That means like this is the
You do first.
40 hertz. This should move 30 hertz. Here is the output.
Okay, go where?
Go to the set point.
The same set point. Because that is where you key in the motor set point.
This means like the move in and out.
Move data, that's right. Move whatever value in the in, whatever value here, I move to here. When I enable. So in this case, when temperature more than 80, this line will enable. Right. Then I will move this value to here. You download this.
If let's say like, this is a set inside the program, right? If you want to set in the HMI, the button,
The button. Okay. Set what in the
set the hertz. It reach to this temperature, right?
So
The
okay.
hertz,
What do you want to set? The hertz value.
hertz and also the temperature.
Okay, what you do now is a constant number, right?
Yeah.
So if you want to set, let's say in the HMI you can decide what is the temperature settings,
Yeah.
what is speed settings, MW. Temperature temperature set point 1, temperature set point 2, seat set point 1, speed set point 2.
Whatever you want to transfer to the
From the HMI, put it here.
all change to memory.
Yeah. Good.
Right?
Okay, we test this one. If this one okay, understand the motor, how the analog input output working, we go to this drive. And we can, so this one will take 30-40 minutes. You can go for your lunch, and after lunch, we just test this drive. Then we can do some other things. Okay, wait. What's the temperature now? Okay, now it's 20 degree. Okay, based on your previous set point lah. Okay. Okay, now you decrease the temperature. Go below 30. And this one move here. So this is the one I use in the top, do the scaling, send the value to my analog output, analog output send here. Okay, 40 Hz.
No, 38.
Of course.
Because the debit trace issue here,
Yeah, of course.
not the issue PLC.
No, you measure and see.
Okay, one thing.
If I put 10 volt, I should get what? Sorry, if I put 27,648, I should get what? You know, the voltage. 10 volt. Is it correct or not?
Correct.
10 volt is correct. But my drive is not running full speed.
Okay.
So it's the problem with the drive.
If they say this is a problem, right? For example, we don't know either inverter issue or PLC issue. We use the meter
Multimeter.
to check on PLC first.
Yes.
If let's say the PLC is not the 10 volts, it's like 9, that means the program, the converter, conversion
problem,
code
yes.
is not the issue.
Issue. So what you do, you need to play with the value lah. So 0 to 27,000, I just need to, let's say lah, you put 27,648 maximum, but you get 9.8. So you try to increase a bit. Maybe 27,680.
Yeah.
Make it
Because sometimes we also,
Of course.
we click 27, we click 267.
No, sometimes the value will be okay, but
Yeah.
over the time, the value will drop one.
Why?
So this over the time lah, normal. So need to calibrate.
So I have to check one by one.
Yes. Both side lah.
I mean we check from PLC first. That means
Yeah.
PLC no issue,
And then we go to the
inverter, right? That means PLC no issue, that means it's a drive issue already.
Yeah. Okay, good. Any question regarding this analog input, analog output, compare, move? How the drive works is secondary.
So we just add whatever we want to move.
Same thing, okay, same thing for you. So just now you asked me, right? So in front will be the counter.
Before this.
No need compare. You take out the compare, you put the counter. You say how many count? 4 count. Count 4, take the output, mean Q, CTU right? What Q? Q connect to the move. Reach 4, okay, increase.
like Madam reach 4 and increase, reach 8
What
and
decrease?
increase, reach 16 increase back. That means each
So what you do? No, not like that. You only to do multiple.
multiple or
Okay, it's depend lah.
if let's say I see the CPUD right, it's like decrease
down.
up down right. After we set 4,
Hmm.
then we automatically count from 4, 3, 2, 1, 1, 2, 3, 4,
Okay. The sensor, how the sensor?
It's
Is it only one sensor?
only one sensor. This is the proximity only.
Okay. Then what you do comparison. You do the counter.
Yeah.
Counter will get you will have the CV, right? Counter value, CV,
Okay.
right?
Okay.
So what you can put the memory there. Then the memory put here is
Counter. Which one counter?
CPU.
CPU. Okay.
Will have the CV, right? Counter value.
Yeah.
Put there one memory there. Then use the memory here. Here is the 4. So you must use multiple move lah.
Okay.
So so count 4. Okay, move 20. If the counter is 8, move 30. If the counter is 16, move to 30. Counter 32, all that.
CPU create the file already, right? Then after that this
CV, use the CV.
CV CV is like
Counter value lah.
value.
The result.
Result sent to this temperature.
Yes.
Okay.
Yes.
R is what?
Reset.
Reset.
Reset the value. Once you complete everything, need to reset, go back to 0, right?
Yeah.
Reset the value.
Then link to it.
It depends on the project. Depend on the project lah.
If they say after 4 I need to reset.
Then after 4, you take the output of the counter, you reset lah.
That means PV I set 4.
PV set 4.
Then the output I
Put the memory.
memory
Then use the memory into the R.
R. Then also the memory link to the temperature there.
Not temperature.
No, I mean move the top there.
Yes.
Then the bottom I link, I can create a memory link to the HMI.
Yes.
PV also can link to HMI, right?
Yes.
But also need the memory.
Yes.
Whatever want to set in the HMI, set memory.
Yes. Okay, good. Any question?
The sensor normally using a transducer. So let's say we doing a program, we always need to refer to the transducer reading, right?
Yes. Yes.
So this one reading will be the 0 to 10 or the 0 to 20 million.
Yes. So in the hardware you need to choose lah. Because now our input cannot choose. Okay, you go offline. This is on yours, right?
Yeah.
Go offline. Go to device configuration. You see here, all see. Device configuration. You make it device. Okay. You click on the port property. Go to IO address. No channel is also is. Can you see? Click here. Can you see? I change voltage or current. Right. Can change.
Voltage is 0 to 10. Current 4 to
4 to 20 or 0 to 20 lah.
So this one will be referred to our
Yes.
link.
Yes. But okay, why that yesterday we didn't do because our PLC AI is fixed 0 to 10. We bring it down here. Then we bring it down. No, the black line. You click first. Okay. You choose the PLC. Okay. You bring it up this one. Go up. All the way up. Go to AI and lock it. Channel 0. Okay, can you see 0 to 10 volt? I can't change. Okay?
Because our
It's already building.
Mm.
If you add any device like this,
Mm.
it can change.
So we need to using the.
Okay, now it's a 0 to 10.
Hmm.
That's why the small the potential meter we use is a 0 to 10 volt. Correct.
Yes. Hmm.
The drive also we choose 0 to 10 volt.
Oh.
Okay?
Oh.
Because my PLC is a 0 to 10 volt.
Hmm.
Let's say for example my device is 4 to 20 milliamp.
Yes.
So I need to add the card, additional card, AI card. So that AI card I can choose milliamp or voltage.
So we just be only using the. Hmm. Okay.
That's your question, right?
Yes. This one is channel 0 is input, one is output.
No. What they put there?
0 and 1.
No, what you put here?
Input.
Input. So input 0, input 1 lah. Got 2 input, what analog?
Oh.
Correct.
Oh, okay.
Correct.
So let's say we add another one, then here will be come out.
No, it won't come out here. It will. You need to go to the device.
Go to the device.
Because this is the PLC. Like this one, right? You click on this one. No, the center one. Okay, go to property. Yes. So if I choose, it only show the property of that module. So just now it showed the property of the PLC.
Yes.
So PLC only have 2 input. It will only show that.
Oh, okay.
If you add any additional device, it will show only that device only. For example, I just add one. Go down. This is signal. I don't want signal board. Go down here. Go to AI. AI 8. Okay, and here, just put here. Okay, property. It's the AI 8. AI 8. Open here. Analog inputs. Okay, click the first one. Okay, can you see? Can change. Click here. Voltage or current. Okay. Plus.
Okay.
Click here. Can choose 0 to 10, 0 to 5 or 2.5. Choose current. Click here for 20 or 0 to 20.
So we will.
Okay?
Okay, my question.
Just now I create CPU, right? Like this, right? You see, this is the memory of the output. This is our set point. This also is our set point. No.
Okay, who want to count?
Huh?
Who count?
This count.
Who count the counter?
This. Who count the counter sensor input?
Where's the sensor?
Sensor means like something inside here.
Yes.
Then mean the input.
This one remove.
This one remove.
Remove.
It means
Put the sensor.
Sensor.
Any input lah. Just put I 0.4, 0.5.
Sensor. Input.
Global input. Global in.
Okay. So count.
Now this is the value, right?
Yeah.
Okay. Now how you want to move? Every 4 you want to move, or 4, 8, 12 you want to move that way?
4, 8, 12. After 4.
Every 4
Every 4.
you want to move how?
Increase and decrease.
So the first 4 increase,
Second
8
4.
decrease, 12 increase.
16.
Okay. Put Go down.
Go down.
At a branch, put compact equal.
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 This one.
Okay. On top, you put the output for the MW20 lah.
Yeah. Yeah.
Okay. How much?
4.
8. But why here put 16? So 8.
8. Okay.
Okay. When 4, what is the value? How much the speed? You go up. You copy this. Copy.
Copy. Oh, sorry.
You are moving. Then you copy back. No, you click here. Copy and paste it. You didn't copy. You click first. Okay. When it's 4, move 20. When it's 8, how much you want to move?
50.
50. Move 50. So 8 means I can use this output, right?
Yeah.
Okay. Then use the copy move.
Copy.
Put it there.
Move.
Put 50.
50.
Okay. After that, I want to reset the drive, right?
Yeah.
Okay. So click here.
Right here.
Add a branch.
Branch.
Put okay. Just put name reset counter. Okay, right click,
It's a memory.
memory, global memory. Okay, use the memory here. M. Okay, this one make it into a pulse because why? Because according to that, it's not because of the sensor. I know what you want to tell. It's because it's this one.
Right.
Always on, right? So what happened? The moment you on number 8, you see, you listen to me.
Yeah.
The moment you on for number 8,
Mm.
it will reset, right?
Yeah.
But the sensor is still on, correct? So the value become 1 again. So if pulse means because since this one is always on, the become 8 means Q will on, this one will on, this one will reset. Okay? But the sensor is still on, right? So it will count 1 again.
They mean it's only one.
Without off and
Yeah, without the pulse lah. I mean, like I on.
I already count 8. Listen, I already count 8. Now I at number 8. I want to on and off. But of course the PLC will process fast. Correct, faster than my on off. So that's it. On 8 ready. I move 50. Then I on this memory. This memory will on this reset. But my sensor is still on, right? Reset means what happened? The value becomes 0. But my sensor is still on, so it will count. Because my PLC is scanning, right? PLC scan, come and see, oh, sensor is already on. Count 1 again. Okay. You remove the P, you do. Then you understand.
No, I understand. I just
No, you didn't understand.
P, I understand.
No, P you understand, but why I use P you didn't understand. Correct?
No, because the pulse or the scanning. Like for example,
Without pulse, can I count or not?
cannot.
Can count. That's why I say you didn't understand.
Okay.
You did double click, change that. Okay. You download. You already offline?
Yes.
Check the laptop connection. You remove and connect. start search. What to do? What? Okay, let me.
Okay.
The one button. Okay.
Oh.
Because always training and this is all the thing. Still same?
Yep. Yep.
Okay. Got so many. Can you see? Got so many devices. Desktop, drive, PLC, all. It's all connected. But you only see PLC. You don't need to download hardware. You know why? Because he already downloaded the hardware.
Okay.
Same model.
Same. I mean, same model, same configuration. No. Can I erase this? Okay. Okay. Currently, you see, currently you go up. The temperature, okay, temperature we don't disturb. We leave it 62. Means 62 means nobody will move. Nobody will move. Because this one also move, that one also move, we'll have a conflict. Okay. So what you do? So for now, no value. Can you see? No value, right? Okay. Just key in here. Anywhere you key, or if you want to key on top also can. On the go up. Here also can. Okay. How much you want to put? 30. Let's put 30. Okay. Bro, you can press start. Okay, now go down. Go to the counter. Okay. I want to see these two. Okay. Come. The selector switch number 1. Okay, 1. Okay, off. 2. Off. 3. Off. 4. Now 20, 30. Correct. Just now you put how much? 30. 30 area. Okay. On. 4, 5, 6, 7, 8. Okay. You off. Okay. Oh, okay. It's not counting. Then only once. Because normally we count one additional. If I use back this output to reset right, sometimes it will count additional one.
Change to how?
No need to change.
No need to change.
No, just now I said it will count extra one, right? What I mean is, but it's not counting, it's okay. Right? So you see, sensor, CPU, CU, this one I put what? 8, right? Then, this one I don't care what I put. Here is the reset, right?
Yeah.
This reset I put it here.
Yeah.
Okay? So this is the CV. This why I put CV because of the 4 on the count 4, right? Compare the 4. Okay. Now how it works is when I start, I on. Okay, I will count until 8. Okay, you see, when this one become 8, it will energize this and also energize this, correct? When this one energize, it will reset this value. Okay, correct? Reset, and this one will off. So this reset also off, right? So when PLC scan and see this one is still on, right? Sometimes it can count one, but here not counting. I think maybe my mistake. In Allen or Mitsubishi, these two PLC will count one. So for that's why I just now asked you to put a pulse here, right? But now not necessarily, because 8 bottle done. Now you count again, another 4 bottle. 1, 2, 3, 4. Just on off. Okay. Just normal count. 1, 2, 3, 4. Okay. Now it's 9 like counting 9 already. 8 bottle is not done already. Again, so again I can count 1, 2, 3, 4, 5, 6, 7, 8.
CV is output unit.
The counter value lah. The counter output.
Then we will take the CV, do the compare.
Yes.
That means the compare for what you need.
Yes.
If compare like I receive the CV is 4, then compare will do their work. No matter how the set point is not reached yet. Okay, then what's the next step? We want to reach to the 4, compare.
Yes.
Then we move mean like we 20 hertz is a hertz we need. Then the output to go back to the set point for the motor.
Okay. Yeah. Okay. The compare down there, right? I don't need to use also. I can do this way. Sensor, CPU, but this one is 4 lah.
Yeah.
So I don't need CV. CV no need, here also no need. Nothing. This one is the move. How much is it? For 50, right?
Yeah.
50 to the set point. This one is the 20 to the set point. So both count. Here also count, right? Once here the movement reach for the output will move 20. Okay? That's all. Here but this one is so okay. Here when I reach 8, the output move. This one. So here need to reset, right? So I can use this reset here also. Count 4.
Oh, okay.
So this one I use one counter, then I compare, right? Instead of I can put another counter here also. Okay.
That means you reset, you have to both also reset.
Both using the same reset lah. This one 4 enough already.
Yeah.
Ah.
Then you have the 1 8.
Because if I reset at 4, reset 2 for example lah. So what happened?
Number 8 they will count also. They will
Yes. Clash number 8. Because at 4 it reset already. Then here become 5, here become 1 again. This one 5, 6, 7, 8, 1, 2, 3, 4. So move at the same time. That's why I use this move here. This reset. I mean, okay, what? This one but not important lah. What I try to tell here, there is no fixed programming format.
Just depend what you know.
Yes, that's it. Just depend what you know. If you know counter only, you will do like this, correct? If you know counter and compare, okay, you will do okay. First one count, second one compare lah, easier.
Okay. Well, not really because upstairs we already set the stop, right? So at the bottom here we no need to set the stop already. No, related or
control related, if you want to stop the motor automatically, then you do some programming for that.
After this volume, stop it.
Yes. Got it now.
Compare lah,
Yes.
like for
That is the
example,
logic lah.
after like now 4, 8.
So depend on your process. How you want. Okay. After this I want to off. After this I want to on back. Like yesterday we did on back, off back, right? Say.
Who will write the logic? I mean not the PLC This all the logic. We need to work that flowchart. We
Maybe okay. It's something like this. Okay. When I do project, okay. When I some so the client customer will give me the flowchart. How they want to run. Then we talk about just these two. Okay. Let's say this one is on actual system. Okay. So they will tell me, okay, when I press start, the conveyor run at 30 Hz. 30 Hz. Then what? Then I put the bottle. Okay, need to scan. When first 4 bottle, it must run 30 Hz first 4. Then after 4, it become 20 Hz. Then when it become 850 Hz, then continue. Then it will be 20 30, 20 30, 20 30. Right?
Yeah.
Correct. Okay. Then at the same time, so this is what the process people give me. Then they will tell me also for safety feature, if the temperature more than 80, I reduce the speed. So they give me the flowchart. From the flowchart, and they will give me the IO list also. What is the IO? So I mean the process people give me the flowchart. The electrical people give me the IO list. Input is what address, I0.0. Output what address. Motor feedback analog is what address. Motor set point analog is what address. Temperature is what address. Okay? From there only I will create a program. So I know okay, all these analog can do scaling, can do scaling. Then I do okay, first start motor, okay, working. Then what is the sequence? They say okay, temperature high, low, okay. Then when the bottle count 4, 8, I need to jump between the speeds. Okay,
One. We must create the start, stop for motor first. Then only can play around what you get the data.
Yeah. Because that is the value, right? On first, right? Then
On first.
you can get the
Get the value.
values, can
Then,
play with
then
the value.
start the scanning. Then we only. That means we no need to bother about the motors. We just want to play on the scaling,
Yes.
compare. That's it.
Because our process is not straightforward. Just like the first one we did start motor run, stop motor run.
Yeah.
Not as straightforward.
Yeah.
We have some flow to
Flow.
follow. So I start motor run, then I follow the flow lah. Just play with the speed, compare with the temperature and also my water. Just play until I press start.
That means I only have one motor. One motor run like this function. Okay. The compare the UCD, I mean calculation everything lah. The math everything right. You just add in the instrument. Like the sensor, transmitter to control back the motor to start.
Yes.
Okay.
You need to add
You right now I know. We no need say like we have to interlock or what, no need right?
no need.
No need right? Because what we can see the program when we start, motor already start. But we need to control the motor.
We are controlling the speed,
Speed.
not the sequence, correct?
Yeah.
When to on, when to off. No, we are controlling the speed. Just play with the speed lah. You want to control the sequence, then control the sequence.
Maybe all from VFD or from transmitter or from sensor.
Yes.
When you want to off, we can play around from the sensor, the timer.
Yeah. Timer, total count, so many like.
Maybe not so complicated on this interlock lah. I mean this is because interlock.
Yeah, that's what I say. It's not complicated. Just on off like okay, just forget about this one. Think about how we do the tank project. how we do? Start while clip on. After the timer cut off, once the high level on, off. So normally we do that.
Another one way is we start a project. We start a new project. We don't need to think about sequence first. Okay, wait.
Yeah.
We have to think the sequence first, but
Correct.
before
I know
we,
what you mean.
before we do the tagging,
Hmm.
we just create start, stop, trip, motor. It depends on motor, how many you have, right?
Okay.
Like you have the three, let's say you have the independent of the, you have the three motor, right? Each of the motor have the start, stop, trip, start, stop, trip. So we just create whatever the IO have, create first. So we build this kind of thing lah.
Yes.
Only create the, we call it the
Scaling,
Scaling.
everything lah.
Yeah, then after that, during on scaling, we don't need to like think what is the number of the, what is the current what's it called IO, memory. We don't need to think, we just define the tag only.
Yeah, can.
Whatever tag you want, you just define.
Define.
Define away, define. That's it.
Yes.
Okay. Oh, like for example, this is output, right? Output for start the motor.
Yeah.
And because you told me last time, if we want to indicate the lighting in the screen, we just like put the output
Yeah.
name and change it. It's 0 and 1. 0 what color? 1 is what color?
Yes.
So this is a move.
Yeah.
HMI, if let's say download the PNG file, put in the HMI also can, right?
Okay.
Later will teach you. No.
No.
You know how to do it?
Yes.
Can you teach me?
Okay, good. We go for break first. And continue with the other line.
If let's say, it's mean like if we do the testing on field, right? We need to have, if let's say we have a programmer, we need the wireman to check also. Because we don't know to check the panel, right?
Yeah.
They know, so they have to check.
They check based on your wiring diagram.
Yeah. Okay.
What we check as a programmer is the sequence lah, why the output's not working.
Why the lighting is on, but there is not only like, for example, the output is going already. Because the lighting here, right?
But the output not moving.
They are not moving, like the motor is not moving.
Yes. So why?
So they have to check. Is it why it's true?
That is mainly wiring lah. Most probably. Most
Yeah.
probably this is the maybe wire break or something. If we see the output and if sometimes we cannot see the output, but you press start, all okay already. So that one is what start stop all okay already, but sensor already all okay, temperature also like this lah, temperature also not this one, but not moving. Why? Then only we go to the program and see why, maybe some interlock.
I have one. Yeah. You see, yeah. Now the output PLC already informed this inverter to run.
Yes.
And the inverter show the
What is the
curse,
current speed?
the curse or current speed. That means got current already, activated already. There means no any issue between the PLC and inverter, right?
Yeah.
But they need to know from the inverter to the drive, is it got supply or not?
Yeah.
How?
From inverter to drive.
Because you cannot like have to always use the multimeter to check output, right? Check, I mean the current output, right?
What do you want to check?
That means I just want the indication only. Just like, okay, now current from the inverter, the current, the electrical is already going to the drive. Just indication, I need
Oh,
an indication.
from the inverter to drive.
Yes.
Ah.
You like between the PLC and inverter, I really
Okay, no. Normally,
But we don't know is it from inverter to the drive got issue or not. But I cannot always use the multimeter to check and see, right? At least something to indicate for me.
Two of them. Function, lighting. No function, no lighting.
Just a lighting from the output
not from the output.
From the-
from the drive.
to the inverter. But this is a three phase.
Three phase but you just use one phase and one neutral. Can lah, but I think it's not that is not a proper way. So you should have a device for that,
Yeah.
where to know whether there's a voltage or not. Or sometimes you will have the current, to know whether the cable got current or not. There's an analog for that. Analog input or digital input also. They call what current transmitter or something.
Oh, okay.
So you can put on the cable.
They need to know I see whether
So
they,
the current-
if the three phase they will
One
come
phase
out.
enough already.
One phase already.
One phase enough already. So
Okay.
you know if there's a current, this is like a ring lah.
Yeah.
So you need to put the three cable, right? One of the cable in already. So just to check whether it's okay or not. From this transmitter, you can get a digital signal. So that digital signal can go back to the PLC.
PLC will show pop. Yeah.
Lamp or something lah. So you can cut off also. So means if you energize the drive must run. When the drive run, I have a current.
Yeah.
So the current transmitter will send an input to my PLC.
Yeah.
So if the PLC send output ready, within 2 seconds I didn't get this input, I automatically cut off my PLC output to the drive.
Then I will show the error.
I will show error.
This is a cable issue.
Not depend on cable issue or the drive is not functioning or something. But we no need to go until there, because when the drive is want to give output to the motor, if the motor is not running, the drive itself will have an error. Drive itself will have an error.
They do VFD.
Yes,
How they know that?
because they're sending voltage, right? So voltage is a cable winding, right? So they know, okay, I send let's say like maximum. Let's say 415. So if you send 415 volt, of course it's a AC. Go up, go in and come out, go in, come out.
Yeah.
So I send already. If I don't have a response, of course the PLC cut off. Disconnect.
Okay.
You know what I mean?
I know you mean because this one also I did this issue also lah. I think this can be my client also about this. You can check for me. Okay, inverter if you don't give any supply or after inverter there is no any supply, right?
Yes.
Definitely will pop out the error.
Yes, of course.
Now the issue is like they don't want a way to open the panel because the inverter is
Then
inside.
then in that case, it means the error is from where? If the motor not working, error is from the drive, right?
Right.
So they need to use the communication to get the errors.
Okay.
If they don't have a communication, let's
From
say
the drive.
yes. If I'm using like this, if let's say I'm using the Profinet. Profinet means it's not only control the drive. So you can give the PLC the drive status, is it running, all that can give also. But in that drive, we are not using communication. We are using hard wiring, right? So if I want to know the status of the drive, I need to use communication. And if I'm not using communication, so like this way lah, like I tell you, the current transmitter.
Normally the HMI, with the HMI we are showing the lighting on the start stop Some HMI, during the running, they will show in the line whether running the green color or no running in the HMI. They will show also the
Graph, is it? You mean graph?
no, from the compressor, let's say from the compressor to the start button. Then they will show a line whether this line is running or not running.
Oh, it depends on your design only.
It's depending on HMI.
It's depend on your design in there. How you will design the HMI.
Let's say we press button, we hear monitor, you can see the green line or the blue line.
Okay.
But the HMI can see also.
No, cannot.
They will show, let's say we start the button.
Have you seen before that?
Yes.
It means they designed that lah. You mean you okay, now my question is you mean in the HMI you see the ladder logic.
See the yes, it's not the ladder logic, it might be some line to show that whether it's running.
Just a
or
push button.
a push button.
Is it a push button or normally open?
A push button.
Push button, then one line.
One film line.
Okay.
So then let's say we press the button, the line will go to which part.
Okay, each part, okay.
Showing the HMI.
So that is the design. They design that like that.
We can put the line in the
Yeah, of course. You put the shape right. And then you put the round right. You can put a square, you can put rectangle. So you can put a line also. So to the line change color is the animation. Got it? It's the design only, how you design.
Yes. Skip to another topic first. Yesterday we say, how about SCADA?
Yeah, when we use this one,
SCADA is communication.
no, SCADA is, you're doing HMI, right? In PC, it is called SCADA. Supervisory control and data acquisition. So, we finish this motor, we do a simple SCADA. At the time, we learn the DB also, because we haven't learned DB yet. So we need to fasten.
The SCADA. Is it need to buy something? I think the format, software for the screen. Yeah, I mean for the.
It's not a screen actually, it's a PC.
It's for the.
So you need to install the WinCC software.
The WinCC like
TI portal.
have to pay like money.
No, it's a license.
It's a license.
Like okay, in our laptop we already have this kind. So sorry. I see this one. Message, keep on messaging people. People keep on messaging for training. Okay. So what I did?
SCADA.
Okay, SCADA is like a PC. So you need to install the TI portal software. That's all. With the license, the SCADA license.
So maybe we create inside the software.
Yes, then
Link it.
just connect to one Ethernet cable. Just click one time, it will open the SCADA screen.
Then they mean like the HMI, you just edit this logo when you design, like the memory is.
Exactly same like HMI. Only thing is, like HMI we choose what? KTP400. SCADA means we choose PC. That's all. Later we do.
So
Later we do one simple pro.
Okay.
Once we do this one, then I connect the HMI also there. Simple. In the HMI is simple lah. Just start stop only. No motor value all don't put that. In the SCADA, we put start stop, motor, what is the motor speed, what is my temperature now, all that like a bigger one lah. We do a simple and make sure we cover all everything. Okay, good. But this one, this drive will be complicated. This drive. So just follow with me. We do one program first, we test first, then you ask me questions. So because when you starting time, you sure you will have what? Confusion. I'm not sure. Okay, good.
Okay.
Okay, go for lunch. Go buy lunch.
Halo Ali. Bukan potong silikon, bukan. Sebab dia dengar tak?
Ya, ya bos.
Okey, sekarang mereka pernah letak satu itu firm jaga itu window, betul?
Ya bos.
Dia pernah laminate satu benda jaga window, betul?
Ya bos.
Tapi dia sampai itu aluminium profile, ada silikon, dia potong silikon.
Oke.
Untuk kasih dia itu laminate boleh lekat.
Oh.
Tadi tanya dia mana dia ada potong silikon, kita kena letak balik. Nanti tak ada itu window yang besar.
Oke masalah tapi silikon tak ada kira-kira bos.
Dia buat window punya orang mungkin dia ada. You nanti tanya dia ada tak? Aku akan tanya dia juga. Okey ya.
Oke bos.
Okay, thank you. Okay, thank you.
Have you got your lunch? Told you to take away to some chicken rice.
I can wait around here.
Yeah, just wait for him to come. You can have him.
Right? That's all everything okay? You let me know.
Yeah, still installing. I just only now started to install PLC SIM. Is there anything else he told you? Anything? For DIA portal, because version 18, I don't know if you mentioned or not, panel image for version 18 is not included. But version 17, version 16, version 19, version 20 they have. Version 18 they don't have. So instead of panel image, they call it comfort or something. That one, the panel image is for HMI,
Yes.
for HMI comfort,
Yes.
the comfort model, right? I don't know much about it, but if you're using that, you can install the unified comfort. The installer is also inside there. So my recommendation, the folder will be in the desktop. If you have an external drive, thumb drive won't be powerful enough for you to transfer all the file. So it's better to have an external drive. External drive, the M2 slot external drive. But that will be powerful enough to keep. Yeah. I mean SSD, right? Yeah, external SSD should be okay. You transfer all that file and keep it as a backup. Okay. So right now it's just going to be the basic HMI you can still use and troubleshoot and check the program if you want. But suddenly if you encounter like the comfort, the advanced one, those advanced panel, then you have to install those additional optional drivers, or not drivers, installers lah. Yeah. So for now I will install the DIA portal version 18, PLC SIM Advanced, and the PLC SIMs update including start drive. Start drive is this one, Dynamics. Yeah.
And for the HMI what's this? Simulation.
HMI simulation is the WinCC lah. It will be included because DIA portal will be included with everything, right? Yeah. Because that one included, right?
Yes.
Because this one, that's why you ask him first. Make sure you ask him if the DIA portal is included with the HMI and everything.
Okay.
Because when I do the installation, I will be done. Then you just give it a check. If you miss something, you can install. Good boy, taking hell of a time. Because there's one problem with this Windows 11. Windows 10, we don't face this issue because Windows 10 is the older model Windows, right? Windows 11, what happened is the recent update in May. I think in May, because in in May. The recent Windows update, what happened is, it crashed the automation license manager. So if you can't open the automation license manager, it becomes buggy. If it becomes buggy, what happens? You cannot open the software. So the license is not being implemented. Yeah. So to resolve that issue, you need to uninstall the old version, the current version of the automation license manager, and then reinstall the new version, which is version 6.8 or something.
I faced that problem.
Because obviously most of the people using crack version. Even but this issue faced in a original license as well.
Me is like,
So I was scared. I thought the crack version is giving some sort of bug, the blocking or what. I thought like that, but actually no. It's the automation license manager buggy. The older version is not compatible with the new version of the Windows really anymore. So that was an issue. So to resolve that, you need to uninstall the current version of the automation license manager and install the new version. Before you install, it might skip the installation and it won't install. Why? Is because you need to do the Windows update, and then you need to add the net framework features and everything. You must update everything, must make sure the Windows update is all fully updated, then only you can proceed with the installation. Face this issue with all my clients.
I had a similar experience with KTP400 version 14. So the automation license manager, it cannot work.
Is the was Windows 10 or Windows 11?
Windows 11.
Version 14 is not stable with Windows 11.
Yes.
The automation license manager is a different issue, but Windows 14 is only compatible with Windows 10. Because if you go through the manual, you go through their installation guide manual, it clearly written over there. They for sure written over there, there is no Windows 11. Only compatible with Windows 10 Pro, not home language. There are two types of Windows. No? If you see in Windows 10 or Windows 11, there are two types. One is home single language, they will call it. Another one is Pro. You must install this software in only Pro. Home single language is not supported. Still can install, only the basic. The professional edition cannot. Professional edition is only compatible with Pro. Windows 10 Pro or Windows 11. So when you face that issue, it's because of the automation license manager, because you install it in Windows 11 and you update your Windows 11, it becomes buggy.
So
Some people I give them two options. It's either disable the update, pause the update completely, or continue and then reinstall the new version.
yes, that's what I did. I installed a new version.
Just the automation license manager. Yeah.
And when I had the issue, I have nothing to do with Siemens, but I am I am looking after a machine because I have experience in hardware, Siemens hardware and all this. Not only programming, it's just basics. If there's one input not working, okay, I assign new input like spare input, and then we use things like just basics. Then when I have this issue, it's a new issue to me. I got panicked, and then night I went to the room, I went to YouTube, I typed the error, so there's a lot of things. And then they told me that, oh, you can try to do this. So I did everything, and the last thing is I went to Siemens forum. So I typed my issue, then there was someone replying, he said, you get a new
automation.
Yes. And then you install. When I did that and it worked, I got a day off and I went and drink beer.
So this is your first time.
Thank you so much.
Because this type of laptop or information laptop, there are certain maintenance you need to prepare. Try not to use this keypad all the time. Just use the mouse. Try to keep this keypad. If not, if you keep on using it, yeah, the process will more. So it will tend to spoil very fast. So try to use the mouse, small mouse, and then try to make sure I have given to you the cover pad. It's completely free with the camera lens. The one it's mine actually, I just put it for you. Because make sure no dust enter into the cap of this keyboard. All need to maintain it. But it's solid. It's very solid. Dell and Lenovo is very solid. But yeah, Lenovo will be a little bit expensive. Okay. Then there are certain things I can show it to you. It's like command prompt. If it becomes so slow or what, MEM readout I have already installed. MEM readout it will try to clear off any any type of application that is running in the background. It will clear off for you and just keep it stable. Another one is if you go to command prompt, you're typing command prompt over there in the start. Normally you ping IP address to command prompt, right? Yeah, right click as administrator, right click, run as administrator. Make sure run as administrator, click yes, is okay. Click yes, and then type in SFC / scanner. Scanner, SFC / okay, yeah, that's / SCANN OW. Yeah, you just press enter. And when you press enter, it will start scanning all your registry file in your system. It will scan and it will, if there is any form of bug, it will resolve it. And if there is no bug, it will tell them everything is perfect. It will resolve it and just tell you, okay, now it's perfect. But my advice is, after I do this, I just restart and just continue my work, or you can just continue. It's completely up to you. This is the same thing it does with your free antivirus system. Instead of downloading the antivirus that is being very marketable and will slow down your entire system, just do this simple. Because Windows 11 security system is already very powerful. It's already enough. And not like me using. I went into all forms of websites and everything. I'm a very dangerous person, so yeah. So I need a VPN, I need a full version of antivirus, I need everything. I need to fix a VPN over here in my system so that others and other customers use, they can feel safe. So I have to do everything here. So yeah. Getting all this software from my supplier is from China, so one of my suppliers from Russia and another one from Mexico. So this software, once they release, they will just publish it to me. If you are interested, you can have this software group. Okay, yeah, no problem. Thank you. I just download it from them. But I have to use a VPN to make sure I'm not tracing it. This Siemens is okay, but Allegretti is not easy to get.
That's very so.
Allegretti software is not easy.
Means Allen Bradley, Omron, and Siemens. I only do like hardwiring, troubleshooting, and to the extent of like basics.
But when it comes to software, it's complete zero knowledge.
Software
Many
is
people come here because of that. They do all the hardwiring. They know how to build a control panel and everything, but when it
Yes.
comes to programming, they
yes, I'm one of them. So that's why like program I saw the program, but I don't know how it works. For Omron and Siemens, I just do basic programming like assigning new inputs, new outputs. That's all. Adding like counters, timers, all this. But to the extent of like now what we learn is unstable. That's why I decided to.
Yeah, some people complain 5 days is not enough. I can give you more, but if you're willing to pay me more, I have no problem with that. I have no problem. Have to practice this. That is why we give all the content and everything. So you can check your email. I think you should have already received your digital copy of this.
Ah, okay, thank you.
you done, you say first lah. Inside this only we going to add.
Want to check the start is an input, stop also is an input, trip also input, but there is not any button for the trip, right? It's a
From the contactor. Normally from the contactor they will add auxiliary contact.
yeah.
Ah,
Then after when you detect something,
yeah.
they will go call the PLC to off something.
Okay. Now, add new device. Drive. So this drive software you need to install separately. When you install the AI portal, you will get all these three. Okay. Okay. Go to Siemens G. So this model is a Siemens G120. G120. No, G120. Yeah. Control unit. Okay. So this model, you can see this part number inside lah. So this model is a CU250S-2 PN. Right there. Yes. Okay. The version weight, the version choose 4.7.10.
4.7.
Yes. Why? That's the version.
Oh,
Yes. Like this PLC app version 4.7, 4.6. HMI good version, so it's good version. The firmware, they call firmware version. Okay. Okay. So now this is your control unit at the top one. The bottom one we call power unit. Okay, click on the power unit here. The power unit is a PM240 FSA. The second one. Oh no, sorry. I think not this one. PM240-2. Okay, single phase. Yes. Okay, FSA. Second one. That is the part number. This part number is the one, the power unit, the bottom one. Okay. Just add here. Okay, done. Now click on this, the device network view. And you add the HMI, is it?
Yes, just I'll try.
Okay, never mind. Just leave it. Those who didn't add, never mind, no problem, no need to add. So from the PLC, click the green color, drag and connect here. Okay. Alright. So this is how you do ProfitNet configuration.
confident configuration.
Means from the software you can choose the drive you want to use. Okay, then you click on the network view. Yes. So your PLC is 1, the drive is 3. Okay, okay. Wait. Okay. Now, we do the commissioning for the drive first. Okay, click on the commissioning. simple lah, basic step by step commissioning ah. Okay, commissioning result, click that. Yes. Okay, commissioning is what? Remember for that drive, right? We do some setting, parameter settings, right? The same thing here. Okay, but this is within the software lah. Okay. So it's a standard drive. Okay, next. So PLC will send the data to the drive. Drive will control the motor. Okay. Next. This one only. Next. Additional modules and functions. Okay. This is the IC 50 Hz. So the drive is 230 volt, right? From 3 phase. Okay. Next. Braking resistor. No braking resistor. Motor configuration. Click here. Enter motor data. Click here. It is an induction motor, right? Okay, it's a delta connection. Okay, so what is the current, rated current in the motor? Double click. So like this, just now we see this one recently here, right? So the 200, we are using 200, 1.28. Then the motor kilowatt is 0.18 kilowatt. Then the RPM is the 1310 RPM. Okay, done. Enter. Okay. So no temperature sensor lah, right? No temperature sensor. Okay, next. Brake. Okay, no brake. Okay, what is the RPM? 1310. 1310. Okay, maximum speed also 1310. Okay. Ramp up, ramp down time, the acceleration and deceleration. So you just put 2 seconds lah, 2 seconds, 2 seconds. The quick stop is if suddenly got error or something, cut off. So that is 0. Okay. So current limit is based on the previous setting lah. Okay. Okay, next. So it's a constant load, linear lah, right? Constantly go up and down. Then identify motor data at standstill means now we do the commissioning, right? So it will do the like auto tuning. Okay. Next. Okay, finish. This is the all setting you do lah. Okay, finish. Okay. What we did here is the parameter setting. So we have the software, so we can do the settings. If we don't have the software, we manually do go and do that. Like what we did in the drive. Not hardware, I mean the settings. Just now we do the settings, right? So manually we go here and do the settings. Okay? Since we have the software, we can do the basic. Because we want to do a basic control system. And we set the speed, okay, increase. Then start, stop, then speed settings. Done? Okay. First what we do, 1% lah, that laptop, that one, okay. We click here, download. Okay, start search. Okay, look. So just now we use the software to do, right? So each drive they have their own software, their own brand, own software. So you can do the same thing, lah. Okay. Some drive is this one is they have like basic step by step. So when you set, it automatically set all the parameters. Some drive software, we need to do, just now we do the manually one by one, right? We do. Normally we will be in factory setting. So which one you want to change, you can change. Okay? Or in the drive, in the screen itself, you can change also. Okay. Look. So means what I'm doing here, I add same like the PLC, I add a drive, I do the commissioning, means the basic settings, basic parameter setting, and I download the settings to the drive. Okay, similar to what just now we checked on the parameters. One by one we check, right? If anything want to change, we can change.
We have the PLC HMI 300. The drive is installed by ourselves.
Yes,
So
separate software.
we brought the driver, so we connect, so we will automatically.
No, you itself tell you, just now you mentioned need to install, right?
Yes.
You install separately, not connect automatically. No.
So install from the Siemens.
Yes, buy the software.
Oh. So let's say
We
we
call start drive. For Dynamic, they call start drive software.
let's say we buy a driver. They will give us the software also to install.
When you buy the drive, so far when I buy, they don't give that. You can download from the Siemens website. But for start drive, I don't know. I think no license. Drives mostly lah. If you ask me, because I've done for this 11 years to say, no license. You can go to the Siemens website, just register your account. You can download some software. You can download. So one of the software is the drive software. Okay. Now ready? Go online. What error? No, but warning. Never mind. Warning, no problem. You bring it up. You see what is the warning? No, this one I think the previous one because loading completed. You go to right or make it this one make it smaller. The here. The go to make it smaller. No here this one. Yeah, want to see the time. 11 o'clock. The previous one. Okay. You click the drive. Go online. So what I'm doing here, I download already, right? So the last setting we do the auto tuning, right? So I want to do the auto tuning first. Okay? So same thing, okay, go to control panel. This one can close first, enter you open. Activate. Okay, so you see, if you activate this auto tuning, my PLC cannot control. Okay, now I'm doing auto tuning. Okay. Accept. Okay. You set some RPM 1000. Enter. Okay, click forward. It is stationary measurement in progress. Okay, it's not rotating, right? So this one will do auto tuning. So auto tuning, what happen is whatever the set value just now you choose, right? RPM, motor voltage, motor power, motor amp, right? So the auto tuning means what happen? It will give the 50% to the drive and see whether I can get a feedback or not. So that is called auto tuning. Okay. Tuning is done. Okay. Enable the drive. Yes. Can you see? Ready for switch on. Okay. Forward. And run. Okay. Stop. We are just testing the drive. Yeah. Okay. Reset. Okay. Enough. The drive settings is done. Okay. Deactivate. Okay, accept. So once you deactivate, then only the PLC can control. Okay. Now can you see there's a lamp, right? LED on, red color. On the drive,
Yes.
red color blinking, right? You see what is the BF bus fault?
Yeah.
Bus fault means no communication between PLC and the drive. You know why? Because just now in this program we have a PLC, we already add the drive, and we download the drive configuration to the drive. Okay, so whatever the drive know, I have a PLC in my network, but PLC we haven't downloaded yet. Now the PLC is alone. So once we download the PLC configuration, then the error will go off. Okay? Any question until here?
This is only for the LAN cable, right? I mean for the Siemens drive.
Yes. Siemens drive, I am using a communication. Doesn't matter it's a Profinet or Profibus, it's the same way. Okay?
All the model we can choose from
Yes. So whatever I install is a they call start drive software. So under start drive software, all the SIMATIC drive you can do the settings, commissioning. Okay? Can? Still okay? Can
So let's say we doing the communication, we don't need to do this type of the wiring, right?
No need. I didn't do wiring work.
So only the LAN cable.
Drive can control three ways. Number one is PLC VFD, PLC VFD, PLC VFD. Okay. So the first one is just the my PLC just DO only. Okay, so means my PLC just control, means control on off lah. Okay, the speed I need to set here. Okay, second one is DO and AO. AI we don't care lah. Okay, AO means the PLC can control on off and can control the speed also. That's why we did for the blue color motor. Okay, so if you want the feedback, is the AI. Okay, third one is the communication. Okay. So communication, the PLC can control on off, control the speed, can get data. For example, the status, the VFD status lah. The VFD status, whether it's run, is it stop, is it a fault, everything. Because communication means you can get so many data. Okay, so now we are doing here, just now we do here. This one and this one similar lah, wiring. Okay? Clear? Okay. Now, done, ready. Now you go offline. Okay. So later, if the other two other two laptop want to communicate, you don't need to download the drive. Because you already downloaded the configuration. Just download the PLC program. Okay? Now go up. All the way up. Okay. Click on the drive and device and networks. Open. Okay. Click on the drive. Double click. Right click the SIMATIC property. Okay. So got so many. If you want to change internet address, click here. The address lah. Okay. The most important is the Telegram configuration. Okay. Open. drive, send. Okay, so means this is the data I need from the drive to the PLC. Okay, open. Alright. So from the drive to the PLC, you click here. Got so many telegram data. 1, 2, 4. Okay. You click 1. It means I can get 2 data, which is word. Means I can get 2 words from the drive. Okay. So what is the word? Later we discuss. Okay. Means I can get 2 data. If you click standard telegram 2, I can get 4 data. Okay. So each data they have their own meaning lah. Okay. Okay. So this one, this standard telegram, what data it give you, you need to refer to the SIMATIC manual. Okay, SIMATIC manual. From the manual only we can know how many data we can get. Okay. So we just use 2 data enough. Choose standard telegram 1. Okay, can I erase this? Can I? So where to go? When you go to SIMATIC drive, so many set how to do settings, parameter setting, everything. There will be one part for communication. Under communication, got so many communication types. Because this drive is not only for Siemens, can control from other PLC also. So you go to the Profinet section. They will tell you, okay, standard telegram means 2 data. So 2 data means 2 words lah. 2 words from the drive to the PLC. So we call what? I, input. I, so it's a word. Starting from what number? I 256. Can you see? So in the drive they call PZD. In PLC is the this address. Okay? I 256. PZD means process data. Okay? So in the PLC is 256, and they say how many data? How many words? 2 words. So next one is IW 258. Okay? Okay. Now, when you refer to the manual, they say IW256 is what data? You need to know what. The first one is what, second one is what, right? Then only you can do program. The first one is the status word. Okay, status word means the status of the drive. Okay. Second one is the actual speed. This one similar to this drive. The feedback, right? The analog input similar. Same concept lah, right? When the drive running, I can get the feedback. Here, when the drive is running, I can know whether the drive is forward or backward, or stop mode or fault mode. Okay. If I choose more and I go more, each one they have their own meaning. So it indicates from the drive. Okay. That is the from the drive I get. Okay. You click receive. This one is from the PLC to the drive. Output lah. So I use the same standard telegram 1. So it's what? QW25. The 256 can change. 258. Okay. So the first one, if you refer to the manual, they say the first one is the control word. Means you send data to the drive, forward, backward, stop, reset, everything. Okay. Then the second one is the set point. Okay. The set point into the drive, same like my analog. Okay. So these are the data. Then when you refer to the manual, they will say your actuals, the set point are most important. Set point for analog, what is the value? 0 to 27,000, right? Means it's a 10 volt. So 10 volt you send to the drive can run maximum minimum. So the set point, if you refer to the manual, they say 0 to 4000 hexadecimal equal to 0 to maximum speed. So let's say I put 1310 RPM means if I put this value here, the motor run 1310 RPM. Okay, same concept as just now. When I put 27648 into QW80, motor run 50 Hz. Because PLC set can go right, similar concept. When I run, when the motor run, I get the feedback. The feedback is also 0 to 4000 hexadecimal. Okay. Now control load. How the control load? Because like this drive, the other drive is a hard wire, right? How we run forward, backward, on and off the relay, correct? But here they didn't put any relay. It's a communication, right? So it means very simple. This is the word 16-bit data. Okay, means each bit they have their meaning. Bit number 1 is the enable run. Bit number 2 is the follow set point. Bit number 3 is the no error. Bit number 4 is the clear fault, something like that. They have a 16-bit. All the 16-bit they have a meaning. So also you need to refer to the manual. Okay. So what I do if I want to run forward? How can I do forward run, stop and reset? These are the command I need to send to the drive. Okay. So how to send? How to value? Right? This is because only one word can control all this. It means each one have different value. Okay. Means if I want to run forward, I send one number to here. So the drive will know, okay, this is number 1. Because like I said, the 256 means Q256.0 until Q257.7, 16-bit, right? So each bit they have their own meaning, right? 101010. So if I want to run forward, this data also you can get from the drive. I need to send 47F in hexadecimal. Okay. If I want to run backward, C7F, stop means 47E, reset means 4FE. Okay. If you type this one in hexadecimal, if you convert to binary, it means the 16-bit drive, some is on, some is not on. So if you compare with all these, you can know already. Okay? But you cannot go deep, then it will take a long time. Okay? The concept I want you to understand is you send different numbers to here. So what happened? This is what that day we did. When we key in 10,000 in MD0, some of the memory is on, right? The same concept. So if you send this number to here, some of the bit is on, the bit is between these two. Okay? Then when I run, so very simple. You set the speed here, then you send this number to here, motor run forward. That's all. When the motor is running forward, I can get the feedback, and here also I can get the status. Status later we see I forget this one. This is stop mode lah. I think it's a AF30. Later check BF37, something like this. But later I confirm. Okay, so I don't want to write now. Okay. Any question? So first we try to understand the concept, how it's working. Okay, how it's working. So once I do this communication setting, I able to select how many data I want to send to the drive, how many data I want to receive from the drive. That's the first thing. That is the standard telegram. Okay. Once I choose here, they will let you know okay, how many. Two data you send, two data you receive. Okay, two data you send, two data you receive. So what is the first data and second data? To check in the manual. Why I use these names? This is the common name they use in the drive manual. So
You
that's
mean
why-
you just follow the drive manual only?
Yes, yes, all must follow the drive manual.
You mean like
Because he didn't do like that was like that drive, so we follow the drive manual, correct? Because set the drive and according to the manual, S1 is the forward, S2 is the backward, I need to give 0 volt, right? Then the analog input is the 0 to 10 volt, analog output also 0 to 10 volt. All the data from where we get? From the drive. The same concept apply for this. So when you go to the drive, but it's not hardwired. It's a communication. So you go to the communication section, then go to the Profinet section. Because under communication we have a Profinet, we have a Modbus, we have a ASCII, so many formats. Okay. So now we are doing Profinet. We go to the Profinet. Under Profinet, okay, they will tell you okay, this is how you do the communication. Once you do the communication, this is the total data you can take from the drive. This is the total data you can send to the drive. Okay, I think if I'm mistaken, if you send that, if you send to the drive, I think it's around 4 data only that. So control the drive. Second one is the speed setting. Third one, if I'm mistaken, is the torque control. You can set the torque value to the drive. If it involves torque everything. And fourth one I can remember. Normally it's 2 only. Feedback and then get many feedback actually. Because feedback, okay, first the status lah. Whether it's a forward, backward. Second one is the what is the actual speed, what is the running speed, what is the torque value. If the temperature sensor is installed, what is the temperature value of the drive? What is the status? If there's an alarm, what alarm? Everything can take. So the data from the drive to PLC can take long. Okay, so we do a simple settings. Okay, any question?
Just now let's say we want to forward the motor. We send the 47F
Yes,
and 0
and 47F to the 256 means I can use the move function.
the send is defined as how to send.
Use move function.
Or use move function.
Yes. How? Wait. I will do that first, then you can clear, okay? So that's very simple. When I press start, what I want to do? Forward, right? Use move function. I move to where? Like just now, the same concept. We do set points, right? So where to move? Here, right? QW256. Okay, move what number? 47F. Correct. So 47F is in hexadecimal. So we need to put 16 hashtag 47F. So this is the format. Okay. Okay. If you want to set in decimal, just now all we set in what real, right? You want to set in decimal number. You convert this. If not mistaken, this one is in decimal is 1151. If you convert to decimal, so it's up to you. You calculate. Okay. Hexadecimal, hexadecimal. Okay, 475. 1151. Okay. Change the 4000 hexadecimal. What do you get? 0 to 16384. I think so. No. I think 4000. Okay. In decimal. So, how to control motor? Very, very straightforward. That is, when I start, I move this number to here. Motor is ready to run forward. How to set this number? Use the scale. Now the scaling, what number I use? My set point is 0 to 1300. Convert to QW500, right? So what is the range? 0 to 4000 in hexadecimal or 0 to 16384 in decimal. Same concept like we do scaling for the analog. Okay? Can? So what now we do the program. We do a simple program. Then we can understand.
That means only have two type for this drive. Hex or decimal.
Normally in the drive manual, normally they use hexadecimal. So it's up to you. You want to use decimal or hexadecimal. Both also the same thing.
For SIMATIC, right?
No, all drives same.
Whole drive. So
All
the
drive-
whole drive is either decimal
Integers, no real.
or no real.
No real.
Oh, it's integer but it's under hexadecimal or decimal.
Yeah, all integer. Only the they call integer means data type. Only the format can be hexa or decimal. Okay. This one done, right? Already we set everything, right? Okay. Now you right click the PLC, no, the CPU. CPUs. Download the hardware configuration. Start search. Okay, finish. Now got error. The PLC, the drive. No, right? All green.
Yes, all green.
Yes, because now PLC know this is the drive. Correct. Okay, now the PLC know this is the drive. Huh? Okay. You add new block. You do a program for that. FC. So you put a dynamic control. Dynamics, SINAMIC, MIC control. Okay. First we do the speed settings. Okay? Speed settings, the scaling lah. Okay. Then just now for that motor, right, we already used the start, forward, stop, start, forward, backward, stop, right, already 3 used already. Okay, so what I want to do is, because for this I need 4, so stop button we use back the same stop. Okay, then the sensor for your project or sensor, right, you also do the sensor now. The sensor you change the address, maybe different, maybe 1.0.
Yeah. Others are
Others,
don't use
okay, don't use. So starting from I0.01, the 0.03 is the forward. You put this one forward, backward, and the last one is the reset. Okay, I might do one by one. Okay. First we do the scaling. You put normal scale X. Then you click here. At the branch, same normal scale X. Okay. So first I want to do the set point. Then only I can get the feedback, right? So set point, who need to key in? You need to key in. So we need to put memory. So you want to use what? Integer or real? Integer lah better. This is real, real, real. This one must be integer. Okay? Can? First, here. This is the my set point. So what you do, you put the name later defined lah, so automatically memory, right? Okay. You put SIMATIC set point. RPM. Okay. Right click, define tag, global memory, MW6, okay? Leave it, automatic, define. Okay. So what is the range? RPM range.
0 to 1310.
Okay, good. Norm X1. Because this is another FCR, I can use the name. Okay, right click, define tag. Okay, use a local temporary. Okay, define. Yeah, put norm X, norm X1. Okay, change here, also change back. Okay, then here the output is what? Set point is what? QW258, right? QW258. Enter. Rename. You put SIMATIC set point. Okay. So what is the range for SIMATIC set point?
We're using integer. We're using real.
No? Here. For this one, integer, right? So what is the range?
0 to integers with decimal point.
No, this one, right?
Right.
What is the set point range? This is the one, right?
0
Yeah,
to
this one,
400.
So it's up to you. You want to use hexadecimal or decimal?
If let's say decimal,
0 to 16,000?
just key in on it.
Yeah.
0 to 4000 right? 0 to just key in on it.
Yeah. So we key in 0 to 4,000. Okay, what do you do? 0, decimal 0, hexadecimal 0 is the same thing. Correct? But I want to do 4,000, right? Put 16 hashtag 4,000. Put 16 hashtag 4,000. Yes. Okay. Yeah. Then only this one will recognize this. The 4,000 mean is an hexadecimal. If you put 16,000, you just key in 16,000 enough. Both are the same number only. Okay. One we using hexadecimal format. One is we are using decimal format.
That means the X format we have add 16.
16, yes. Because if we put 4,000 only, the software will keep 4,000 in decimal format. So it's 1/4 of 16,000. So the motor cannot run full speed. It will run on. You key in 1,300, but it will run only 1/4.
The front 16 meaning the bit.
No, 16 means it's a hexadecimal. Hexadecimal is 16, right? What's your question just now?
Sorry, I missed out on some things. Can you switch?
Where? Which one?
For the
Local time. Yes. If you're using global memory also can, no problem. Okay, delete, put again. Okay, choose the dynamics here. can use back the same thing. Yeah, value. Zero. Okay. This is 16 hashtag 4000.
So helping to check.
I installed for the PLCC.
Okay, the output is this one, make it small. Okay, small. Okay. So it's what address? QW258. Yes. Key QW258. Okay. Yes, it's a global approach, right? Okay. Now for the feedback. Where I get the feedback? Here, right? Okay, put integer to real, then real to integer. Because I want the RPM in normal decimal, normal number, I don't want decimal. Okay. So what is your input?
Set point.
Your input.
Actual speed.
The feedback, right? Actual speed. So IW258. What's the value? What's the range?
0 to 4000.
Yes, that's for that. But now, here what I want to do, I want to use, okay, never mind, I put 0 to 4000. So I convert to what? No, local time, correct. Local time. Okay. Then double click, change the one. Where is it? Okay, double click, erase that one. Okay, now max convert. Okay. So what is the range?
0 to 1310.
Yes. And yeah, 0 to 1310. What is the output here?
Actual speed.
Actual speed. So it be a memory. 0 to 1310.
if we want to get the data from inverter, right, we must create two line of the non-X, QX, non-X, QX. The non-X will be the data we need. The first one, I mean the first one. Like we set.
No, first one is the data, we want to control the drive.
Yeah.
So I need to send a speed. That's all. So I key in RPM and the motor run in RPM. Same like just now. I key in Hertz, 0 to 50 Hertz. The motor run 0 to 50 Hertz.
The first one will be like
Set on.
motor, set on.
Yes, to the drive.
The second is a PLC.
No, first one is to the set, to the drive.
Yeah.
Second one is I receive from the drive.
Yeah. But can I declare like the first one is like you need to get the data from drive.
No,
Then
first one you send the data to the drive.
yeah, I mean like okay, if we do the conversion, right, the first one must be the drive like 0 to 1003.
Yeah, the unit
The
is,
unit we want.
yes,
Then after we convert, after that get the set point.
yes,
Then the bottom is like the PLC need to convert back to show
yes,
the data.
yes,
So that's why what is a PLC have is like 0 to
4,000,
4,000. So we get to convert back to get the
the
data.
RPM, yes. Same like your analog, right? Same like your analog. Only the just the position is different lah. Just now, first we did input then only output. Just now lah, I mean the position here, I put the output and the input. Second one, right? That's the position only different. Both the same thing. Okay. Now, go to next network. Okay, click here. Now I want to do this one. Okay. You put normally open I 0.3, right? I 0.3. I think your sensor one is a
Yeah,
sensor.
I put I8 or
Okay.
something.
Alright, okay. You rename. You put Dynamics forward. Okay. Okay. Put move function. Okay. So move what? If I want to run forward 47F, right? So put 16 hashtag 47F. Okay. Then I move this number where? Go to the control word. Right. Okay. Put control word is what? QW256. Right click the QW256. Put control word. Okay. So do the same thing for backward. Just add below, add a branch. Normally, no, what you do? You just highlight these two things. No, I don't need it. Add a branch. Okay, highlight these two. Okay, copy. Okay, paste it. Okay, so this one I 0.4. Change to I 0.4. No, not rewired. It's a new one. I0.4 is a new one, right? Put new one. Double click, change I0.4. No, delete that. Delete. Create a new one. It's a new, right? I0.4. I0.4. Okay. Right click. Rename. Dynamic backward. Change. Okay. So backward, what is the number? C7F, right? Okay, put 16 hashtag C7. Okay. You click here. No, click the line. Add a branch. Paste. Right click, paste. No, you already copied this now. Again. Okay. Now delete the dynamic format. Forward. Delete. Just now you have a stop, right? Where is the stop? No, not that stop. I think I0.2 stop motor. Yes, use the same stop. Okay. Okay, stop what number? What? 47?
E.
Yes. Enter. Okay. Click here. Add another one. Paste. Okay, this one is the you use the last set switch I0.5. Change delete I0.5. Right, rename, reset. Okay, so what is the reset number for FE? Okay, go up. Okay, in the command, no, network in the command. Yeah, you put this one. Forward equal to 47F, backward is this, stop is this one. So when you later you refer, you understand. Okay, save. Okay, now we test. Okay, so let Moses download. Okay, so just download the PLC program in a Before that, go to the main, call the block. Okay. Click the PLC and download. Download software on. Because hardware just now we download already. Can you see the drive got error now?
Yes.
But now it's a different error.
It's a RDB.
Ready.
RDY.
Ready.
Ready. Yes.
Go down. Okay. Go HMI input. The drive. Click the drive. Go online. Go online. Let it do it. Change this one to internet. Okay, start search. So you want to know lah what error? What's got error suddenly? If BF means we know it's a communication error. Okay, go online. Okay, go to online and diagnostic. Diagnostic. Okay, diagnostic. Active alarm. Okay, what is that? It said set point timer. Means no set point. That's right, no set value. Okay, this is a new project, right? Okay, good. Go to dynamics control. Monitor. Okay, where is the set point? This is where I do the set point, right? Okay, you key the set point. No, the number. Yes. In between this lah. Put lah 750. Okay, it's okay. So already has a set point. Can you see? I said supposed to be 0 to 4000, right? Can you see? 6879. Why? Because this 6879 it is in which format? Decimal. Right? In this format.
Oh.
You right click here. Display format. Tag. Okay, choose hexadecimal. Right click here. No, I think you right click the set point. Yeah, set point. Set point. Right click. Okay. Display format. Hexadecimal. Can you see? It's in hexadecimal. Okay, good. You go down. Okay, now got error, right? So what I have to do when I got error? No, just now got error. I already add the set point already. The value okay. But how to remove error? It means if I move this value to control word, my drive will reset. Okay? You go down, where is the drive? Which one? Last one, right? Reset. Okay. You turn on the last button, switch on and off. Can you see what's the number? No, just on, one time on off. That's all leave it. Because you don't have a push button. Okay. What is the number now? 47F. Correct. Right, the 16. Okay. Go up. Slowly, I want to see this score. Okay. Now you press the stop. Stop, I think the third push button. You press hold. Let's see. So, really. I think this one is still on. Off this switch off. Okay. Press stop. Leave it. Just now the switch is always on. So it's always moving. Okay, because we do program here, we assume all these are push button. So when we do testing also on. Okay? Okay? Backward, go backward. Second switch. Switch. Selected. On, off. Off back. Yes. So when I on this one, this value move here. So what happened? Inside here got 16 bit, right? So the 16 bit is 10110. So if at QW256 I receive this number, I move backward. So it's not like that drive. That drive we on like output. Correct. Because why? We energize the relay. So we have to use the output Q0.4 and 0.5. But in this drive, what happens is they give you only one word. You use the one word to control all the way. How you want to control. Forward, backward, stop, reset. So you have 4 controls. Right. So how am I going to control? In word. Because they give you word only, right? They didn't give you bit. Let's say they say just now when you see the settings, right? They didn't say 16 bits from the drive, right? They say 2 words. So the first one is the control. So if we send this data to here, this is how it works. Any question? Try to understand the concept. Okay,
Can we say like this one is used Confinet? You do the communication. All the setting already have inside the PLC. The PI portal.
Yes.
Yeah. So whatever you do, whatever you set, all the command, you just follow back the manual of this setting.
Yes.
That's it.
Yes.
You don't need like do a lot of the conversion, or you need to put the delay like this.
Yes.
You do the reverse forward.
Yes. Okay, so when you do communication, from the communication, in the software itself, it's already give you already 2 data for input, 2 data for output. Okay, so just press stop. So it's up to you lah, which one you want to use.
Can I say like in the SIMATIC drive, right? We have three. Almost they are fixed. Like I don't say like QW256. I mean the words. Okay, and also
It's
like
fixed.
like the status already
Yes, it's fixed. The first word is the status word.
Yeah.
Second word is the actual speed.
Yeah.
Already fixed.
Fixed already. So we just want to check whether we want to put at the IWM
That
or
one, okay.
QWM, like the
Yes.
for check from the property.
Yes.
Property of this drive.
The drive, yes.
If let's say we get the inverter and we have there's a internet port, but not from SIMATIC, maybe from maybe others lah. So how do you do the communication?
Same concept. Same concept. Go offline. Go offline. I'm not sure in this one or not. Go up. Here. Go up. Go to device and network. We said let's say other drive.
Hmm.
Other drive means I have to install a software. Later I see, later I tell you what software, but I'm not sure inside or not. You check and see. Others also do. You see which laptop got. I think some laptop got. Okay, so this one make it bigger. So you click on the drives. You can see only Siemens drive is around. What is that? Right.
Yeah.
Okay. So means I need to install separate later, right? ABB, because ABB not there, right?
Hmm.
So I need to install. Once I install, you go to the other field, go to the Profinet, drives. Okay, which laptop got additional here?
Maybe.
Got it.
Right.
You got. Yours got.
Got.
Okay. Wait, I show you. So in this laptop I added before.
This one,
Okay.
right?
No.
Profinet.
Under Profinet. Okay. So you make it bigger. Okay. So it means if the drive is a different brand, you go to the drive. What is the model? And you type GSD file. GSD.
SD.
German, Singapore, Denmark. Right.
Okay.
GSD or GSDML.
GSD.
ML.
ML.
Yeah.
Wow.
Yes.
Okay.
These two files, two type. You need to download from their respective website. Let's say ABB.
Okay.
So what is the model? Say I downloaded this one something like model and Profinet GSD.
Hmm.
When you download, after download, go to the tools. No, go to option.
Option.
Okay, can you see? Manage GSD file.
Okay.
Okay, click that. So I downloaded. Okay, you open.
Open.
Go to downloads.
Download.
No, sure. Oh, this one downloads.
Oh yeah.
Okay, actually this laptop I think I already downloaded this one. Okay, I download the file, then I click the this. Okay, click.
Wait.
No, just go back.
Go back.
Select folder.
Select folder.
So it will show all this,
All the model they have.
all the model. No, only the particular model.
Okay.
Particular models.
Okay.
It means how they call it now. Actually, all a few models. Okay, but since this is Siemens it won't recognize ABB all the model. He said what he recognize, he will recognize ABB Profinet only.
Hmm.
He won't recognize what is the model.
Hmm.
It can be AACS 500, can be ACS 700.
Hmm.
So it won't recognize that. It will recognize Profinet. It is a ABB Profinet device. That's all.
Hmm.
So it won't recognize it. That's why I said, can you see? ABB, FP, and OBIS is a Profinet system.
Oh. That means they only know this is the file from the ABB.
ABB, yes.
And this is all the file about the Profinet.
All that, but it's all, can you see, it's a date actually. From the old date until the version 2.43.
Okay.
This one is based on your ABB.
Model.
Whether the ABB can support this version or not. The latest version lah.
Hmm.
Then it's already installed lah.
Okay. The latest are the way we install the latest one.
Install latest or all also can. It's up to you lah.
Then we select all, then
Install.
install.
But it's already installed.
Okay.
After install, then only I get this.
Okay.
Okay. Then I just take and put it here.
Put it here.
Okay. Then from the PLC I connect here.
Just connect on it. Okay.
Double click this.
Okay.
Okay. Go to module,
Okay.
vendors. So which one you want to use?
This one?
This one is no. This one is similar, like the same concept like the just now we choose standard telegram 1, standard telegram 2, right? Remember just now we choose. Remember? No. We go to the dynamic drive. Double click dynamic drive. Right click property. telegram drive? Okay. You choose standard telegram one, right? Correct. Because you just want to use true data, right?
Oh.
Same concept. Okay. Go back. Go to the double click. Okay. So PPO3. Look at description. Okay. This one of course lah from the drive. You need to go to the drive and you need to know lah. PPO3 means what? PPO4 means is what?
Study the menu.
So PPO3 normal lah. Commonly PPO3 is a same thing like standard telegram one. 3 input, sorry 2 input, 2 output. Take you double click. Okay, you open this. Okay, go to Profinet. Advanced option.
You touch it.
Wait, where to add this one? You drag and click it. No. Okay, maybe double click here. Right? Wait, somewhere you have to click the head module. Data vendor, yeah. Yeah. Oh, okay, sorry.
You already go what?
So close. You open the device data. Yes. Okay. So you already added here. Like the address lah. Can you see the PPO3 already added? What is the address?
6871.
6871. Means input, right? Means IW68, IW70. Correct. What's the output? QW64, QW66, right? Okay. So that's the address. So what is the values? Right, this number, everything, right? Same.
Same.
Yes.
Use back the
Same.
47
0 to
F.
4000, 47F, everything same. Because why? Because you already download the Profinet one.
Oh.
Like I said just now from the earlier example I give you one. We are talking in Profinet language, right? So means must use the same value lah.
They mean for easier way lah.
Yeah.
We know the Profinet, right? We all put the Profinet settle already.
Of course.
We don't need like complicated or here Profinet, here analog, here what?
Correct.
We are not buying the beer, you know. It's client buying the beer, right?
Client the buy okay lah. Because if you ask me, let's say I have 10 motor, even though the drive is, because you know what's the advantage of Profinet? One is the value is accurate. If I need additional function, like top control, all I can get lah, right? But if I want to do a simple program, simple just like when I start, okay, run on 20 Hz. If the speed, if I want to change the speed, I can change the speed at the HMI everything. Even I can buy that drive also, right? I can buy that drive. I can use hardwire or I can use Modbus. Modbus don't need to add any hardware, just a programming. Additional, not like this lah, additional programming. Okay? So just maybe I can clear your mind. Profinet means I need to do, you close this, go here. I need to do this configuration. Correct? That is called Profinet. If I'm using Modbus, I cannot do this. What I do what communication also, same communication, but the program there's a block like a timer counter, right? There's a block for Modbus. I take that, then I need to tell, okay, this is the address. So means additional programming work. Once I've done with that one, then only I will get this task. It's the same thing, control set point, same thing, but the value of course are different. Value is based on the drive, which is cheaper.
This one?
Correct, cheaper. So if I have just a drive, just a pump on off, control, I can go for that also.
Now this one is tutorial. Some
Means okay, what you know, your programming what will be more. The cost of the device will be less. Okay, if you go for Profinet, means I don't care whether it's a SIMATIC or ABB or Mitsubishi drive. So whatever drive can support Profinet. Of course lah, slightly costly than that. Okay, but the programming will be straightforward, easy to do programming, easy to troubleshoot. You know why? You have a communication.
so we know where is the fault.
Yes, if one of this one is not working, when you go online, it will show a cross mark.
So we just find that. What's the
Yes,
issue?
so from here, what is the issue? Just now I add, right? Okay. Now
This is
clear?
Clear. That means same like for example, this one we need like analog input output something because we separate. We need to do the additional program
Yes,
to make the PLC understand.
hardwire lah.
Hardware lah, and also need additional AI, AO.
Need to additional card
Yeah,
modules.
has
Yes,
to add the money also lah.
yes,
Then
of
what?
course, of course.
This one is simple.
Yeah.
You just terminate the Ethernet port,
Yes,
the Profinet,
yes.
do the program, link, check, finish.
Do the communication. Your system, what is one?
Which one?
I mean your software. I mean your program.
Yes,
Got something like this?
Yes.
Okay. You see this one.
Yeah. Because I see this kind of the panel before. Is it only link the Profinet? So I don't
Yes, yes,
know
yes.
what they are doing.
This is the way. So now you understand. Now you go to the main PLC, you upload the program, you go to the device and network, you can get this configuration. This is called configuration.
Okay.
But if it is Modbus connection, you won't get this. So all the drive, you must go to the program and see in the Modbus system.
Yeah, then you have to check where is the where is the interlock.
Where's the program first,
Yeah.
where's the Modbus settings, and then
where is your main conversion? Have to check one by one.
yes.
And also check the conversion for which I/O, which analog input, which analog output.
Yes, yes, yes. Okay, can? Any question?
Last, sorry.
Hmm.
Just now because before we already after we create a file for the drive, we need to do the setting, right?
Yes.
All the setting is like very common follow back and just now you teach, or we have to check from the manual.
It depends on how you want to control. If it is a basic control, like just now lah, on off, like a linear, constant load, like you want to use this for a pump, or you want to use this like a mixer, or fan, or what, something like this, just like that enough. Unless you have a top control, suddenly you want to pull something. Let's say lah, you want to pull something. So, let's say you put 25 hertz for example. We talk about hertz. Let's say you put 25 hertz. When less weight also, you need to follow the 25 hertz. More weight means high load. So if the drive stand 25, cannot high load. So what happened? According to that, according to load, it automatically create a torque. So you can carry. So for that, it's called expert configuration.
That means the export we also need to let the drive know.
Yes, yes,
Now
yes.
you start is a
Now I do the standard. So if it's a high load, what happened? The motor becomes slow.
Yeah.
Motor won't be like
Fast.
same speed. No. Let's say that it's running. Suddenly I apply load. What happened? Becomes slow. But if I do that, this top control everything, even though I apply load, it will be in the same. It's supposed to be in the same speed.
This is not the program. Just want to check the guy need a confuse of this. Why they said like low speed, not low hertz is a high stop top of what?
Okay, normally when they work with what high top, right? Big motor sometimes. So what happens is they will need to start the drive, right? So I'm also not okay. I also forget. So it's like if you want to run the motor because it has a high load and everything.
Yeah.
So at low speed, they take more current, take more power.
Okay.
Once it start to rotate, then only it need less power, something like that. But this one you need to
I need to check.
check.
Maybe when it start up,
Start.
the power will be
Yes, that's why when you see this one all we are using what? Drive to control. Okay, so we call VFD lah, variable frequency drive. Let's say it's a direct motor only.
start it out.
So they use star delta. So initially they use the star, then only convert to delta, right?
After a few seconds, convert to
Why?
They need low lah.
Yes. So star means it can draw more current at lower speed. So something like this lah, but you need to study lah. Okay, lah. So don't 100% believe what I say. I also convinced me. So it's something like that. So why they do that? Because to run, so to make it rotate, so it draw more current at lower speed. Once you go to some speed, that's why they put 5 seconds, then it become delta. Correct? Am I correct? I'm sorry.
This one I feel a bit confused.
Because I'm not very familiar, I mean not very really hands-on on that. No. Drive I know. Not really hands-on with the drive. Even
The drive also can set, right? Inside the drive also can set.
Yes. We choose delta because why I do it's not high. I'm not using this for high torque. Right? It's a constant load. So I connect delta. So that's why when you do configuration you choose delta, right?
You mean data is a smooth, not like the high top.
Star is
the high top.
because delta means it's like this, right? You like this. So if you measure the current between point to point, I think you will get like 415 lah. So you will get the 415.
Yeah.
Delta means it will be like this, like a star. I mean star means like a
Like the
like a
Y.
star lah.
It's like the Y.
Like a Y. Yes, the connection in the inside the winding lines actually.
Sometimes we don't know, sometimes we do the machine also. They already fix what you do. After the motor, which is more, I mean your motor set is 5 kilowatt and above, they all request starter time.
Yes.
If less than that, no need.
That's direct data also can. Then direct data can write less.
Can.
Yes.
But some of them they request this kind of thing.
Yes. Because you know why? If I use delta, so when I want to start, I want to rotate, I will draw more current. So what happen? It will if you put the MCB everything right, all will shut down because no current. Right?
Oh.
That's why they use this. So when you start, so it will use of course more current, but it will take current slowly, less current first. Make it rotate first. Once there's a rotation ready for delta is easier. So once I convert to delta, then delta.
So that was the Olympic, the cycling.
Yes.
Something difficult.
Something difficult. Okay.
You see, okay, one last. You drive, why they like always like say if you stop, right, they always call us to delay second.
To stop.
To stop, not direct to stop.
You mean the deceleration lah?
To protect the drive or what? To protect the drive or protect the inverter or what? When you press the stop, right, they won't direct stop the motor, they will delay few seconds.
Yeah, that is called the deceleration lah. Deceleration. So why? Because direct one, you see like anything in the motion, when you suddenly stop, it will create what? Vibration. So if let's say this is the water, it's running on the conveyor. Slow speed suddenly stop, okay. Let's say high speed suddenly stop, what happen? The motion, right, the initial motion will fall down. That's why to avoid the vibration, the inertia, then. Okay, good. Any question? you get the concept, right? How it works, everything. So what are the terms they have, they use. These are the terms, you know.
For me, easier way is this one the computer area.
Of course.
But we need to check the cost also.
Yes, yes.
I believe it's very expensive if you
Yeah,
use the
of
computer.
course. You see, both drive, it's the same thing. Can do the same things.
One is more program, one is less program. That's it.
Yeah.
And the cost, one is expensive, one is not so expensive. Cheap.
Another one also, that one is a 0.75 kilowatt drive.
This one is
0.75. This one is just 0.55 only.
okay, compared to the cost, I believe this one is like less than 1,000 only.
That one I think if I'm
Few hundred.
not mistaken, I think it's around 6 to 700.
Yeah. How much the cost will be for this?
The bottom one, the power module for 0.55, I think is around 700 plus. Then the top one, the control unit is around 800.
Become down.
1500.
Double the cost.
Not include the BOP.
This one.
Yes.
But this one is not necessary, right?
Not necessary.
Ah.
Let's say you have set 10 drive, only one enough.
Yeah.
Because normally, what is the advantage there? You can see on off lah, just test.
Then
Yeah.
can share.
Yes. And once you do the for number one, you do the setting already. Using that backup from the control unit to the BOP, take up, put back to the other drive, download also again.
The installation, typical installation time will be different. This one will be easier.
Yeah.
This one
This one
You know
really
why?
easy, you know.
Because once you do the connection, now I do the connection. This one is this one. Now I want to check the drive is working or not.
Check here only.
Very simple.
Okay, check here.
Here got for this lah. Here got auto N. Can you see got N symbol? I increase the this is the RPM. Increase the RPM. 780. Okay.
This one is rotate, mean.
It's rotating lah.
Let me go the current.
Yeah. So 310. Because according to setting lah, right? Okay, finish. Now, if this one want to control, then I end auto press again. No end means okay. Means my no end up. So now my PLC can control.
This is manual control.
Yes, normal lah. That one also.
This one long time, the tikus coming.
Exactly. Yeah.
Okay, good.
This one I know why they are not preferred. No. If during the comparison of price, they are not preferred to profit that because it's very expensive.
Yeah.
Must be use this type of thing.
I have the program. I don't have the drive configuration. How can I download drive configuration?
Don't have it.
He was doing the drive configuration.
You didn't do. Is that? You didn't do that.
No, I did.
You did right. Okay.
Just few more things I did know.
Okay. So what you do? You can upload from the spreadsheet. And it must go offline first. Yes.
Oh, that means the file. Just now the 2 days ago we discussed the GDF file or something.
Yeah.
That is a file.
This is the one.
Okay.
I click. Upload from device software. Yes. Loading configuration from you already copied your company program to this laptop? the SCADA, we do a simple one. For SCADA lah, simple.
So, for advanced, another course.
Yes, of course.
Okay.
No, this is advanced.
Yeah.
Okay, advanced means you get so many in advanced function, right? So many. Okay, one is the analog drive. Another one is the SCADA advanced. We will do SCADA basics. Okay, SCADA advanced means waiting alarm, trending, data logging, all that. Okay. That is one advanced. This one advanced. Modbus communication one advanced. PID communication settings one advanced. So normally I will do drive because that is the most common request that I get.
So SCADA also have, let's say.
SCADA we will do basic.
But let's say what you're learning more, also.
More on the SCADA.
Yes.
This is advanced.
Okay.
It's just advanced only.
How many days, let's say?
It depends what you want to learn. When I say only SCADA, because you will learn alarm, trending, data logging, do some projects, face plates, do multiple PLC, 2 to 3 days. SCADA advanced always like 2 or 3 days because it's a very specific. So means you want to come learn Modbus, only Modbus only you learn. You won't, because you must know PLC. So you will learn only that. If we have time, maybe we add HMI. HMI also I won't teach. We already learned.
But that is a basic.
I teach additional something lah.
Yes. But let's say go to another class.
Yes.
Okay.
Because if I want to teach you whatever I know, like, if I want to teach you whatever I know, it will take time. If Siemens only lah, you ask me, all the everything. So the drive, the Modbus, the SCADA, all advanced I will tell you. Because basic we will learn in this training, we will learn advanced PLC. Basic HMI, basic SCADA. Got it?
Right.
So we will learn more on HMI. Not more, we will learn how to create alarms, how to get alarm, how to get trending, all that in the HMI. The SCADA also. Then the Modbus, PID, all that I think we will take 10 days plus. We want to learn the whole thing, whatever, then IoT.
But let's say the traditional, the mechanism control panel, start store, magnetic contractor, the design, you teach also.
Design, how to design a
Yes,
control
how
panel.
to connect, how to pin.
Okay.
Okay.
Okay also. Because I have done control panel wiring lah. But more to PLC wiring and not drive. Drive is more to 3-phase or that. So I just normally teach the single phase, PLC with the power supply, relay, contactors, teach how to learn.
There's a 2 PLC. They link together, right? Let's say there are different 2 types of PLC.
Okay.
One Allen one Siemens. If let's say the Allen is the main, PLC is a sub.
PLC is a
Sub.
Siemens is a sub.
Siemens is a sub. Means that this Allen we need to download the PLC Siemens.
If it is PLC to PLC, we cannot use that method.
Oh, not like this one method, no.
To PLC, maybe we can do Modbus communication. They share data through the Modbus protocol. Or another software, another system called OPC. OPC. It's a software. It's a software.
Okay.
So must have a PLC laptop for that. So your Siemens and your Allen send data to the OPC will send here. So from the Siemens send data to the OPC will send to the
That means we have to research the PC then.
Yes, of course.
If without the PC,
Without PC means Modbus.
oh my.
So So that what you will learn in IoT. If you want to learn IoT, you will learn OPC.
With this, I have involved.
Yeah.
Let's say learning PLC, normally what kind of
No, I will. Can you see there's an owl there?
Yeah.
Right. So I will connect a temperature sensor there. Then we will control the temperature. So you are using the PID block and the PID function. So the temperature, we can control the temperature. That's what I will teach. Easy.
Can this file open?
any software to do PLC temporary?
Any software
To do the PLC.
No, there should be some software, but I'm not really. I never explored. I know how to do programming in PLC, but PID software.
The IoT is linked to the PC, like the SCADA. SCADA also linked to PC, right?
SCADA of course PC, but IoT more to link to the server and cloud.
I put it inside.
Yeah, okay.
要回去装那里，自己 test 看。
直接从早上做到晚上。
啊，对。因为刚才我自己去刷那个海波，可是我是想过去，我教人家做那个可能，可是我跟他们。因为有时候啊。
Yeah, I think it requires like after training, you go back, you have to continue.
But you can also have a real panel to check
Yes.
one by one.
To assembly one. Assembly one.
It will be good if like now three of us are here, we create a WhatsApp group.
Yeah.
And then like for my sake is every day I come up with different error.
Yes.
So like I also have all the errors. So if we create a like WhatsApp group, any error I come across, how I solve, I get screenshot, send it to the group.
Yeah,
Oh,
easier.
this is the problem, this is how I fix like it. So it's like for learning of all of us.
Better we live with people also.
Yes.
We need to check as well. We got the issue. Then he has this issue. I cannot get it. We cannot learn everything. Sometimes this very smooth,
Yes.
but sometimes it will fail. Different.
Learn from default. Learn from default.
Yeah.
Problem coming, then we will know. This is that we're doing a program is learning a lot of things.
Yes. That's very good.
After being prepared,
Yes.
no feel.
I-
Easier.
We will talk to you. And then we create a WhatsApp group for all of us.
Yeah, have to. Because sometimes if like among us, right, if there's any error, we also computer how to do it.
Yeah.
At least something. Oh, you can make this. Oh, oh, okay.
Hello, actually, OK，我看到你 send 来的31799是哪里来的？ 有听懂吗？哦，还有一层，对对，还有一层，对对，对对对，还有一层，是的，对的，对的，
Yes, yes. Okay, now. So, yes, is it use this step or you open it? So, Moses is having his lunch. So, you can see what is the drive. Let me put it there. Then you connect the HDMI.
and the HDMI.
Yes. Okay, what is your question?
Let's say I get this type of drawing.
Hmm.
How to start to read? There's a lot of numbering, a lot of
Okay. So there's a lot of symbols, right?
yes.
Okay. First thing, this one is a voltage relay, three-phase protection.
Yeah.
So it's a protection relay.
Mm.
The three-phase coming in lah.
So the power supply direct coming.
Yeah, coming in ROIB lah.
Okay.
Then they have a normally open contact here.
Mm.
It's going through a overload lower fan.
Mm.
Okay, then go down. You scroll down, we make it smaller, go to a lamp.
Okay.
So if the relay is overload,
Okay.
this one normally open, right?
Mm.
Become normally closed. Right, so the signal will go here, go down, go to the red lamp
Okay.
and energize the red lamp. So we know the lower fan is triggered.
Mm.
So this is the fan symbol. This is a contact. It's a contact, but I'm not sure which contact. Okay. PB5, PB6. Go down. So this is the compressor, is it?
Yes, it's a compressor.
Okay, compressor, there's a sensor. This sensor is for what?
For this one is
Home operator cabinet. Okay. This is a remote on-off switch. This is an open switch. This is a main switch.
mm.
The main switch supply the current for the black seal.
The controller.
This is a controller.
This is a controller.
They have a cooler, defrost, and compressor. Make it smaller. So you need to know the symbols are normally open, normally closed. This is like a switch, I think so.
Okay, let's say how much?
Okay,
Mm.
this again I will tell you one thing. This one, the C2 means is your component. So this is the C2 SVR, right? This is a tag will be on your component. Component means push button, relay, contactor. This is the symbol. Yeah.
Okay. Let's say this line they link everything together.
This is the common.
Oh, here's the common.
Yeah.
This is the common line.
Go up. This line is from where? Neutral, can you see?
Oh.
Neutral, right?
Mm.
Neutral, go down, go to the lamp.
Mm.
The positive is from the, okay, for the run is from the MCB. The live from the MCB will come here. So
Mm.
it will show the run lamp. This one is for the lower overload.
Mm.
The lower overload, okay, the live, can you see? R, right? R is a live, correct?
Okay.
The live coming in, go to the normally open, go to the lower and come down.
Mm.
So same thing. So all the is like similar to your output.
So let's say one day from here, example from here, I notice the same numbering from other place. So meaning that they're sharing the contact or
Which one same number?
here don't have. Let's say the wiring diagram, one day. Okay, here example one line. I see the same contact number from the others. So meaning that they're sharing the contact.
Same can be same number, but depend on because this number I'm not sure how they label your device. So this number, is it a cable number? 17, is it a cable number?
number,
So cable number means 17 means another 17 means also it's the same signal. Go up. Neutral, right? What is the neutral number? Don't have number.
Also asking some stupid question.
Yes,
Okay.
there's no stupid.
This one is a power incoming supply.
Yes.
We talk about either it's single phase or three phase example. So let's say in a wiring diagram, if you measure this point, will be sent, how to say, will be sent with the incoming power supply or
Of course,
in wiring diagram.
because you see, they take this is a 3-phase going to the relay lah, right?
Yes.
And they take one of the phase, go through this one, and they connect to all this. This one all loop lah, right? Loop to here to here. So if I want to measure this one at this point, right? This point, and you measure with the neutral, you will get 230.
So let's say here, instead of taking it here, then with neutral we're getting the same number also.
Yes. Okay.
Okay.
Compressor.
Understand. Okay. So, as I received the drawing, I don't know where to start to read.
Which one?
Let's say I get the drawing, I don't know where to start to read the drawing. Yes.
But this one is like more to because it's more to hardwire.
Yes, true. Okay.
Hardwire process.
The additional
Traditionally, there is no PLC.
Okay.
It means so they take good. So this is the interlock lah, right? Actually, this is the interlock. Okay, so they come here. The overload interlock. Okay, the lamp is on. Actually, for this right, they can put a PLC here. It means from the, let's say in between here lah, right? From the overload go to the PLC, then from the PLC go to the lamp. It's a normal. But what they do, okay, they put the overload straight away to the lamp. That's why they loop all your the life lah. All your life they loop. So this one I want to make it into PLC controller, very easy.
So this one is still controller, using the serial also
RS485.
yes. So that we can link with another one.
Yes.
Thank you.
Okay.
Okay.
Now we go back to our program. Now we want to do a simple SCADA enough. Simple SCADA. Maybe just control this motor enough. Okay? This motor enough. We just want to know how to do the start stop functions. So you go offline. What you do, you add new block. You want to learn the DB.
Okay.
Add new block. Data block. Okay, you put a SCADA, the name. Okay, global DB. Okay. Global DB means, can you see nothing inside the DB? Right. Global DB means it's similar to your memory. Same like the memory. Okay, what I want to do, I want to do for this one. So, you put start forward, start backward, just put forward lah. Forward, backward, stop, reset, set point, feedback. Okay, set point and the feedback. Set point and feedback change to integer because set point and feedback is integer, right?
Timer is a time.
Timer is a time. Okay, finish. What you do? You right click the SCADA properties. under the attribute, click the optimize block access. Uncheck. Optimize, okay, means anyone can use this block. Optimize means only Siemens only can use this block. Okay, even though I'm using the Siemens SCADA lah, so that's okay. Okay. Then go to dynamic control. Okay. Now in front of this, you add a move function. Move.
Now the data block why you protected?
What's it? Attribute.
Yep.
Uncheck the optimize block access.
Oh, then
Uncheck. Unclick the one. Okay, then click OK. So what I want to do in the SCADA, I want to key in the set value speed. So just now I click the SCADA set point, right? You choose it, double click, click here, go down, go to SCADA, click the SCADA, click it. No, one click down. Okay, you click. You key in S. Okay, just click once. Set point. Yes, okay. Then put here this one, your dynamic set point here, your M11. Okay, here. Can do simulations. Yep. Start. Time on. Press on. Yeah. Okay, it means okay. Can you see that this question mark, right? Okay, what you do, you right click the SCADA, compile software origins. Okay, this one bring it down. Don't put this one. Just bring it down all the way down. Okay. Can you see? I have the address. Right. Data block 1 dbw, because why? It's an integer. Okay. So in the HMI I key in, the value will go here. Then this is the address I'm using here, right? So it can do the conversion.
Okay, let's say the move is kind of scale.
Can also. That's what I want to do for this. You add here because why? Because I key in this. I follow the sequence lah, right? I key in here, the data will move here, and this data I use here. Okay. Now for the feedback, I put the move here. Here. Put.
I open the wrong.
SCADA, right click, properties. Put the move function. Then okay. Put the actual speed here.
It's supposed to be day 5. I open day 4.
MW. Okay. So move to where? The SCADA, right? Okay. Click the SCADA. Okay. Choose. Again. Okay. Click that. Feedback. Yes. Okay. Enter. So DBW 4.
They already have.
The number we don't need to worry. They already have all the numbers. All the things. Okay.
After we compile,
After we compile lah,
they don't have any question or question like that.
Solution. Nothing. Don't want. What's that? Nothing. Don't worry. So after I do the scaling, the value will go to the actual speed here, right? Okay, you see, in the HMI, I can use this one also, right? To show the value. But I'm moving all the data to the DB. Why? I dedicate 1 DB for SCADA. Whatever one to use in the SCADA, I will put it here. Easy for me. I need to think about which memory one to use. Which memory one to use. So you remember when we learned HMI, We do the memory, right? So we struggle that way which memory we want to use. So can use the global DB.
They mean all we can take.
All whatever you want to put in SCADA, all put it here. Then later when you put the SCADA, take from this.
HMI also can take from that.
Yes.
All is the same.
All is.
So they mean all the data we need to create a file.
Yes. The DB. Okay, good. Now go down. Go down. Okay. This is the push button. Right.
Yeah.
I want to put a HMI button. Right. Into branch, right? Okay. Put a branch. Now we open. Okay. So this one is what? SCADA forward. Yes. So do for all SCADA backward, SCADA stop, SCADA reset. Forward, backward.
Like the HMI button also.
Yes. Using memory. Actually, we are instead of using memory, we are using DB. That's the difference. I can, if I don't want to use DB also can. I can use memory.
Oh, like the button, everything. I mean, these are the button also.
Yes.
HMI, SCADA,
Same.
can use
Yes.
memory.
Yes. Memory or DB.
DB.
Yes. This one why normally it was changed to normally open. Then your program can run properly. Stop. Reset. Okay. Then set point fitness. Both are okay, save. Okay, that's all. Okay, okay, wait up. Then we will start. Okay, now right click the properties. Uncheck documents. Okay. Okay. Now go to the SIMATIC. From here you could move. From SCADA, system SCADA. No, input out. Input out. Add now. Set one. This side is MW18. Okay, then here move, out here move. This one is the MW20. This one is the SCADA feedback. Out. Go down. All these you add the HMI start, stop now. Yes. Add a branch. Okay. Right click the SCADA. No, right click the block DB block. No, DB block. Okay, on the left hand side. Then the DB block. Right click. Combine. Software. Okay. Now we do the all this. Yeah. put a branch, open branch, open, close branch. Okay, so it's going to start off or do for other three also. When you going back? Meeting. Oh, then after the meeting, right? Penang. Penang to which?
Dulu kan makin tajam kan.
My father from Kulim.
Oh.
My father. But after he became a police, he come to Perak. So my brother, my father married every in Perak.
Oh. Perak apa?
Bido.
Oh gitu.
Bido.
No.
My father there police officer for 30 years plus, the same place. No, Bido. Then get a higher position, Tapa. Then get a promote, Bido. Bido Tapa. Nearby only. From
Nearby only,
Tapa.
yeah.
Around 15 kilometers only.
Yeah, nearby only. Itu apa? Itu.
So I born study everything there. Then after diploma, I come and join.
So how many years you been staying here?
Here, 9 years plus. After diploma, I just at the home, I think around 2 weeks only. My cousin sister called me. She said, okay, this company, because my cousin sister was working as accounts. She doing freelance accounts for this company. So she called me and this uncle needs someone to help. Then I was waiting for my degree. So then I said, okay. Then I thought, okay, at least something like you can earn something. They say they pay me like 500 ringgit. It's like an intern lah, right? Then I said, come, I come here. Then I get interested in PLC. Before I come, I don't know what is PLC. I never heard of PLC also. No lah, mechanical guys. Right, so never heard. I don't know what is that. So I come here, but I like to use computer. That's the one advantage for. I like to use computer. Then do something. Then when you see, you also get excited, right? Whenever you do program, you download, you press the button, the lamp on, you get excited, right? So excited. Then sometimes initial days sometimes the participant come they will tell me, oh, you are mechanical graduate and you learn here PLC and wiring, very good like that. Then when they like brainwash me. Then I said, okay, never mind, I stay here. I get a scholarship for degree. And I thought lah, big decision lah, right? Okay, never mind. Then I do part time. Okay, good. Now we add, go to add new device. Okay, PC system. So if you're using the Siemens controller application, Siemens open controller, all is Siemens one. I'm using normal one, right? PC general, PC station. Okay. Now I cannot change. Okay. Okay. Then you open the hardware catalog. Yes. Then go to communication module. Profinet. Okay, this one all the communication lah. What type of communication are you using? So we are using IE is a industrial Ethernet. So we are using Ethernet cable, right? Okay. Choose the Ethernet.
How you know it's IE is general?
We are using Ethernet. From the PLC to your laptop, you are using Ethernet, right? This is Ethernet. Others all is a like a communication cable. Other cables.
So they mean internet, we choose that.
Yes. Drag and put here. No, this one. Drag this one. Yes, drag and put in the blue color. Yes. Then the runtime they call SIMATIC HMI runtime. Siemens they don't call Siemens SCADA. They call Siemens runtime. Okay. Can you see? RT, right? Okay, click here. Okay, choose the runtime advanced. Don't choose the professional. Professional, the laptop will hang. Very heavy.
Oh, I mean.
That is the higher level SCADA. You just do the advanced. Okay, just drag and put it. Done? Moses, okay?
Hang on.
Yeah, it will load somewhere. Loading, huh? Okay, now you click here. Okay, this one can close. Go to left. Then from the PLC, drag and connect here. Yes. Okay, click here. Okay, it's connected. Huh? What is your PLC IP address? I mean, what is your laptop IP address?
1, 2, 3.
Yours?
Done.
Yours? Your laptop IP address. 40, right?
Yes.
Change your laptop IP address. Okay, good.
I will change my laptop IP address.
No, this one here. Can you change? Yeah, click. Click again. Okay, 40. Okay, save. Save. Okay, that's all. Okay, now go to the, can you see under PC station, HMI RT, right? Okay, you open here, you add go to screens. Okay, this one don't have full screen on, everything must print. Okay, double screen the screen, add new screen, double. Okay, you okay until here, okay, on? Don't explain.
Coming out question.
No, it's same. They call HMI also. Don't confuse. So not this screen. You close this. Now this is one time. Screens.
This was the question.
Just now you click on the HMI. Okay. Go to runtime setting. I want to do one setting here. Okay, the full screen you off. Because later when you want to test, right, become full screen. Okay, I don't want that. Okay. Go back to the screen again. Open. Okay, so you see I've got more features compared to the HMI. Okay? Same thing. You take one button, put here. Okay. Right click the button property. Click here first. Okay, right click. Properties. Open the property. Okay. General. Start. So button we what we do? Event, right? Same thing. Everything same.
Event.
Go to event. Press. Okay. Just now, right, when we choose about advanced, runtime advanced, WinCC advanced, the other one is a professional, right? Professional, like a bit advanced. More professional, like means here, right? We have so many options. That is, here just press and release only, right? Inside that, we will have a left press, left release, right press, right release also.
Wow, so complicated.
Yes. So same button, you can, if you press left, can put another function. Press right, can put other functions. So more advanced functions lah. That's all. Then this picture all right. We got the pipe pictures.
Not the line.
So if you, this one we can do, but manually you do the pipes lah. If that one we have a shape and the L shape, angle, the T, everything. Okay. Only that is the. If you ask me, that only that is the main difference.
Maybe inside here we can choose a pro, but this laptop is not recommended.
Not like that. Can use, but it will delay our training lah. I think our training will finish at 7 o'clock. Because we want to open the.
Maybe still can use, but
They can
not
use.
recommended for
Not
this
recommended
laptop.
because if you see, we open the later once we finish runtime. To open only, you need to wait like 1 or 2 minutes. For any error, close 1 or 2 minutes. Then do the small, just a small change. Open again 1 or 2 minutes. So I just use this. Okay, press. Okay, add function. Okay, click here. Okay, edit bit. Set bit. Okay, then the tag. Okay, normally we choose from where? PLC tag. Correct.
Yeah.
PLC tag. But that day we put the name lah, HMI star, right? But now can I choose from the PLC tag?
No.
No. There's no nothing in the PLC tag. So from where did you choose? DB. The DB is under where? Under the program block, right? Okay. Click the program block. SCADA. You click the SCADA. Yes. Forward. Yes. That's all. The rest, everything is same.
So that means inside the button, we have to click, press and release. Press is the set by, release is the reset.
Yes. Okay, now, what the first one you select already, right? Wait. Go to the HMI runtime. Go to the HMI tab. Click on the HMI tab. Can you see SCADA forward is there? So always the HMI tag always will be empty only lah. You know why empty? Because this is a Siemens one. So I can. So when I open here, I can see the PLC. Let's say I'm doing this SCADA for elaborately. What I do, once I add this SCADA, right, I go to the HMI tag. I need to key in all the tag I want to use from the elaborately.
Wow, really?
But nobody can do import export.
Oh.
Of course lah, you see got hundreds of tags. How you want to write one by one? So they have like import export. Okay, so you can just start forward.
I missed something.
You miss where?
I missed you click in the SCADA DB. You click the SCADA DB.
The name you choose, you put start forward.
Okay, so now choose.
No. Go to your. Don't use this one. Go to your screen. Where's your screen? Okay, right click property. The tag, right? So you choose from where normally?
We from PLC tags.
PLC tag, how you choose? No, you don't go here. You will click here and from here you choose. Correct or not? No, the click. Like this, right? So, but now we are using SCADA, DB, right?
Yes.
Select, yes, yes,
So we
yes. Okay, release.
okay.
Save.
Sure.
Okay.
Mm.
Okay. Maybe the name you can put forward lah. Yes. Event. Press release.
Everything we for SCADA we choose from India, right?
Yes.
Don't from input after that.
No need. Unless the queue lah, the lamp, right? Can choose from the queue lah. Because that one make our life easier. Okay, then the value, the set point and the feedback. It's the same thing, choose from the same.
Set point also is a set B. Set point also is a set B. Sorry, yes.
No. Go to property, the process tag.
Go to
digit enough lah.
We still need to do the linear scaling.
No need, no need, no need. No need. Timer we do linear scaling because two different format. HMI is decimal, in the PLC is a time. Two different format, right? But the RPM in the PLC is what? Decimal. Here also decimal. Once done, save.
Option to do this.
No need, because it's yours is not real. Correct?
We are decimal.
No, is it your the RPM, is it real or integer?
This block.
Integer.
Check and see.
The RPM. We can create this for RPM also, right? Inside the SCADA.
Now we are doing for RPM.
This one is display.
Display the set point.
Set point. There's a graph. I saw it's a graph.
Graph. What graph? Integer, right?
Here. This one is.
No.
This one. Okay.
No. Go to Dynamics. Go to this one what? Integer, right? The actual speed. Memory. Integer. Go to left. All the way left. This one is integer, right?
Integer.
Okay. Good. Excuse me. Okay, good. Now, finish already. Okay, now let's say we test Mr. Lee and yours now. You want to test your SCADA, you download the PLC program first. You go up, click on the PLC, download. Software on. Yes. You downloaded what just now? No, don't download. You did download just now?
Yes.
Now go down, go to the, you close this. Okay, the PC station, right?
Yes.
You click here, go to online, start run time. Yes. Make it smaller. Okay. You put the value first, set point 1000. So do enter. Okay. Got error, right? No, in the drive got error, right?
Yes.
I think this one is a set point error. Maybe download, right? Reset. Maybe reset. Reset today.
Yeah.
Click start. Forward.
Oh, when download or something, the frame.
Yours is wrong. What wrong? Why 4096?
Maybe hashtag.
You minimize here. Let it run. Am I minimize? You click here. Right. It's a SCADA feedback, right? Okay. Go to Dynamic. this one can close lah. Monitor.
Oh.
4096
No, there's no hashtag.
IW256. Ah, can you see?
Betul.
So what happened? What happened?
Decimal mah. Dan
Decimal. So in decimal means it's supposed to be 1,163,824.
They mean now here is not the
It's actually it's
running, but
Running.
not 1000 RPM.
It's 1,000 RPM. Which one? You see 1,000 RPM. Correct.
Yeah.
Because your set value is correct. Because 0 to 4,000.
Okay.
But the feedback scaling, you put 4,000 only. It's supposed to be 16,000.
Oh.
So your feedback scaling is wrong already. Calculation.
That means 6,000. Oh,
16,000.
16,000. Oh.
Okay. You put here 16,000. 16,384. 384. Enter. Okay. Download.
No need stop.
Only because just download the program only right.
No.
Okay. Minimize. Bring down. Okay. Now what is the value? 1,000. Check your runtime. 1,000.
Why 163
4,000 in hexadecimal. In decimal is 16,384.
Oh,
Okay. You put here 1310. Enter. Yes, sir. Full speed. You move this one aside. You move this one to the right. No, to the right. Go up. Okay. Yes, sir. You key in 0 to 4,000. It becomes 16,000. Right. Okay. Because this one is in decimal lah, not in hexadecimal format. You can change to hexadecimal. Right click Dynamics. Display format. Tag. Hexadecimal. 4,000, right? You see? You key 1,300. Convert into 0 to 4,000 in hexadecimal. Give the value. When I get, go to left. When I get 16,824, right? 384. That is the same as 4,000 in hexadecimal. Okay, can stop.
Instead of the speed, can I, like for example, change to first? Also can, right?
Can.
They mean that set point 0 to 50.
This is, you minimize this. This is user defined.
What we need.
You define. RPM, hertz, percentage. This one is based on the hardware. Dynamics one. It's a hardware defined value.
So I need like further 0 to 50. If we calculate the first output, and the software define. Either you're use the X or you use the DEX. This is the point. Then you will come out the result.
Yes.
Same like the bottom also. We need to check the hertz also same.
Same. Here.
Can you add one more like direct another one column at the behind? There is a conversion and not possible. Because only cannot X and scale X in one line.
No, not necessary. I like your thinking.
You know what I mean?
I know. Can do, not the issue. Go offline. Click here. add one branch, open branch, copy this. No, you didn't copy, just click the block and copy, paste here, use the same Normax scale X, so must use the same Normax scale X lah. Put here 50.
Oh.
Okay, wait you follow me, 50. Okay, so this one delete first. Delete first. I want to create in the SCADA. Go up, open your SCADA. Program log. SCADA, open. Okay, you right click the feedback. Add row. Okay, you put feedback hertz. Okay, then right click the SCADA, compile, only changes. Okay, go back to the Dynamics. Here you put SCADA, feedback hertz. Yes. Save, download. Okay, monitor. Okay, what you do? Go to screen. I want to do some setting here. You copy this. Copy the whole thing. Put down there. Okay. 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 Double click. Choose SCADA feedback hertz. Choose from the SCADA. Okay. Enough. Save. Okay. You close this runtime. No. Close this one. Click this. Online. Start runtime. Okay, 1310. Enter. Forward. Click forward. Okay.
Whatever the output you get from the drive.
Okay, how I can do this?
How can you do this?
How can I give? I mean, the moment you ask, straight away I can give the idea. I can do. You know why?
Why?
Because I understand how the scale and Normax is working. That is the most important. So when you know how it's working, you the way you ask question, right? The same question you ask yourself, you know already how it works. The thing is, you need to take a timer, same like timer, or like you need to understand how the timer works. Once you understand how the timer works, so if you're doing a process, you know already where to put the timer, how to put the value, everything.
Okay.
But the one, of course, I need to practice. Do different. We have different questions. Sometimes you ask your question, repeat the question. Sometimes from the question you can get the what you want to do. I mean, actually that's how I learn.
Now X.
The idea is, this normalized is whatever value here, it will convert into like a percentage actually. If you see this right, it's actually in percentage. But it's not 0 to 100. It's a 0 to 1. 0.0 until 1. Okay. So if you put half value, it will become 0.5. Correct? Very simple. You know what happened? The calculation inside here. This one divide the difference between this one. And we get 1. The 1 multiply this, I get this result. 1 multiply this, I get this result. Very simple. You open here the runtime. What is the half of 13,700? 655.
55. Yes.
Okay, you key 655. Ini mas, you see, 8,000 divide 16,000, I get what? 0.5. 0.5 multiply 1310, I get what? 655. Right. Actually inside there, that is the logic lah. Inside the block. Whatever value you give will be divided with the maximum minus minimum. I get the result. I take the result and I multiply this. I get the value.
Like the set point also.
Same thing. That is, don't confuse with the set point. That's how the normax scalex work.
Yeah. Normax is like we need to
It convert whatever data convert to 1. Scale x is what the 1 multiply whatever your set point value. Okay, okay. Any question?
no because I confuse a bit not the norm X. Norm X and scale X only. But I sometimes like confuse on the like for example set point. Set point have to figure 0 to 100. Okay. Sometimes I confuse like wait, some set point why not 0 to 16384? Start from there first. Why?
Okay, set point is who set the value?
We set the value.
You set the value. You follow your number or the PLC number?
Our number.
Yes.
Output is a PLC number
Yes.
because they need to know.
You need to follow their format. Correct. Same thing also the feedback. Same thing the feedback also. The feedback is their number, Siemens number. So you want to convert into your number, right?
Okay.
So the feedback, the minimum maximum will follow your number. Okay. If this one is all okay, maybe we can see its company. Okay. SCADA you understand, huh? SCADA same like HMI. Only different is you choose the PLC, open up here. That's all.
SCADA. Oh, now we inside the PC.
Yes.
SCADA.
That's all. Okay. You can open this. Whatever you done, just save it. Okay, you save this one.
Close.
Okay, close. Okay, you cannot open from here. You open from TI portal 18. So whatever software you want, whatever the project all you can copy to your laptop. So you save, you close everything, then you can go.
PLC drive, HMI, IP address, the last number can be different.
Must be different.
Must be different. The SCADA must be same.
Must be different also. But okay, now, which one is the SCADA? Where is your SCADA device?
It's the same.
Your laptop, right?
No.
So you follow your laptop, huh? No. The PLC IP address, you follow what IP address? The PLC IP address, right? You want to key the IP address for the drive, you follow the drive address. Want to key for the HMI address. So SCADA is your laptop, so you follow laptop address. It's not the same.
Oh,
You put your laptop address.
They mean inside our laptop. Oh, from our laptop.
Yes.
The rest.
So rest the respective one.
So now we are using SCADA through this laptop. That's why we're using the same IP address.
Yes.
If we are using a monitor, a desktop monitor, then
Must use that IP address. Okay, now open. Okay, you see, this one is a version 14. This project, company project is a version 14. Okay, now we are using version 18. So how to open? From the folder you cannot open. You must open from the TI portal. So go to browse, go to desktop. Which one? KTF. Yeah, this one, right? Open. Okay, can you see? Because you click here, all supported file. Can you see? Support. You ask me, right? What is the extension? AP18. 18, 17, 16, 15.1, 15, 14, 13, 12, 10. Then ALS 18. ZAP. ZAP means if you compress the file, it becomes ZAP. Okay. So you can open starting from TI portal 10 until 18 now. Because TI portal started from 10. Okay, means any files you can.
But that is 14. Ours is 18. We can open that one.
Yeah, of course.
They can open up.
Of course. Okay. Because when you open TI portal, when you click open, you only show starting from 14. Because it's 14 means you're only able to open 14, 13, 12, 10, 11. Okay, you click here. Just click. Open. Maybe click again. I think you didn't click properly. Okay, open. So what happened? It will create another file. Oh, that's one problem, you know. You know why? These company programs, you don't know what are the GSD files they install. Like you install, right, in your laptop. So we don't know what are the GSD files they install.
Maybe got other GSD.
Other GSD. So sometimes we cannot
it's
open.
for lens drive.
Lens drive, is
Yes.
it?
9400.
Let's check lah and see. Cannot make some.
Oh, if we don't have that file, we also cannot open. Right?
Even you cannot open TI portal. Sometime lah, sometime cannot open. It shows installing. Never mind. You see and see. Some required GSD files are not installed. If not installed, I will show you how to get it.
How to
Get it. So they will give you what file is not installed. Just copy the exact thing. Go to Google, type in, you open up the page. No, open up the page, download from there. Then you open up your TI portal, install the GSD file first, then only can open. But let this one. Okay, then it's okay. So not the issue. So means, can you see all things luckily all installed. This GSD also is already possible. Okay, upgrade. So this is the GSD file. If you want to download, this is the GSD file. Lines 0788.gsd, this is the version. Okay, so it shows that your PI portal is the version 14. To use this project, upgrade. Okay, upgrade.
that means the tau will become 18.
Yes. So 14 will be there. Won't disturb. You create another file.
Then you don't need to transfer that in the next time you open. Right?
Yeah. Next time can directly open it in. Really?
Oh, last day. Yeah.
I know these 5 days are very compact. Okay, but I hope whatever I deliver you can get. What is that? Just now we didn't take the picture, right? The lines. You click the log file.
Yes, I will television.
Huh?
Go television.
The lens,
Yeah.
the picture, okay.
Oh, okay.
Then when you click the log file, Microsoft, just once, you know what is the format of the log file. XML, okay, then close. Close. Log file, click here. Conversion log. I want to open in Excel. No, it's in text file. Close. How am I going? Because just now it shows upgrade is available, but what's what error? Okay, still okay. Okay, minimize this. We try to install the lines GST. Go to Google. You search Google. Go back to okay. Google. Enter. Go down. Okay, here. Okay, what is the lens, right?
LEN
L-E-N
Z
Z-E
Z07.
Z only,
Sorry,
okay, E don't have.
you don't have
Okay,
07
07
A
A
at
8
yeah dot GST.
dot just 8 here.
Yeah, GST. Dot GST.
A8 A8
A
07 A8. Okay, enter. Yes.
This one?
Yep. This no, this is the 9-4. Go to Google again. Okay. Go back. You go down, look for lens, under lens, okay. Go there. Is it this for this one? 9-4. Is it the Profibus or Profinet? Profibus, okay. You key lens 9400 Profibus. Lens Profibus GSD. Okay. Choose the lens. Okay. Under I think J bracket. Lens file downloads. Okay. Click here. Go up. Up. engineering software tool certification documentation. Okay, click engineering data. Okay, go down. Go down. CAD. Go down. Display. Go down. Device description. Okay. Go down. Can you see? All these are communications. So many communications. Type like. You are using Profibus, right? Okay. Click that. Go down. GSC version 30. Siemens PLC software. Go down. Anything additional? No, right? Only this one. Go up. Okay, click this. Down. Already done. Okay. Show in folder. Right click, extract. Extract. Okay, close. Close. Minimize this. Go to TIA. Go to project view. Go to option. Manage GSP file. Click here. Go up for the downloads. Choose this. Select folder. Click it. Open this. This is which one? Inverter drive, is it?
Yes.
Okay, click the inverter drive. Open. Which model? Wait for the no. I will try it first. Open. So many things. Go back. Choose. Go back. And just choose this one lah. Select as. So.
Yes, the drive is connected to servo.
Oh, okay. Oh, okay. Go to servo inverter. This one. Yes. Click here because you said 9400, right? Okay. Click here. Open. Select folder. Still, I need to open some folder for you. Go there. Open some. Why don't you? Go back. Go back. Go there. I cannot go back. Here. Go back now. Click for the servo and select. Okay. Why cannot choose? You open the folder and see. No, folder. Yeah. Click here. Go to downloads. Open the folder. No, this folder. Okay, open. Open servo. Open this. Open this. It's there. Because it is one right? A.
Yes.
Correct. But why can I install? GSG. Okay, open. You click here. Open some. Open. Okay, select folder. lens, it's already installed. Means there's some other issue. That's why I cannot open. Because just now when we tried to open, it already installed the GSD file. Then what is the issue? You have any other files?
Same program only.
No, different programs.
This one for another machine, but it does not have
Drives.
the drives for the GSD file and
Oh. We try to open again and see. It's already installed, right? No, already installed. It's already cancel. We try to go project, open, browse, go to desktop. This one. This one is the conversion. Okay, try this. Which one? Click on the first one. Yeah, open. Go back. Click on the second one. Go back. Then open your 14. Your 14. Yeah, open. Try one more. Yeah. You try to upgrade. Click log file. You copy to this pen drive. I will close it. Copy the version 40 here. Oh, okay. No, wait. The problem sometimes maybe that is the problem. When we want to give to someone or copy the files, right? We need to copy in zip file. We need to give to in zip file. So sometimes the raw file, sometimes we copy in between the PLCs. I mean laptop, some of the file might be deleted.
Oh, so have to go
Virus.
Yeah.
So better use a zip. Tomorrow also have to have this. Everything. 2 packs. They are coming from Sabah.
How many percent?
Try to open this. So in the meantime, any questions? Yeah.
Can I borrow any time to set?
Question. I have a lot of questions.
Yes.
But let me think. Wise question.
this.
Just now the SCADA, right? We have click not to full screen. If let's say full screen, they will occupy your full screen.
Yeah, of course. So if you want to close, you must click the window button
Yeah.
and close that. That's why only I ask you to put Because you cannot make it smaller.
Yeah.
Want to see both the PLC.
Like HMI, how to create a new file?
What new file?
They mean the button to create a new. Like for example, this
New screen.
new screen.
New screen. That's all.
HMI SCADA also same.
Same thing. Whatever you do SCADA is actually same thing in the issue.
Or add new screen.
Yes.
Then replace this button, like for example, is for page what? I mean page 1. This button is for page 2. Then we have to create the memory.
No. Choose the button. Click the press. We choose set bit, right?
Yeah.
Instead of set bit, choose activate screen.
Activate screen. New screen. One button.
Right click. Okay. Right click. Properties. Go to event. Press. Okay, this one choose. All the way go down. Screens. What are
Screen.
you? Screens.
Okay.
Activate screen.
Okay.
Then choose the screen name here.
Like for the first screen is a screening.
No, here. Is there only one?
Yeah.
Okay, that's all.
Okay.
Then you do the same thing in the screen one also.
Like for the screen 1.
Mine also same lah. Cannot open. Process.
Screen
Something is the issue.
2. So it's only the press, right, for the screen. Release no need.
This is only.
Only the press. So this one will be screen 2. That's it. Yes. Object number, nothing. Yeah. That's why I saw this thing. You see, after I going to property,
Go to not animation. Yeah.
yeah.
Process.
So this reset lah. This
Yeah.
tag for example, this is
Yes.
this. Then what is this way to get the file? Tag for the maximum.
Unless if the PLC have the tag for maximum minimum, you choose maximum minimum lah.
Then we don't have.
Don't have, just don't need.
No need blind.
Just, yeah, because we follow this.
Okay.
If we have a text for maximum minimum, this one will follow this number.
Oh.
Means
Like,
you can key in maximum minimum.
like for example, just now ours is the feedback first.
Yes.
Here is a 50.
Yes.
Then finish.
Yes.
Then the color.
What is up to you? You know, this is screen.
This green, sorry. This color. Okay. Okay. What is this? Blower. Oh, good lah. Hey, this one sekarang tu. Let's go to blower.
Not only blower, go to property.
Oh.
All that.
Part also.
So your laptop have this one, right? Explore. Explore and see how can do like the first day we do tank, right? Tank picture, tank, valve, see all this kind of
Then
stuff.
put there one. This is a tank one.
Yes.
Tank also.
In my laptop too.
What's that?
This one.
Yeah, what? What really? The message, I'm not sure what is the message. Oh, Excel sheet. I think when we copy right between the laptops, that's why something is miss. That's why I cannot open.
That's my guess.
Yes.
It's not bad.
Yeah.
This one is 14 lah. Oh, don't have.
Okay.
Just a question.
Yes.
How about the PNG file?
PNG file. PNG file. Oh. So any PNG file in this laptop.
Just history lah. Easier.
Okay.
Loading.
Cannot print screen. Yeah, put your print
Oh.
screen.
Then
Can. But
off first.
no, right. You click here. You click the window here.
Okay.
Then print screen.
History.
Okay. Then you save in your file first.
I have to off first, I think.
Minimize. Okay. Minimize here. Can save or no, right? Must open the PowerPoint and save. Right now. You try to save? Control V? Yeah. You open the PowerPoint.
File.
Okay, save. Okay.
Save.
File, save as.
Desktop. PNG. Ah, don't have
PDF only can.
then
PowerPoint can.
PowerPoint.
Under PowerPoint. You close this
Then
one.
I'll open in the PowerPoint.
Yes.
PowerPoint.
Okay. Okay. Save as PNG.
PNG. Yes.
Okay. In the desktop.
Sorry.
Never. Put in other documents. Okay. The other documents you go and check. No, I want in document.
Document.
Put in documents.
So now already set in document.
Minimize it. See? Where is it saved?
Document.
Okay, never mind.
Save again.
You save under picture.
Under picture.
Picture. Okay, save. Just this side. Okay. No need to close. Go to TIA.
Okay.
Go to libraries.
Library.
I don't know. Go to toolbox. Go to graphics.
Graphic.
No. WinCC graphic folder. Okay, no. Close. Can't be close.
Close.
No. This one. Controls. Close. Yes. Okay. You close the WinCC graphics.
Okay.
My graphic folder.
Okay.
Graphics. Any test. No. Go to graphics. I think under graphics should have Make it bigger.
Oh, this one.
Mm-hmm.
Okay, I put here already. Okay. This is HMI. No.
Oh no, HMI same thing lah.
Right.
No, no station. Got. Okay, screens. Full screen. Yep.
Okay.
Finish.
You know, easier for me. I create my.
Of course lah, your own logo lah.
No, not my logo. My process. I just put my process inside. I just put the button like finish.
Yeah, that's how normally do. You know what? Last week I have a participant from a company called Johnson Control.
This year,
You know,
Singapore,
no, it's Malaysia.
Malaysia.
So they do safety security system for Navy ships.
Okay.
They use Siemens
Maybe.
PLC. They use Siemens PLC.
Okay.
Siemens PLC, Siemens HMI.
Okay.
So he showed me one picture like the Siemens HMI. You can see the entire ship picture. But it's in 2D drawing.
Yeah. Yeah.
I think they do in the 2D drawing. Save as PNG.
Yeah.
They export here.
Export here. Yeah.
So they import something. Then they put the lamp and everything. So anywhere got alarm on off.
It's very easy. We are easier to check your off. Yeah. Why don't?
Normally they do these pictures all in SCADA. HMI can do, not cannot do, can do,
But
but
it's still have to
not
be
common. Yes. HMI normally they do like more to like data, like what we do. Start, stop, value, like a data only. In the SCADA only they put like graphical things. Tank, valve A, valve B. Right. So valve A you can see the color change. Above the valve A, what is the flow in the valve A? What is the pressure? What is the motor speed? Everything.
Maybe you can order behind this picture, right?
Send to back.
Send it back.
Yes.
Can do. As I say, if you have time, explore. Just explore. For me, when I explore, because sometimes it's like something what I say. Sometimes it's like you will think like you are. For me lah, sometimes I think I know everything lah. Just don't need to explore lah. Sometimes like but whenever I have a project lah, then this is what new thing. Okay, go to Google and study. But sometimes don't have time because most of the thing you know already. So what you want to explore, right? So for me, you give me some challenges, I explore. So whenever I have a project, then I explore. Oh, this one forget already.
That's true.
Correct or not? So right. When you do something, sometimes not only PLC like anything. When you do a few things already, so you do like everything lah. I want to explore.
I have to, when we learn a new thing, the most.
When you learn new thing, yes, of course, because that's how I learn. I learn new thing, I explore how to do this, This one all I explore myself.
Oh.
The pictures and everything. I
Okay.
explore myself and see. Okay, go to YouTube and learn how to add picture. Explore. So all these are common. But anything additional, so many things can do us.
Yeah.
Anything additional. Actually, if you ask me, I know maybe 30% or 40% of Siemens. There's a lot to know. But of course it depends on the projects. Some projects need some project need counter. Some project don't need counter, right? It's the same thing. So some project need some additional things. So because so many things you can do language change. Language means you need to create all the language. Let's say in Chinese, you need to create first. There's one place to key in all the languages. There's one place to do that. So you do that, then you can put one button to change the language.
I actually saw a HMI exactly like what you are saying.
Yes, yes, yes. I've seen many times. I have done a project also, changed the language. So they asked me to create in English, Italian, something. So I have done
When
one.
I was working in VAT, there was a HMI for a backup machine. It's an Allen Bradley PLC. Allen Bradley, so the HMI, it has, when you log in, you have to select either English or Papua New Guinean
Language.
Ah, okay. So these are all different
What's that?
selection for the language.
Yeah, 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 of course. So it's a button.
This is a button.
In the button,
Create.
okay, so okay, I give you the concept. The change language button is not related to your PLC program, right?
Yeah.
So you cannot choose set bit, reset bit.
Yeah.
So you need to go and there's a function, right?
Yeah.
You see where is the language.
Okay.
Choose the language. Okay, change language. Choose that.
They
Like just now we activate screen.
Yeah.
So you try to understand the concept now. So the button is not related to your PLC. So the button is the function must be within the HMI settings. So what you want to do? Change language. Search for change language. Don't get it. Go to YouTube. Type TI Siemens SCADA or TI Portal SCADA change language button. Sure will have a video. If you don't get, message me. I will search for you. Search for you, I send you. That's the mostly I do that. Some of my participants will message me. In this week itself, Saturday, Sunday, I think. Yesterday was night message me. Today also one message me.
Yeah.
Always lah. So what I do, I also learn.
Mm.
I also can learn. So what I do, I ask something regarding there's an error. You go and want to download to the PLC lah. Do everything, but cannot scan the PLC. Cannot get the PLC. Then you know what I do? I tell him, is it the PLC IP address and laptop IP address? Is it the last number different or not? Then only, didn't change. You go and change, then okay. Sometimes the main thing they can do, the simple thing they forget.
Yeah.
Because you already opened the software, already want to do some changes, already want to download. But the moment of the download, no.
They made the application not change it.
Yes, they didn't realize that. Because you know why? The error, it won't show IP address different error. It only show cannot communicate.
People will take the wire.
Yes.
Internet fault.
Cannot communicate.
This happened before also. This my programmer, they will check. Hey, why is the issue? They unplug it, plug again. Unplug it, plug again. Hey, same issue. Okay, what's the issue?
看起来，如果讲房间灯没有开，看起来比较暗；房间灯开起来的话，那个纸看起来就比较透明。
Okay, good. Moses, you okay? Anna?
I'm okay.
I think any question again?
Try.
Sure, we have a question. Yeah. You know why I asked you regarding the background picture, right? I saw it's a Europe company, it's a German company. Their graphics very good. It's really good. Then after I came back from I just called my company. It's create this style. He told me that sometimes can, sometimes cannot, but he doesn't know. Then I said, whatever you can do it. Then after that, he only give me the logo like how something like this. I said, hey, this is like the like the kindergarten, How come you can put your screen like the kindergarten, you know what I mean, right? I said, you have to explore. I said, you must be explored. I said, this is what I know. I said, supposedly people can do what you cannot do. Something different already.
Yeah. But the thing is, if you put the pump picture, the tank picture for that from the Siemens one, that one can change color. But the picture you put cannot change color.
But
you can put the circle, square, that one can.
yeah.
Sure can. Let's say like you put your tank picture, example you have an actual tank. You take one nice picture of your tank. Okay, then you can see the tank, the pump, everything right. Near the pump, of course, you can change the color of the pump. So, but near the pump, you put an indicator. One circle, put a name, change color. That one can do. Yes. But if I use the graphic that is inside the PLC, the tank, everything, that one, the pump itself can change color. That's the difference. It depends on what the HMI offer you. I'm doing one project for the UTM, right? University. So they have a heater and a blower. So what happened? I look for the heater. They have the heater, but just the picture only. Means don't have cards, cannot change color. But luckily the blower, I find luckily I find one fan. That fan can rotate. That one not inside here don't have. Siemens don't have. I'm not sure I think
I saw before.
so it's
It's a rotating style.
rotating style. Only one, no. Only one picture. Only that picture can rotate. That's all. Others all got nothing. They have a valve picture, everything. Valve picture all it's not showing open close. It's just showing the color and the position. So what I put for the heater, what I do, I just put a picture. On top of the picture, I put like a circle. I then put a rectangle, change color. But for the blower, only nice circle, rotating one, nice one. So sometimes it depends. But sometimes you can download their graphics from Siemens if they have.
Okay.
Because I never done for Siemens, but I done for WinTech actually. I have download the graphic from their websites.
They mean the ultimately like the fan is
Yes.
you don't need to create like
No need to create something like that. They have some. You can download from their website. What they call libraries. Even the FBFC also you can download. They have some special FBFC for communication, this, that. You can download from their website.
Okay.
Download, just import, export.
Maybe we also can learn the export report.
So many things. That's why I said, if you want to explore TI portal, daily you can explore new things. Daily.
One thing. Why they said Siemens is complicated to learn?
Not complicated to learn.
They say
It's actually complicated to learn, where the memories. The same memory can use Boolean, word, double word, right?
Yeah.
So that's what normally confusing because some other PLC, Boolean is different. Let's say they just let's say that we talk about Omron. Omron is kind of similar, right? Let's say we talk about machine. Boolean means they just M only. If something is an integer or double word, they use D. So two different things. So when you key, okay, I know I want to use the memory bit in the so you use memory. If this one value, okay, I use D. So no worry. But Siemens only have 4 letters. I, Q, M, D. Additional got P, but that one they call pointer. Pointer means like a set of data. Like a set of pointer means a set of bytes. They use pointer. Other than that, they use the L. L means it's a local, that's all.
Then is like compare between Siemens and Omron.
Omron easy to learn.
Easy to learn. Why?
Not much functions. Not like that. Not much.
And also same will create the block.
Of course, all same.
But the block will be
Block
easy.
only function block. They have only function block. They don't have FC.
Oh.
But they call it different name. They call section. They have one section that is a main. You can add another section. Like what we do FC subroutine. What we do? We do the program. We add another FC, do the program, right?
Yeah.
So they don't call FC, they call section.
Also inside one file.
Yeah, it's one file. LMW also same. LMW, the main they call main. Others all they call subroutine. Can add many subroutine, but need to call in the main lah. Say like that we do. But Omron no need to call in the main. One by one, no need to call. It just work on you.
Oh, they mean no need to call.
No need to call. Just click one section. Okay, do the programming. Click one section, do the program. Let's arrange your programs lah. No need to call in the main.
Oh.
They also have FB.
But if let's say something like we create right the program but not necessarily need to use maybe we have to delete it in the Omron. Like ours one we have to call right?
Not necessary to call. So if let's say that FC suddenly don't want to use,
Yeah.
just leave it there lah. No need to call in the OB. Just leave it in the block. So the program won't run. Correct.
Yeah.
If this or if Omron, you cannot do that.
This one?
So you need to run. If no, you delete. Or
I
you interlock something.
something block there,
Block.
right? Normally open.
Block.
Cannot.
Cannot. The block itself, you go inside the block, do some programming to block. Or delete it. Same thing. Siemens is the thing is, Allen Bradley is easy to do programming. Easy to do programming. Because the terms they use are easy to understand. Because Allen Bradley is US.
Yeah. And very
So the terms they use is easy for us to understand. Anything want to learn, easy to understand.
for example. Ladder, I mean the
No, it's the same thing. Main function block, right? In Allen Bradley they call add-on instruction. Add-on instruction. Why in Allen Bradley? Because the timer, counter, the move, all that, right? They call instruction. So you add on a new instruction. Means your instruction.
What do you want?
Yes, that's what. Add-on. They call add-on instruction. New instructions. But in Siemens they call function block, which is we don't know. From the name we don't know what is that. We need to go explore. Then we know lah. Each PLC they have different lah. But I like Siemens. Siemens you can create one of structured program, and the software also is very powerful. Siemens you do the network. I mean just now we add the drive everything right. PLC drive everything right. In Allen Bradley, if you want to do that, it's another software. Not in the same Allen Bradley software. They call RS network. You need to open that. You need to do that. But TI portal, everything inside the TI portal. You don't need to go outside TI portal. Everything inside TI portal. Allen Bradley not that. Communication, one software. Programming, one software. Networking, one software. Expensive, Allen Bradley software.
Yeah, that's why.
The full version, professional version, full version of 34,000. Siemens, if you ask me, around 25 to 27. Siemens. Allen Bradley hardware was very expensive. The highest PLC I've seen in Allen Bradley, I think 80,000 plus. But most expensive PLC is the back off PLC. Actually, it's not a PLC. They call IPC, industrial PC. It's like a computer. It's this big. Just a CPU. But you can add IO card. But it's run inside there. It's run on Windows. Windows. So inside there got Windows. The software inside there got installed already. So you don't need laptop actually to program that PLC or any laptop. Just bring one mouse, one keyboard, one screen. You connect, you can program it. Because the software is already, because it's already Windows, right? The software is already built in inside. They're using HDD hard disk inside. Normal, not like normal memory. It's hard disk. Because inside that is running Windows.
Yeah.
Windows at the same time they run a program.
That's why I call it one supplier, right? They just nothing to do. No need to create, and because it's a big plant, right? They no need to do their program and They just go to the site, it's okay, 1 or 2 days settle already.
Yeah.
I said, oh, how come so fast? They just click, whatever, create. After that, run. Then okay, start, run. Any modification very fast. But the cost, I mean the license and everything is
Yeah, of course. Mostly expensive is the license. Siemens and Allen expensive is the license, hardware. Luckily 1200 is cheap. If no, very critical. Good training also. That's why the 1002 I have 6 units. First 1200, 1300 I can buy. So every few training I can buy one new. Already spoiled two.
Yeah, just question. Just now I try to create. I already have. I need 30 input and output is only 10. Your output
30 inputs.
Yeah, output is just like for the drive,
Digital.
for the motor, right? Okay.
Digital. Is it digital input, digital output?
Yes, correct.
Or digital input, digital output?
Yeah, correct.
Okay.
Then from the PLC, right? I choose the
One.
nearest.
1212.
No, I choose 1214 because my output I need more.
Input you need more.
Output I need more. Input I need more. Sorry.
How many input you need?
30.
30.
Then 14 is only 14.
14.
I need to add a card behind. At least an input for 16.
32 16.
16. Because they have a lot of slot. We can slot it
8 slot.
8 slot. Because the 1212 is only 2 slot.
Yes.
Not enough. Because I need analog also.
Oh, okay. Then of course.
I need analog also. That's why
Then 1214.
yeah, 1214. Then I put I insert the analog output because analog output I need 3.
Okay. So use the 4 A.
4 AO and AI I need 4 also.
4. So
But I also need to add. You know
4.
what? The machine, the 1214 only have 2.
Yeah, of course.
Then I need another 4.
Yes.
So after this I create out, right? I know how much IO I have already. The IDO,
Yes.
AIO, right?
Yes.
So this is the model.
The part number.
Part
how many
number.
you want to buy?
The serial number lah. The serial number we just follow, we buy it. That's it. Finish. But call the supplier of the system to check lah.
No, normally supplier they don't check. They follow what you the list for your list only.
When we add the new card,
They don't
no. When we add the new slot, we go to the PLC property, we will check where is the I start from. Or we can set also.
You can design and you can change also lah.
That means like from our PC we have the 14, we have really use all 14, then we can change right from there we start from I2 or something.
Yes.
Okay. There's no need to do some communication or what, right? We just like in the second plot, for example the extra okay, input number 15 for example is another one card. Okay, one slot. We just put in the input, the number, is it finished?
Yes.
You don't need like, we have to do slot or that slot.
No.
I calculate very expensive.
How much? Just give me the list, I check for you.
That
You WhatsApp me.
because this one I just want to try it for at least
For one project, is it?
not for one project, for I put at my shop. I mean office. If got any project, at least I can try first.
Then okay, if like that, actually okay, because you can buy like this on PLC.
Yeah.
If you want to buy input output card, it's up to you lah.
Yeah.
But if you buy AI card, you if
Yeah.
no, you can if for your practice lah, if you want to buy because you want to learn the additional also, right? So 1214, 1212, not much different lah.
Yeah.
It's a small amount only. 1214, 16 DI, 16 DO,
Yeah.
4 AI, 4 AO. Can buy or 4 AI one card, 4 AO one card.
Okay.
So total PLC on the IDO card.
They will 4, another 4 slot empty.
Yeah, of course.
Ah.
Can.
And
Or,
then later we get
you see, if you practice your main practice. I mean, like for you lah,
You have to focus.
because you want to for company.
And
You
also,
can teach others also.
yeah, and also like in the future, right, I have another one project or something, right? For this, at least I can put a lot of input there. I can try first, you know.
Yes. Okay.
I don't need that wait off. My card is not enough. I need to change or something. At least I can do some this kind of a button. Okay, and just try whatever I can try. Like, okay, setting. Then I upload. Then go to the field. I download it. Anything I can change from the touch screen. You just do the touch screen. Setting finish. Easier. You don't need to take time in the field.
Yeah, of course, that's what I do normally.
At least I try first, you know.
Yeah, of course.
Easier for me and good environment. You know, practice also.
Can.
Yeah.
Just give me the list.
Yeah, give you a list. And also you let me know the IoT they want and PT one.
Yeah.
In last, before MCO, I start know at IoT. But IoT, what I know the concept is like, okay, for example, your PC, PLC, need to give the internet. I don't need to go to the field, I don't need to go to your office, I don't need to go to your factory to check. I can go outside to check already. Whatever you want, or you want me to check, we also can check online. Also can keep the data also, daily data, like for example the bottle, how many bottle.
Data logging.
Yeah, then people like further their management also no need to go to the factory. If let's say they are overseas, they can online check. Why the output different?
Yes, of course. Can.
Sometimes the operator, their management lying like that. Oh yeah, today is good output. They check, hey, not late. Why? You get what I mean? Sometimes cheating because in the factory, if they say there's a big factory, they hardly to trace. They have to do daily report, you know.
Yeah.
If after 1 or 2 days, you want to trace back, it's very difficult. Very difficult.
That's why they use
Like
data logging.
yeah, because in the past experience, not me lah, it's one of my client. They just have an issue on the output, but they didn't do any data or something. Then they said, oh, daily is output is 10,000 for example. 3 days supposedly is 30,000, right? Then they find out, and the third day, only 15,000. Why? Why? But the report already mentioned daily is 10,000. Then they trace it, nothing. Cannot trace.
Yeah.
They say 10,000.
Because
Yeah.
the manual logging.
They say, yeah, 10,000. My one also 10,000. Good.
Just let me to fill up the evaluation form.
Yeah. Already got.
Oh, you put inside the bag.
No. I don't make it easier. Thank you.
So we take a group picture.
Yeah.
Fix it.
Because that's how I asked you regarding the IoT. If you have a class, can I buy to see my schedule also?
Yeah, you can check according to
Because
the schedule, you can
I asked him, this is a program, I think 2 or 3 months already, you know. I tried to arrange my schedule.
2 or 3 months is still okay. I have some client took 2 years for them to decide.
2 years now, too late already. I supposedly, like for example, when I ask something, for example, this month you have the class, I will plan. But for me, better this month, faster to settle it.
Yeah.
Then the last 2 months, busy I said, oh my god.
Because most of my clients who comes here are all working class. I cannot predict their schedule also, you know.
Yeah, cannot. You know my schedule is daily.
Yeah,
daily
it's
schedule.
also like us lah, project based.
I cannot assume like this week I'm very free, no.
Suddenly client call you already, you have to go.
You have to go. That's why this class I just arrange all my everything.
All your schedules.
It's 2 weeks ago, you know. After arrange, then I settle. Okay, don't disturb me in these 5 days.
You understand? Discuss.
Yeah.
That's why I write it below. I said, comments
We need more practice.
More practice, okay. Have you received an email?
Yeah.
I think
Yeah.
around 12 o'clock I have already sent to you an email with the digital copy of the cert and the promo code and everything.
Yeah.
You can just give us a review. You can review some ID and you will receive your free consultation all the time. However, because you will be holding my certificate, of course we're not going to let you go.
I believe so. We were taking more.
Okay, just wait for him, just wait for Mr. Divyan so we can just take a good picture with the certificate. Solid proof.
I think you went for smoking.
No. He just, I think, he went to washroom.
Smoke?
No. He went to washroom. He knows I have to take picture. Because you will be rushing after this.
How about you?
No, I'll be staying back over here because I need to send around. His bus will be around 7:45. And tomorrow we got training. On here. 2 bags for Alan Bradley under HRDCorp.
It's nice. For me, I don't know.
Me too.
Yeah.
Yeah.
Yeah, just here with the certificate. You can. Don't worry, your IC or that details all I will censor it. Yeah. There, come. There's only one person know your information.
No lah, you guys will be there either.
Don't worry, I think I will run over there. Run there or here? There or here?
Yeah.
Okay, I think, yeah, okay.
No, you'll be there.
No, I can stand there, no problem. Alright, and then that's the timer.
Okay.
Thank you very much. Thank you for choosing us.
Thank you so much.
Keep in touch.
Thank you so much. At least, maybe after a few months, I will learn the LW.
One at a time.
You know, because now I'm mostly using Omron.
Your company.
Yeah, correct. But Omron is not, I don't know the Omron. But I try to, but I know that Omron got a lot of issue. I don't know lah. I always got the issue that like the loss, the loss, something. So that's why I try to change
Siemens.
Belongs to TV.
And also, you know, right, this one I also call the party to do it. So that's why I always call it famous software. Yeah. The camera, I put there already.
Oh, okay.
I think I put there. Okay. This is analog. RX45 also is the same like lane cable. Ethernet port.
Okay.
But the communication is different.
Yes.
But the plus for the learning RX45 also have what?
RS45. Okay. More, you mean what to learn RS45 more fast?
Mobile, no, you know what, now my existing, right, mostly is using the RX45.
Okay. RS45, but RS45 is the communication. We call it as a communication cable lah.
Okay.
But what protocol you use?
I don't know.
So you need to
Protocol is new one.
like Modbus or
Mobile. It's only two cable. Only two cable.
So can be Modbus lah. So you need to
But I remember that there's a link, like there's a drill inverter, there was a link.
They give, I mean, they serve satay. You know satay, bro? How to say it? Satay, satay.
That is initial facility in Malaysia. You must try it. You using the stick.
Yes, you use the stick.
Okay, see you.
Soon see you again.
See you. Okay, sir. See you. Thank you for class. Thank you for using us. Keep in touch.
If I not, you know,
Yeah,
Thank you.
thank you. Okay, after this part, let's get into our proper direction. The flowing, what's right there? Mobiles or so that can.
But you see that which one is related to your field. So one to come from mobile to depend lah.
Yours again is the advanced, right?
You mean
Yeah, that is just the advanced only lah.
But as within 2 days, 3 days.
2 days, 3 days enough because you already know the basics, right? You basically already done the drive and everything. So we can go more into the drive, how to connect two drives, how to connect PLC to PLC communication, Siemens to Siemens PLC, how to data transfer, how to do cloud programming, how to do back server programming. Because that one all is more to, because you already done the data type, right? How to do addressing. So that one is more to settings. That one is not logic. No logic there. Right? It's more to setting. Okay, how to add drive, how to add a interface module. So how to do the setting, how to add how to do a web server.
There's not like.
It's similar like how we add this one.
Yeah.
How we add the HMI, how we add the SCADA, same concept.
There's an advanced lah.
Yes.
Okay, thank you.
Okay.
Okay,
Okay.
thank you very much. Thank you. So, what time I see you? Because of the people us to meet with them once around 9
right.
Okay, see
Thank
you.
you so much.
Okay, see you.
You might expect my messages.
Yeah, sure.
I did some help, I will visit.
Okay, sure.